If I could ask everyone to please silence their cell phones before we begin. And I need to do it myself too. Good morning. My name is Debbie Hersman, and it's my privilege to serve as the chairman of the National Transportation Safety Board. I would like to take a moment to introduce my colleagues, Vice Chairman Chris Hart and Board Member Robert Sumwalt. Welcome to the boardroom of the National Transportation Safety Board. Under the 1976 Government in the Sunshine Act, multi-member federal agencies conduct much of their business in open session. Therefore, board meetings are often called sunshine meetings. While the public is invited to observe the meeting, only the NTSB board members and staff will participate in today's discussions. Before we begin, I'd like to take a moment to make a few comments. First, I would like to recognize former board member Steve Cheelander. He's joining us in the audience today. Steve served on the board from 2007 to 2009 and was the on-site spokesperson for this accident. We're grateful to Steve for his tireless advocacy on behalf of the traveling public, and I'm so pleased that he could be here with us in the boardroom as we complete our investigation and issue recommendations. On behalf of the board, I would like to also extend my appreciation to the nearly 60 organizations and the scores of individuals who helped with this investigation. These include representatives from state, federal, and area-wide county and city offices, emergency responders, police departments, service organizations, and so many others. This accident involved an uncommonly large support team. Whether it was helping with the rescue and recovery operations, support efforts, or the overall investigation, your tireless cooperation and work were invaluable to us. Thank you. I also want to acknowledge the family members and friends of those who lost their lives on Continental Connection 3407. Over 60 family members are here with us in the audience today, and many others are watching from remote sites in Buffalo and Elizabeth, New Jersey via webcast. On behalf of all of the men and women of the National Transportation Safety Board, please accept our sincere condolences for your loss and for what you've endured since this accident. Our meeting today is being held to determine the probable cause of this accident, to consider safety recommendations so that accidents like this one do not happen again. We are aware that over the past year, many of the family members and friends, individually and collectively, have advocated tirelessly to promote aviation safety. We are encouraged by your efforts and want to assure you that the Safety Board is also committed to preventing similar tragedies. We convene today within 1 year of the accident. Concluding any investigation within 1 year is a challenge. And in fact, it has been over 15 years since we have both held a public hearing and completed an accident investigation in less than 1 year. The board made a commitment to those who lost loved ones, and that we would aggressively pursue this investigation. It is our staff who have done the work to produce this comprehensive report. On behalf of my colleagues, I would like to thank the entire team for your dedication and commitment in holding an excellent public hearing last May, and for concluding the investigation and presenting a report for our consideration in less than 1 year. The conclusions and probable cause and the recommendations we will discuss today are based on the facts of this particular accident. In other words, the scope of the report is defined by the facts obtained in this investigation. And what this investigation reveals is a picture of complacency that resulted in catastrophe. As we heard in public hearings back in May, this investigation also revealed a number of other issues such as code sharing and pilot professionalism, but these issues are really larger than the accident itself. Code sharing is a significant issue and something we believe is worthy of examination from a safety perspective as it relates to the overall commercial passenger airline industry. And that is why our staff has recommended that the Safety Board hold a symposium on code sharing, tentatively scheduled for later this year. The Safety Board has already scheduled a public forum on pilot and controller excellence and high standards for later in the spring. I believe that these events are critical to continuing to keep the public attention and pressure on the aviation industry to make positive improvements in the overall safety of our national air transportation system. The report that we're considering today concludes our accident investigation, but in many respects it is just another beginning. The beginning of the Safety Board's work on these and other critical safety issues. One final comment before we begin the presentations. During our conversations today, some disapproving and even harsh statements may be made about the actions of the Colgan Air flight crew, individuals who also lost their lives in this accident. I believe it's incumbent upon us to remember that as we speak about the flight crew, that we remember we're speaking about individuals, a father, a wife, a parent, a husband, a child. The actions in the last minutes of their lives are not representative of the whole of their lives and what each of them brought into the lives of others. This may be very difficult for some to hear, but it's absolutely critical that we have an open and candid discussion so that we can make recommendations to improve aviation safety. It is not the Safety Board's role nor our intention to make any judgments beyond their performance as it relates to this accident investigation. Now, as we move to the report. A few weeks ago, the Safety Board staff submitted the following report for the Board's consideration. Notation 8090A, Aircraft Accident Report, Loss of Control and Approach, Colgan Air Incorporated, operating as Continental Connection Flight 3407, Clarence Center, New York, February 12, 2009. The board members have had the intervening weeks to study these documents, and while we might have met with staff individually, today is the first opportunity for all of the board members to meet together to discuss the issues contained in the report. During this meeting, the board members will hear staff presentations addressing the primary issues identified in the investigation. We will be soliciting staff comments and explanations on many issues. Once we have discussed the draft report, we will then consider the conclusions, probable cause, and recommendations proposed by the staff. Sometimes all or part of a draft conclusion, probable cause, or recommendation is revised or rejected by the board members. This is because these are the board's actual deliberations. That is the purpose of the Sunshine Act, to provide the public with a window into our decision-making process. Approximately 30 minutes after the meeting, copies of the abstracts containing conclusions, probable cause, and recommendations can be obtained from the Safety Board's Public Affairs Office. Dr. Meyer, will you please introduce the staff?
Yes, ma'am. Good morning. Seated to my left is Tom Howder, the Director of the Office of Aviation Safety. Next to Tom is Lorenda Ward, the Investigator-In-Charge. Then Dr. Evan Byrne, Human Performance Group Chairman. Captain Roger Cox, Operations Group Chairman. And next to Roger is Dr. Kevin Renzi, Aircraft Performance Group Chairman. Seated behind him is Jeff Marcus from our Office of Safety Recommendations and Advocacy. To his left is Scott Warren, Systems Group Chairman. Scott's left is Karen Stein, the report writer. Then Dr. Joe Colley, the Director of our Office of Research and Engineering. And seated next to Joe is Jim Cash, who's here as a recorder's expert. And next to Jim is Gary Halbert, our General Counsel. And finally, Tom Zoller, our Executive Officer. Tom Howder has the first presentation.
Thank you. Good morning. The aviation staff is pleased to present to the board the report on the accident involving Colgan Flight 3407 near Buffalo, New York. This investigation was very detailed, and there are numerous issues identified and thoroughly examined. In the report, staff is proposing 23 safety recommendations to the FAA in the areas of prevention of flight crew monitoring failures, pilot professionalism, fatigue, remedial training, pilot training records, airspeed selection procedures, stall training, FAA oversight, flight operational quality assurance programs, the use of personal portable electronic devices on the flight deck, the FAA safety alert for operators process, and weather information dissemination. However, there are two issues that are not fully addressed in the draft report. These issues are professionalism and code sharing agreements. Because these issues go beyond the Colgan accident, staff believes that additional fact-finding is necessary. In previous accident and incident investigations, staff has noted issues regarding professionalism with both pilots and air traffic controllers. Professionalism issues are not limited to specific airlines, hours of experience, salary, or even the nature of the job, and can be as insidious as fatigue and leading to accidents and incidents. Therefore, staff has recommended, and the board has approved, holding a forum on high standards for pilots and air traffic controllers. Because Colgan was involved in a code-sharing agreement with Continental Airlines, staff examined issues associated with airline code-sharing and complexities of code-sharing agreements. In some cases, code-sharing allows a major carrier to expand its routes to airports that would otherwise not be profitable. In other cases, code-sharing allows a smaller carrier access to a major carrier's reservation and marketing system. Code-sharing involves both domestic and international carriers and is often invisible to the public. Because code-sharing issues are so broad and go beyond this accident, staff has recommended and the board has approved holding a symposium later this year to explore in detail the issues involved with code-sharing arrangements. Completing this report in less than 1 year required considerable staff resources, not only because of the complexity of the accident, but also because there were other investigations that required staff's attention. For instance, last year, our operations and air traffic investigators, a total of 7 people, worked a combined 101 investigations, accumulated 349 days on travel, and logged about 1,700 hours in overtime. Since the Colgan accident, the aviation staff has completed 5 major reports, held 4 public hearings, including the one for the Colgan accident, launched on 2 major accidents, launched on 153 regional accidents, launched on 9 foreign accidents, and developed 127 safety recommendations. In the coming year, the aviation staff is on track to deliver 7 additional major reports to the board for its consideration. Staff's work on the Colgan investigation will not end with today's meeting, as we will continue to push for the implementation of the safety recommendations that the board adopts today. With that, I'd like to turn the presentation over to the investigator-in-charge, Ms. Ward.
Good morning, Chairman Hersman, Vice Chairman Hart, and Member Sumwalt. On February 12, 2009, about 22:17 Eastern Standard Time, a Colgan Air Bombardier -A Q400, operating as Continental Connection Flight 3407, was on an instrument approach to the Buffalo Niagara International Airport in Buffalo, New York, when it crashed into a residence and Clarence Center about 5 nautical miles northeast of the airport. The 2 pilots, 2 flight attendants, and 45 passengers aboard the airplane were killed. 1 person on the ground was killed, and the airplane was destroyed by impact forces and a post-crash fire. Variable periods of snow and light to moderate icing were expected during the accident airplane's approach to Buffalo. Because of the expected weather during the climb out of Newark to their cruising altitude, the captain, who was the flying pilot, set the reference speed switch to the increased position which was appropriate for the flying conditions. For the Q400, turning the reference speed switch from the off to increased position lowered the angle of attack reference for the stick shaker activation and raised the position of the load speed cue on the pilot's indicated airspeed display by 15 knots. This action ensured that the airplane would have the same or greater performance margins relative to the stall speed while operating in icing conditions, as long as the landing airspeeds were appropriately increased to remain above the stall warning threshold. The first officer, who was a monitoring pilot, obtained the landing airspeeds for non-icing conditions. She did not enter the keywords that would indicate that the flight was in icing conditions. Therefore, the mismatched landing speed of 118 knots that the flight crew set was 13 knots below the stick shaker activation speed of 131 knots. When the airplane reached 131 knots, the stick shaker activated and the autopilot disengaged. A review of performance data indicated that the airplane was not close to an actual stall because the airplane had minimum ice accretion, but the flight crew was unaware of that fact. The captain reacted to the stick shaker by pulling back on the control column and applying power short of the rating detent. pulling back on the control column increased the angle of attack, pitch, and load factor, causing the airplane to enter an accelerated stall. During the stall sequence, the stick pusher fired 3 times to decrease the angle of attack. However, after each activation, the captain continued to pull back on the control column, which exacerbated the airplane's stall condition and prevented a potential recovery. A similar animation of the last 2 minutes of the accident flight was shown at the public hearing and will be shown again to orient the audience. The top half of the screen shows the 3-dimensional model of the airplane and its motion. Superimposed over the model is the CVR text. Time is shown in the middle of the screen on the right-hand side. My glasses on. We have airspeed indicated as text. We have the airspeed tape, low speed Q, the attitude indicator, altitude indicated as text. You have the altitude tape and then also the rate of climb. We have heading indicated as text. You have stick shaker and stick pusher indicated as text and will change to amber once it's activated. We have the control column and control wheel, which will show the control wheel going right and left and column going fore and aft. We have the rudder pedal input, power levers, condition levers, and the flap handle position, autopilot indicated as text, and landing gear indicated as text. We'll now pause in case anyone would like to leave before the animation is shown. Antoine, can you go ahead and show the animation, please? As you can see, our animation does not depict the weather or visibility conditions on the day of the accident. Also, sound is not included on the animation. If you look in the lower left-hand corner of the screen, you can already see the low-speed Q is visible. The autopilot is on. The altitude hold mode is active. They're at about 2,300 feet. The condition levers have been pulled back to 0. Flat panel's at 0. And if you look at the control column and control wheel, you can see it's pretty much in the neutral position. The black shadow there indicates neutral. At this time, the captain's asked for the flaps to be moved to the 5 position, and they'll go from 0 to 5. The Buffalo approach controller has now asked them to make a left-hand turn to heading 260, and they've been cleared for an ILS approach to runway 23. You can see as they're making the left-hand turn that the low-speed Q will temporarily disappear from view. They now have wings level. They're on a heading of 260. You can look at the attitude indicator. You can see that the pitch is below 5 degrees, right around 2 to 3. Once again, the control column is pretty much in the neutral position. Power is being pulled back a little bit closer to flight idle. Gear is going to come down. And you see condition levers have now moved to max. At this time, you see the low speed Q is now back and it's visible. Airspeed is decreasing. It's moving towards the indicated airspeed. He's now asking for the flaps to go from 5 to 15. You can see as the flaps are coming back, the stick shaker comes on. The control column comes back. Power goes forward, but it's short of the rating detent. You have the stick pusher activate for the first time. Control column still being pulled aft. Flaps have gone to 0. Shaker activates a second time. Gear comes up. Control column still back, and the shaker fires a third time. It's 27 seconds from when the stick shaker activates to the end of the recording. The team was on scene for 8 days, documenting the wreckage, conducting interviews, and collecting records related to the accident flight, airplane, and crew. 3 months later, a 3-day en banc public hearing was held in Washington, D.C., with former acting chairman Mark Rosenkerr presiding over the hearing. The safety issues discussed at the hearing were the effect of icing on the airplane performance, cold weather operations, sterile cockpit rules, flight crew experience, fatigue management, and stall recovery training. Early in the investigation, we were able to identify that the flight crew and the airplane were properly certificated. There was no evidence of any pre-impact structural, engines, or system failures. ATC was not a factor in the accident, and the accident was not survivable. The weather on the night of the accident was typical for the Buffalo area and the time of the year, and the ice accumulation did not affect the ability of the flight crew to fly and control the airplane. Although weather did not affect the performance of the airplane, it is important for flight crew members to have complete and accurate weather documents to assist them in their pre-flight and in-flight decision-making, and staff has proposed a recommendation in that area. Also, staff is recommending a change to icing definitions to include accretion rates and specific pilot actions that would help pilots more accurately determine the icing conditions to report in PIREPs and more effectively respond to those conditions. Because staff was able to rule out several factors in this accident, this investigation focused on human performance and operational factors, and all the presentations and the majority of the recommendations will fall into those categories. We'll start with a discussion of the flight crew's response and their monitoring failures, to be followed by airspeed selection procedures for landing and in icing conditions. We'll look at stall training, including the difference between wing and tailplane stalls. We'll look at training records and remedial training programs to include discussion on the captain's disapprovals. We'll also talk about pilot professionalism to include discussion on sterile cockpit, leadership training, and the use of personable, portable electronic devices. We'll go into fatigue and commuting. And finally, we'll look at the Flight Operational Quality Assurance, or FOQA programs, and the FAA's oversight and its process for transmitting safety-critical information by SAFOs. Before we start the presentations, I would like to thank former board member Stephen Sheelander, who is a board member on scene, and all the NTSB investigators and staff who have supported the accident investigation. Parties to the investigation were the Federal Aviation Administration, Colgan Air, the Airline Pilots Association, the National Air Traffic Controllers Association, and the United Steelworkers Union. As the state of design and manufacture of the airplane and engines, the Transportation Safety Board of Canada participated in the investigation. The Canadian accredited representative was assisted by technical advisors from Transport Canada, Bombardier, and Pratt & Whitney Canada. As the state of manufacture for the propellers, the Aircraft Accident Investigation Branch from the United Kingdom also participated. In closing, I would like to thank the numerous state, local, and federal agencies that were not parties to the investigation, but played an important role in assisting our team with our on-scene activities. Madam Chairman, this concludes my presentation, and if there are no questions, Dr. Byrne is ready to begin his presentation on the flight crew response and monitoring failures. Thank you.
Please proceed, Dr. Byrne.
Good morning. I will address the pilot's failure to detect the impending onset of the stick shaker and their inappropriate response to the stall. The approach phase of flight requires heightened vigilance as it involves changes in the airplane's altitude, heading, speed, and configuration. The captain, as the flying pilot, had the primary responsibility to monitor the instruments, and the first officer, as the monitoring pilot, was responsible for providing backup and corrective input. As the captain slowed the airplane, airspeed information was available to both pilots on the left side of the primary flight displays. This airspeed display contained the indicated airspeed, an arrow showing whether airspeed was increasing or decreasing, and a low-speed cue providing a visual warning of the stick shaker activation speed. pilots need to maintain vigilance to ensure that airspeed is kept above the low-speed queue. To perform this task, pilots compare the actual airspeed with the desired airspeed and consider airplane configuration, pitch, and power. As the airspeed continued to slow, neither pilot remarked or took action consistent with recognition of the increasing proximity of the low-speed queue to the indicated airspeed during an 18-second period. This salient cue, signaling impending stick shaker onset, should have elicited prompt corrective action from either pilot. There was adequate time for the crew to take action before the stick shaker. As the flying pilot, the captain should have been conducting an instrument scan and should have been alerted to the rising position of the low-speed queue. However, there is insufficient evidence to determine where he focused his attention during this period. As the monitoring pilot, the first officer should have noticed the captain's error. However, the first officer was performing tasks that directed her attention away from the primary flight display, reducing opportunities for timely recognition of this event. Both pilots missing this cue reflects a breakdown in their monitoring and workload management. There are ways to improve pilots' monitoring skills. The NTSB previously issued safety recommendations about training pilots on monitoring. For example, Recommendation A0713 asked the FAA to require training programs be modified to teach and emphasize monitoring skills in workload management. Although the recommendation is classified open acceptable response, the FAA has yet to complete action in this area. The captain's aft control column inputs in response to the stick shaker led to an aerodynamic stall. The captain added power but did not advance engine power levers to the rating detent, and the first officer did not detect this error. Stall recovery procedures at Colgan were crew-coordinated maneuvers involving a sequence of callouts and commands. Neither pilot made any callouts or commands associated with the company's stall recovery procedure. Q400 flight simulator observations showed that Colgan's recovery procedures after initial stick shaker activation did not require exceptional skills or inputs on the flight controls. During the stall event, the control column was never pushed forward enough to prevent or recover from a stall. The captain's actions in response to the stall warning were not consistent with any trained procedure or the basic requirements for recovery from an aerodynamic stall. His failure to make standard callouts or even a declarative statement associated with the recovery attempt further suggests that he was not responding to the situation using a well-learned habit pattern. Thus, the captain's improper flight control inputs were instead consistent with startle and confusion. The captain had a history of training failures indicating weaknesses with instrument flying skills, which may have contributed to his deficient performance during the stall event. Staff also evaluated the first officer's actions in raising the flaps and her suggestion to raise the gear, neither of which was consistent with Colgan's stall recovery procedures. These actions could have been an attempt to undo her last action, a misinterpretation of the event as a tailplane stall, or an attempt to perform portions of the stall recovery procedure in the absence of the captain's input. Ultimately, the reasons for the first officer's actions could not be determined from the available information. Captain Cox will continue this presentation.
Good morning. I'll discuss airspeed selection procedures first, and then stall training procedures. Airspeed indications on a Q400 are located on the left and right primary flight displays. Two bugs, which are target speed references, indicate the airspeeds that may be programmed for landing. At Colgan, those bugs are set to VREF and VGA, that is, landing speed reference and go-around speed reference. The bugs are set manually by each pilot using a rotary knob located on the forward panel. The ice protection panel, which is located on the overhead panel on the captain's side of the cockpit, includes a ref speed switch that can be set to the increase or off positions. According to Bombardier's Q400 airplane flight manual, the ref speed switch must be turned on in icing conditions and may be turned off when the airplane is free of all ice. The ref speed switch, when set to the increased position, advances the stall warning so that the stick shaker would activate at a lower angle of attack. As you heard earlier, the airplane would have the same performance margins relative to the stall speed during operations at icing conditions as it would have with a clean, that is, no ice accretion configuration. Because the stick shaker would activate at a lower angle of attack with the ref speed switch set to the increased position, pilots need to increase landing airspeeds between 15 and 25 knots, depending on the flap setting, to remain above the stall warning threshold. The appropriate speed increase for the accident flight was 20 knots. Colgan used AIRCARS, a data link service, to obtain landing performance data from a remote server for its Q400 airplanes. The server computed landing airspeeds and landing distances and returned the information to the airplane within 30 seconds. Required crew entries were airport, runway, and airplane gross weight. Other entries were optional from the standpoint of the performance computer system. The keywords icing and e-ice were available to be entered in the optional remarks area. Icing was to be entered when the airplane was in icing conditions, and e-ice was to be used to account for en-route ice accumulation. Either entry would result in an increase in the airspeeds for landing. This is a copy of the actual downlink from the accident aircraft to its performance computer. The downlink showed no icing or e-ice entry in the optional remarks field. Had either icing or e-ice been entered, the VREF and VGA returned by the performance computer system would have increased by 20 knots. An increased ref speed indication would have appeared on engine display during the flight when the switch was set to increase. However, neither pilot mentioned that indication or the status of the ref speed switch during the flight. The normal checklist made only one reference to positioning the ref speed switch, which was on the after start checklist, and made no reference to the switch thereafter. References to the ice protection system were made on the climb and cruise checklist, but these references did not explicitly instruct crews to check the position of the ref speed switch at those times. Colgan's procedures did not mention cross-referencing the airspeed bug settings with the ref speed switch position, and did not discuss the early stall warning that could result from setting normal VREF speeds with the ref speeds switch in the increased position. The company corrected these items in 2 bulletins issued after the accident. The first bulletin added 2 warnings and 2 cautions, and the second bulletin added ref speed switches required to the approach checklist, with both crew members responding. The second bulletin provided guidance to flight crews, including a requirement to use only VREF ice and VGA ice with the ref speed switch to the increased position. Colgan's ground school curriculum covered the function of the ref speed switch, but not its actual use. For example, the training slides on AIRCARS, line-oriented flight training, situational awareness, and winter operations did not discuss the use of the ref speed switch, even though it would have been useful for each to do so. Neither the training manual nor the simulator training modules mentioned the ref speed switch. Colgan issued guidance after the accident to inform its crews about the relationship between the ref speed switch and the airspeed bug setting. The guidance explicitly stated that if VREF is used for landing, then VREF switch must be in the off position, or a stall warning might occur at an airspeed higher than VREF. Staff has proposed a recommendation in this area. I'm now going to address industry stall training as well as Colgan's program. Air carrier pilots are trained on approach to stall, which requires recovery with minimal altitude loss. This is a requirement of the FAA practical test standards and applies to all airline training. Most turbine engine airline aircraft have sufficient power to recover from a near-stalled condition with full power and little pitch change. However, altitude loss standards are not an appropriate method for determining if a pilot can recognize and properly respond to a fully developed stall. Once an actual wing aerodynamic stall has occurred, positive nose-down control force is necessary. Colgan simulator training generally conformed to standard industry practice with regard to stall training. Each pilot flew the required 3 types of approaches to stall, sometimes known as the stall series in the simulator, and performed both as the pilot flying and the pilot monitoring. Pilots were checked on their ability to recover from an approach to stall. The investigation found 3 possible reasons why the company's industry standard stall warning may not have been, stall training may not have been sufficient to prevent the captain from improperly reacting to this stall warning. First, during Colgan's simulator training, the ref speed switch was not set to the increased position. Second, approach to stall training was not conducted with an element of surprise, but was done as a pre-planned proficiency maneuver. Third, simulator training did not involve autopilot disconnect. In addition, simulator training did not address actions needed to recover from fully developed stalls. Air carriers are currently not required to conduct their stall training under any of these conditions. In a bulletin issued after the accident, Colgan modified its stall recovery procedure to include the need to reduce pitch as well as to increase power. When he flew the Saab 340, the captain received exposure to the stick pusher during ground checks, and he might have received some simulator training on the pusher. However, pusher training was not consistently provided to Colgan's Q400 pilots. A Q400 check airman said that about 75% of the pilots who were shown the pusher in the simulator would actually try to recover by overriding the pusher. Although the FAA said that it planned to reconvene the working group that developed the airplane upset recovery training aid to study possible stick pusher training requirements, when the most recent revision to that publication was issued in November 2008, pusher requirements were not included. Flight crew training on full stalls and recoveries has not previously been included in simulator training because of industry concerns about lack of aerodynamic model fidelity in the post-stall flight regime. However, advances in technology can allow post-stall aircraft behavior to be modeled in simulators. The accident crew had seen a NASA-produced video on tailplane stalls and its ground training. The video's intent was to enhance a pilot's ability to understand and assess hazardous icing conditions, but it also included a segment on tailplane stalls and provided a recovery procedure. The recovery procedure shown in the video is basically the opposite of the wing aerodynamic stall recovery. The video showed that a crew should pull back on the control column, reduce flap setting, and in some cases, reduce power. Officials from Bombardier said that the Q400 was demonstrated to be free from tailplane stalls during its initial certification. However, the company had not provided operators any formal document saying so. Finally, the FAA's manager of air carrier training said that none of the airplanes currently being operated under 121 were susceptible to tailplane stalls. Staff has proposed recommendations in this area, and that does conclude my remarks. And we're ready for any questions you may have.
Thank you, Captain Cox and Dr. Byrne. You know we have a lot of questions for you. Member Sumwalt.
Well, thank you and good morning. I know that for many of you in this boardroom and many of you watching remotely, the last 355 days have been a living nightmare, a living hell, and I deeply regret your pain and your loss. Our job at the Safety Board is very clear. We are here to find out what happened so that we can try and prevent it from happening again. We have a saying at the NTSB. It's on the back of a little coin that we have, and it says, "From tragedy we draw knowledge to improve the safety of us all." And I do believe that this investigation will go a long way into turning this tragedy that you have suffered into something that will improve the safety of us all. I know over the last year, many of us have developed preconceived notions about what may or may not have happened on this flight, and I know that I had formed some myself. But after studying the facts, like the facts contained in this 270-page draft report, the facts like listening to the cockpit voice recorder, the facts like pouring through hundreds, if not thousands of pages contained in the public docket. When I look at the facts, I realize that some of my preconceived notions may have been incorrect. There may be aspects of today's board meeting that will surprise some. They may even disappoint others. But our mission, our job at the Safety Board, is to conduct a thorough and an unbiased investigation and look at the factual evidence and then conduct sound analysis of those facts. And again, the overall objective, find out what happened so we can prevent it from happening again. The draft report, I think, goes a long way towards doing that. The draft report, as it sits here on the table today without the board deliberation, contains 23 draft recommendations aimed at preventing accidents like the one that was suffered in Buffalo. But I suspect that by the time I and my colleagues and I get through with the report, we will even have additional recommendations added to that. But I am very confident that through this thorough investigation, we will be able to turn tragedy into triumph. And I thank the staff for your hard work. Ms. Ward, I want to ask you, the chairman outlined the extenuous, the extreme time frame that you were under. You did conduct a 3-day public hearing in May. A lot of writing on this report, a lot of analysis. Has the compressed time frame in any way compromised the ability of your team to conduct a thorough investigation?
I could answer, in my opinion, I say no, but I'll defer to my boss.
Well, I want to know your opinion because you're the investigator in charge and you work for him, so I want to know your opinion.
I do not. I had a great team to work with. They put in the required amount of hours that was needed to produce a quality report. I think that, a lot of attention is given to the fact that we did do it less than a year, but I would compare it to the ones that took 3 to 6 years. I think we have everything that we need in this report.
Thank you. And Mr. Howder, to follow on to that, please.
Well, I agree. I think it's a very thorough, detailed report. Nothing was left that we couldn't cover. Obviously, we mentioned before in professionalism and co-sharing. Those are broad issues we want to go into. However, the investigation itself was very well done. I disagree somewhat with Ms. Ward. I think people put in extraordinary hours on this. A lot of overtime was done, and people missed a lot of holidays to put this together.
Thank you. And I want to applaud staff, by the way, Mr. Howder, for not only the investigation, but the foresight to say that the issues of this investigation reach out to this issue of high standards for pilots and controllers, and they also have tentacles into code sharing. So I appreciate your foresight into that, and you're bringing forward to the board to approve conducting forums and symposia on those areas. Investigators oftentimes say that an investigation looks at the human, the machine, and the environment, and I think that probably oversimplifies things, but just to provide some structure to my line of questioning, I will get into those. I will start in reverse order. And Dr. Renzi, we heard a few minutes ago that the investigation basically concluded that the aircraft did have some ice on it, but that ice did not impact or affect grossly the aerodynamics of the aircraft, and I'd like to know more about that, please.
Certainly. Don, could you bring up backup slides? If you don't mind, I'd like to use a couple of slides to facilitate this discussion. All right, well, first of all, there was an aircraft performance group, and the group defined two goals pertinent to this particular discussion area. The first was to quantify the level of ice accretion on the aircraft, and the second was to try and determine the effects of that ice on the aircraft performance capability. Now, the group uses scientific methods and factual evidence to conduct its work. So the basis for the conclusions that I'm going to discuss start with the flight data recorder and the cockpit voice recorder data. We also used an engineering simulation model for the aircraft, for the Q400 aircraft, which was supplied by Bombardier. It included aerodynamics, engine and flight controls models. And then in addition to that, we looked at the stall protection system design specifications, which gave us insight into the stick shaker and stick pusher criteria for this aircraft. So to answer this question about ice accretion and its effects on performance, 4 methods were considered. The first was to calculate the incremental lift and drag on the aircraft relative to a baseline clean aircraft, a clean aircraft with no ice accretion. So we're looking at incremental lift and drag required to match the airplane motion. And this was done during the 2-minute time frame prior to the stick shaker event, and it includes the aircraft as configured with flaps retracted and gear retracted through the transition to flaps 5, then into the transition with gear deployed, and finally the initial transition toward flaps 10. The second method was to estimate the equivalent Appendix C ice load on the aircraft. The Bombardier engineering model has a scale factor in it which is designed at one end to represent a clean aircraft and at the other to represent the ice load that the aircraft is certified to carry based on the holding configuration with flap 0 at holding speeds. The third method that was evaluated was to compare the stall angle of attack for this aircraft based on the maximum load factor that was developed prior to the G-brake and the roll-off, and to compare that angle of attack to the criteria for stick shaker and stick pusher for this aircraft. And finally, the group evaluated several alternate control input scenarios where control input strategy, engine power, and equivalent ice accretion variables were varied. Don, next slide, please. So the short summary of the group's efforts is as follows. First of all, there was no significant lift degradation or increase in drag in the normal flight regime in this 2-minute period evaluated prior to the stick shaker. Second, the level of ice accretion was equivalent to about 20% of the certified performance level. So while there was a degradation in aircraft performance due to ice accretion, it was on the order of 20%, which is at the lower end of the scale, well within the certified capability of this aircraft. Third, the actual stall angle of attack was close to the clean wing, where clean wing here is a reference to no ice accretion. So it was close to clean wing performance level, and I have a slide to try and illustrate that. Fourth, the airplane had sufficient performance capability to return to a safe flight condition, and multiple recovery scenarios were possible for this aircraft. So here's a summary slide related to the stick shaker, stick pusher criteria, and it has a fair amount of detail, so I'm just going to step through it step by step. So Don. So first of all, looking at the horizontal axis, we have increase in angle of attack from left to right, and on the vertical axis we have increasing lift coefficient from bottom to top. The white curve that you see there basically can be interpreted as you increase angle of attack, you get increasing lift, and nature has its limits, so there's a point where there's a peak in the curve and then a drop-off. So this next slide, the color graduations are intended to communicate the normal flight regime in the blue and green color band, that general area, increasing toward the maximum lift as we proceed toward yellow and orange and into red. And then as we go to the latter part of the red toward the right and into the magenta, the stall area, the stall angle of attack. And you can see that lift eventually will decrease with increasing angle of attack in the stall region. So the next point here, I should note that this graph is not to scale. The next point represents stick shaker for the icing condition. This would represent the stick shaker warning level with the ref speed switch set to the increase position for this aircraft. So it occurs at a certain angle of attack. The next point, stick shaker with no ice, you see that it falls toward the right at a higher angle of attack. And down the next point, please. The maximum lift point is to the right of that, in the orange, the junction between orange and red, if you will. And then finally, the condition for stick pusher for this aircraft, which is a post-stall event on this aircraft. It is a stall recognition device. And finally, we add the point for the accident flight, again, this point is defined by the point where the aircraft develops maximum load factor prior to the G brake and aircraft roll-off. The bands that you see there are intended to communicate the performance level for a clean wing aircraft. A clean wing aircraft is designed such that stall warning or stick shaker occurs prior to the maximum lift that's developed. So the horizontal bars there indicate the region between stall warning for a clean wing and maximum lift. And for this aircraft, when we see maximum load factor prior to the G brake and the roll-off, we see the aircraft is somewhere between stick shaker and maximum lift capability. And it's based on that assessment that I made the comment that it's close to a clean wing performance level.
Thank you for walking us through that, Dr. Renzi. I appreciate that. So if I were to sum it up, it would appear that and I want to make sure I'm saying this properly, it appears that the aircraft did have some ice on it. However, that ice did not affect the wing significantly. In fact, the wing performed almost the same as if it was a clean wing meaning without any ice at all. Did I say that correctly?
That's correct. The practical reality is that if you stay at angles of attack that are well below stick shaker for icing or stick shaker for no ice, the pilot won't have any perception that there's any performance degradation whatsoever.
So we have a draft finding: the minimal aircraft performance degradation resulting from ice accumulation did not affect the flight crew's ability to fly and control the aircraft. And do you agree with that?
I do. That's supported, among other things, by the alternate control scenarios that were evaluated.
Thank you. Thank you, Madam Chairman.
Thank you. Vice Chairman Hart.
Thank you. I would like to join Member Sumwalt by extending my sympathies and condolences to the family and friends of this tragic mishap. I know this has been a difficult time for all of you. We're trying to do our best to learn what we can from it to try to keep it from happening again. I would also like to join Member Sumwalt in congratulating the staff on doing such a thorough and detailed job. Of course, you always do that, but doing it in such a short period of time and so that we could have it as quickly as we could. I have a third, I guess I agree with Member Sumwalt in saying this accident was a real eye-opener in many respects, and to me it was an eye-opener with respect to the behavior of the pilots, especially the captain. And what it brings to mind for me is one of my overarching concerns that we in the civilian aviation world are losing the benefit of the formerly robust pipeline of military trained pilots that we used to have. The military was famous for world-class training, and not only that, but they had a very sensible and robust washout mechanism to take people out of the system who just did not have what it took to be a good and competent pilot. Unfortunately, in the civilian world, our washout system is not quite so good. For example, our standards are, if you meet the standards, you can have a license. It doesn't say if you pass the test the first time, the third time, the 8th time. It doesn't say how many times you can flunk the test. It just says if you pass the test, you're in. And if a pilot who didn't pass the test, if a pilot who did pass the test was relieved of duties for somebody's judgment that that pilot was not a competent pilot, they would probably lose that battle in court. So I commend the staff for recommending that we convene a pilot and controller excellence symposium, because that's certainly one of the huge issues we have to look at is in this new environment of not having the world-class training from military pilots that we were used to having. How do we respond to that situation, and how, for example, do we take pilots out of the lineup who should not be in the lineup even if they can pass the test after the 13th try? We need to include the military in that because they have extensive experience in how to determine who should continue and who should not, and also we know that some airlines around the world have started similar programs to actually train people from the beginning, ab initio training, and they also have had to face that dilemma of is it enough just to pass the test if there have been multiple failures before that, and to take people out of the loop if they are not competent and should not be continuing to fly paying passengers. So this was an eye-opener for me as well, and I commend the staff for recommending that Pilot and Controller Excellence Symposium, and I look forward to participating in that. I have a few questions relating to the presentations that we heard this morning. Those were all excellent presentations. One is, I'd be interested on the tailplane stalls. Did the NASA films indicate that there's any advanced aerodynamic or other warning to let a pilot know that they are approaching a tailplane stall?
Yes, the video was very explicit in explaining the kind of information that you would have in advance for a tailplane stall. One of the most important ones is that this tends to happen at a somewhat higher speed. It also indicated that you could get considerable vibration that you would be aware of. So there were a number of prior indicators that were indicative of a tailplane stall. Also, you needed to be aware of the type of airplane you were in and the environment you were in, typically, which would involve icing affecting the tailplane.
And I understand, correct me if I'm wrong, that this manufacturer said that this airplane was not susceptible to tailplane stall.
We learned that in the public hearing and during the course of the investigation. However, they didn't explicitly make that clear in the material that they presented to operators.
Do you know if the pilots were informed, of the pilots of this airplane, not these two pilots, but I mean the pilots who flew this airplane for this carrier, do you know if they were informed that this airplane was not susceptible to tailplane stall?
We did 65 interviews, and we talked to many pilots at this airline, and we got a wide variety of responses indicating that pilots were really confused as to whether or not the airplane was susceptible, and if so, what the proper response would be.
Was the was the previous airplane that this pilot flew, the Saab 340, was that susceptible to tailplane stalls?
In its most early configuration, the Saab 340A, originally it was. FAA did a study in the 90s and put out an airworthiness directive that made a physical correction to the airplane. And so the subsequent models, including the ones flown at Colgan, nominally were not susceptible to tailplane stall.
Do you know if there was any training or any messages from the manufacturer regarding the susceptibility of the Saab 340 to tailplane stall?
We did see a Saab video that addressed tailplane stall on Saab airplanes. It was specifically directed to the early models, and that video is still available out there.
Okay, what I'm trying to get to is whether you have any sense that this pilot's previous experience with the Saab 340 might have led him to believe that the Bombardier was also susceptible to tailplane stall.
I think not only this pilot, but all the pilots at Colgan probably, and many throughout the regional airline industry, have been introduced to these videos, but typically not in formal classroom training or informal simulator training, typically by way of video or word of mouth or crew room discussions. So yes, to answer specifically, this pilot had flown the Saab previously. He had seen a video previously, but the company did not have actual tailplane stall training for the Saab.
Okay, thank you. Let me ask a couple of questions about this pilot, because it was certainly an eye-opener to me that after he passed his initial private test, then he flunked for the first time. The first time he took the instrument check ride, he flunked the first time he took the commercial check ride, he flunked the first time he took the multi-engine check ride. He also, maybe flunked is not the right word, but anyway, did not pass 2 check rides at Colgan. I don't want this to be a rhetorical question, but do you have any sense of how common that is to have pilots out there flying paying passengers who have such a record of failures to pass? I mean, is that a rhetorical question, or do you have any sense of that?
Well, I think it's a very salient question. I do have a presentation that will be coming up shortly where we will kind of go through that track record and talk about it a little bit more in detail.
I'll wait till you do reach that point. One more question about the stick shaker. I noticed the stick shaker in this airplane doesn't occur until after the stall, so I guess it's there as a recovery measure but not as a preventive measure. Is that a fair statement?
Oh, you're talking about the pusher.
I'm sorry, you're correct. I was talking about the pusher.
Yeah, your question directed to the pusher is that it has the same function in different airplanes. Some airplanes don't have one at all. In this particular airplane, it does happen post-stall, and that's a function of the airplane design, which is a straight wing type of airplane.
So is that, to your experience, typical or atypical to have the pusher not happen until after you're in a stall versus trying to keep you from getting into it in the first place?
Well, it's a good question. The short answer is I flew a lot of swept-wing airplanes, and swept-wing airplanes are really dangerous once they're stalled. So the designers use the pushers to prevent the stall. So they'll come on much sooner in the airplane slowdown sequence. But you have a straight-wing airplane like this, much more conventional type airplane like this, the pusher is designed to come on later because it is highly recoverable.
Okay, thank you. That's all for now.
Let me just close the discussion on the ICE issue. Can you tell me why there were a number of flights, including some that the accident crew were supposed to fly, that were canceled on the day of the accident? Why were those flights canceled or delayed? And were there other flights that were dispatched around the same time as the accident flight?
I believe the answer to that is that Colgan, as a co-chair partner of Continental, pretty much depends upon Continental to decide there at Newark whether or not they're going to cancel a flight or not cancel a flight. On the day of the accident flight, there had been high winds at Newark, and a lot of cancellations had taken place at that airport due to simply meteorological conditions there. So as far as we know, that was the primary reason why various flights were being canceled. But aside from that, in terms of the specifics, I can't say. We do know that afterwards, certain flights were dispatched up to Buffalo from Newark. Okay.
And there was actually a company flight that was dispatched around the same time that actually beat them to Buffalo, right?
Right.
Were any of the flights canceled because of icing
No.
conditions? We make a number of findings and recommendations about information that should have been provided to the crew and their paperwork. If we don't think icing is a factor in this accident, why are we making the recommendations that this information should have been provided to the crew? Maybe Mr. Ike wants to take that.
There was a National Weather Service. The National Weather Service did have an AirMet or for an advisory for icing conditions, which is a required document that they would have had. It was recommended after Roselawn that air carriers do receive this information. So overall, the flight crew did not have any icing information other than the forecast of light snow, the report of light snow, and 2 pilot reports. There was moderate icing conditions expected over the area. Advisory was in place, and after the accident, we found numerous aircraft reporting light, moderate, and even isolated severe icing, which would have severely been detrimental. So conditions were favorable to icing. The advisories were out, and none of that information was included in the pilot's paperwork. Additionally, in the paperwork, we found outdated information. We found center weather advisories that were from 4.5 to 24 hours old in the paperwork. And out of the 27 pages of weather and NOTAM information were included for a flight of less than 1 hour. So we do not think the weather document, the briefing tool, was very useful to the pilot. It did not include the current advisory for icing. It did not include the current products. It included multiple amended TAFs. It included out-of-date winds aloft forecasts. It included almost 280 FDC NOTAMs. Over 78 applied to Buffalo alone, and about 38 to the specific runway approach, amending the procedures. So we had a multitude of problems with the weather document, not providing useful, relevant information, current information, and there was no icing forecast included in that document.
And who's responsible for overseeing? I understand a contractor provides this information to the crew?
Well, the air carrier is responsible to have an adverse weather reporting and forecasting system, the dispatch to support it, flight following to make sure they're updated, Colgan Air did contract out to a weather vendor to provide the programming, to provide the data. It could be remedied by fixing that, a little bit of oversight to make sure it's getting useful information out. But we did see some information that we can improve on to make a pilot's life easier, provide them relevant information, up to date, flight specific, and we believe that we need to make some improvements in this
Okay,
area.
so we don't think that icing was a factor in this accident. We know that they were aware that there were an icing. They were talking about it. The boots were on. They had the increased ref speed switch on. And so really what we've identified is a shortcoming that we're attempting to remedy, even though it wasn't causal to the accident.
That is correct.
Okay. With respect to stall training, Captain Cox, can I go back to something that you said, or maybe it was Dr. Byrne, about when they get shaker or pusher in the simulator, that they're prepared for it? Can you talk to me very briefly about that? What did you mean by that? Do you mean that they're told that it's going to happen and then they practice it?
Well, that's precisely correct. Historically, throughout my entire career, the stall series was one of those pro forma type of things that all pilots had to do typically as a warm-up, as a proficiency maneuver to demonstrate your skill. You know, how closely can you hold your altitude, your airspeed, your heading during a recovery procedure. And it wasn't at all uncommon for the pilot to actually set the whole maneuver up himself, including the stall, and fly himself out of it. It's a skill maneuver, definitely. So what we're alluding to is that there was surprise in this accident. The stall training that is done throughout the industry does not normally require that this be done with an element of surprise. And we think that was an important element that's been missing in training over time.
Right, and we want to make sure that they have positive training, not negative training, so they don't react and do the wrong thing and begin to get conditioned to do that. And so there is a benefit in talking people through it, making sure they're practicing and getting the memory skills to know, how to do it. But I've heard pilots say that piloting is hours of boredom punctuated by moments of sheer terror. And I think if that is kind of the issue that we face when there's an emergency or an upset, then we ought to be training pilots for that, not giving them a check ride that basically is telling them what's coming, and then we're just trying to see if they can follow directions, not if their skills are sharp.
Well, I think you hit upon a good point here. We're not saying eliminate the approach to stall or proficiency training. That's always been good. It's always been necessary. We're saying the circumstances have begun to show us that pilots need to have an additional element, which is dealing with the emergency type of stall that may come about.
Right. I think that what you've presented demonstrates that the captain made the opposite inputs that would have been expected for what he was kind of engaged in based on the training that he received. I don't know if we're going to get to this in a later presentation, but neither of them called stall, and neither of them appeared to be communicating, recognizing what was going on at the time. I'm wondering why the first officer didn't recognize what was going on, perhaps overrule the captain if he was in a situation where he couldn't identify what was going on. Are we going to talk about this in a later presentation?
I really think this might be the appropriate time.
Okay.
Ultimately, we can't say for sure the answer to that question, but my personal experience to answer your question is that what it takes to intervene with another crew member in a multi-crew airplane is a product of experience. It's a product of maturity. It's a product of being able to recognize a really bad situation and take decisive action in short. We attempt to train these things at all times. One of the fallback mechanisms we talk about is crew resource management, but there are other methods in which we try to coach and encourage people to know when to make that call. But ultimately, we can't say for sure why the first officer didn't intervene, but clearly there was a need to intervene promptly, and it didn't happen.
And what would we have expected her to do?
Call out the stall and push forward on the control column forcefully.
Okay, so it's appropriate for another crew member to attempt to override the controls when the flying pilot is in control of the aircraft?
In an emergency, yes, I've done it.
Okay. How much time do we think that she had to assess what was going on and take action before the upset was not recoverable? Are we talking about two seconds, or are we talking about 20 seconds?
Well, that is a matter of speculation. We certainly had a lot of internal debate about the question of, how long into this event was it recoverable, and I don't think that objectively we've come up with a specific number, although I think it's a good question. I do think there was time. It wasn't just a split-second thing. I think this is a fairly large, stable, straight-wing airplane, and there was time to evaluate the situation and take recovery, but I can't give you a specific number of seconds.
Research indicates that the presence of an emergency situation requires greater effort to manage because of the stress involved and reduced opportunity for pilots to have practiced those skills. Several studies that we've cited in past reports note during high workload conditions, performance deficiencies, including narrowing attention and impairment of working memory, could result from inherent limitations in cognitive processes and the effect of stress on human performance. This is especially true when some of that information is incomplete, ambiguous, or contradictory. Crew tend to lose their place, jump to the wrong item or checklist when they're dealing with many distractions or competing demands for their attention. And I think we talked about the confusion and the startle that might have been going on. I've looked at some research because I'm just trying to understand why they didn't respond appropriately, and there tends to be some thought that in the immediate seconds after an event that there's kind of a caveman response, a fight or flight, and so it's really incumbent to train memory into the pilots to immediately react when something happens and not get startled and confused and lose their place. Do we think our recommendations will address that?
May I defer to Dr. Byrd on that subject?
I think they will address them, not one specific recommendation, but in total. And by that I mean we're asking for improved methods for training stalls, as Captain Cox discussed. And it's a natural reaction or that a pilot needs to control. And the more experience and opportunities the pilot has to control those impulses, the better and more refined the response will be and more appropriate. At the same time, it's important not to get surprised in the first place. And the ways you can prevent that are through improved monitoring behavior and maintaining situational awareness. So you know, so you're reducing the opportunities for surprise and having to perform in that manner.
Okay, and the last comment I have is, do we make any, do we believe that there was a breakdown in CRM with this crew resource management, communication?
The crew did not perform in a way that is consistent with the training that they received or the guidance that exists regarding crew resource management. And by that, they did not trap their errors. They did not challenge one another as far as deviations from standard operating procedure. We will have a presentation later about that issue.
Thank you, Dr. Byrne. Member Sumwalt.
Thank you. The Vice Chairman raised a good point, and I want to follow up on it. I don't think, I know his intention was, he raised good questions. I don't want the people in the audience to misunderstand that, to think that there's a difference, that anybody that's a civilian that's flying airplanes is not good. And I know that that's not what his intent was. I think the intent was to say that we do have a different pipeline of people coming out these days, but there are different ways of training pilots between the military and the civilian ranks, but I've flown as an airline pilot with many civilian pilots and many military pilots, and in my opinion, after having done this for 2 or 3 decades, is that what makes a good pilot is discipline, attitude, and approach to professionalism. And I do think that it's not necessarily a determinant of whether they were trained in the military or the civilian ranks. And I know that's not what he intended. His point was well taken, but I don't want anybody to misinterpret that. Is that fair, Vice Chairman? Thank you. Okay, so I want to go back to the theme of human, machine, and environment. We talked about the environment. Let's back up now and talk about the machine. What did your investigation, Ms. Ward, find regarding the mechanical condition of this aircraft? I noticed that there was an ice detection vane that was replaced, I believe, 2 legs prior to the accident flight. Tell me about the mechanical condition of the aircraft.
The investigation found that we found no structural systems or power plant failures that existed before the impact. If you want specific into the systems themselves, we have Mr. Warren here who can talk to the systems.
Yeah, I think it's important that we discuss that.
Okay, we did a number of things to look at the aircraft systems, primarily the de-icing system on the aircraft. We looked at the components that were remaining at the accident scene, and even though a good part of the airplane was consumed by the fire, there was a substantial amount of those systems that were remaining intact on the aircraft. We recovered those components. They include the bleed lines going from the engines to the distributing valves that control the flow of air to the boots that inflate to shed the ice off the leading edges of the wings and the tail surfaces. We looked at the bleed lines. We looked at the valves themselves. We looked at the boots themselves on the leading edges. All those items looked to be in good shape at the accident scene. We also took the distributing valves themselves to the vendor and examined those valves. They were in varying conditions, I guess is the best way to describe them. Some were badly burned and some were in good enough shape to still pass the manufacturer's acceptance test procedure. They would have been able to go back on an airplane had they not been in an accident. So in total, the aircraft itself, the systems that we were able to look at looked to be in good shape. The de-icing system looked to be in good shape. In addition, this de-icing system is monitored, well monitored by the aircraft itself, and any warnings or cautions from the system are registered on the FDR. They also would have produced a chime that would have been visible or would have been heard on the CVR. None of those warnings or cautions, I should say, were registered on the recording devices for the aircraft.
Thank you very much. We've talked about the environment. We've talked about the machine. It's time now for me to move now to my questions about the human, in this case, the flight crew. So why don't I start asking some questions about what was going on in the cockpit that evening. So, I want to know what allowed the crew to get into this low-speed situation in the first place. And from my experience as an airline pilot, after spending many, many hours studying and thinking about this accident, it is apparent to me that the captain set a very relaxed and casual tone for the flight. And unfortunately, that tone ended on a very deadly note. It's really difficult to get this from just merely reading the CVR transcript. But when I listened to the cockpit voice recorder in real time, I was struck. I was struck by the amount of conversation between the captain and the first officer. I hate going to listen to a CVR. It's a horrible thing to do, but it's part of my job. And what I do is I typically just sit there, put the headphones on, and I listen to it. And I close my eyes, and I envision that I'm in that cockpit. Because I flew for about, as an airline pilot, for about 24 years. So I try to place myself on that jump seat to try and get a feel for what's going on. And what I found here is that this conversation, it was a lot more than I'm used to. It was almost continuous. Almost continuous, but I will say it was pretty much one-sided with the captain doing most of the talking. The topic of the conversation, generally extraneous to flying the aircraft. And what I said when I finished listening to it was it was as if the flight was just a means for the captain. It was as if the flight was just a means for the captain to conduct a conversation with this young first officer. So we have a draft, we have something in the draft report that says, and I'm going to quote from the draft report, because of their conversation, the flight crew members squandered time and their attention, which were limited resources that should have been used for attending to operational tasks, monitoring, maintaining situational awareness, and managing possible threats and preventing potential errors. Right after the first officer extended the landing gear, the ice detect message appeared on the engine display in the cockpit. Is it possible that this light, is it likely that the illumination of this advisory may have distracted the flight crew?
It's possible that captured the captain's attention. However, on the basis of the CVR, there's no information that allows us to determine where he was focusing his visual attention during the period that the low-speed cue was visible.
And furthermore, the way I look at it is the ice protection system at this point was already turned on. Is that correct?
That's correct. And the enunciation that would have come up would have been not a higher priority alert that would have cued the pilots to the fact that perhaps they didn't have the ref speed switch in the increased position. So it would have been a nominal alert indicating the continued accumulation of ice.
Yeah, so the system, the anti-ice system, the ice protection system was already turned on. So even though this alert signaled in the cockpit, there's nothing more that they could have done. Is that right?
At that time, yes.
So it's not likely in my mind that just because this advisory came on that there's anything that they would have had to have done, that would not have distracted them. That's the way I look at it. Comments?
It should not have distracted them.
Thank you. I yield the balance of my time.
Thank you, Vice Chairman Hart.
Thank you. Member Sumwalt was correct. I was not intending to suggest that we have a population of not so well-trained pilots out there. My point was that we are losing the benefit of what we used to have in terms of the world-class training from the military, and we need to figure out a way to continue and maintain that excellent training for future pilots. And that's why kudos to the staff for having a separate session on that subject. I have a question about use of autopilot in icing conditions, and that is, I noticed that the captain in the cockpit voice recorder, one of his comments was, oh yeah, that's the most I've seen, most ice I've seen on the leading edges in a long time, in a while anyway, I should say. So he was obviously aware of a lot of ice, and after Roselawn, there was a lot of attention given to use of automatic pilot in twin turboprops in icing conditions. Can you give me a little bit of a history of where we went after Roselawn regarding use of autopilot in icing conditions?
In addition to Roselawn, it also was an issue in the Monroe, Michigan accident with an Embraer 120, and we issued a recommendation out of the Monroe accident to not ever use the autopilot in icing conditions. The FAA disagreed with that recommendation on the basis of there are periods of high workload and the pilot needs the autopilot to be available to do that. We ultimately closed that recommendation unacceptable. In 2006, in response to several icing accidents and incidents with Saab aircraft, Saab 340s, we reissued that recommendation, but we changed it slightly. We asked that autopilots not be used in icing conditions except for brief periods of high workload for the pilot. So the idea would be that the pilot would be able to use the autopilot for a short period of time, but he would not put himself in a situation where he would miss the tactile cues through the controls of reduced control from icing. The FAA came back and said, we recognize the difference in what you had, and we'll let you know what we're going to do. That was in 2007. We're still awaiting for a response to find out what they're going to do.
Do you know if there was any training, if Colgan gave any training to the to this or other pilots of their twin turboprops regarding use of autopilot in icing conditions?
Captain Cox?
I think at ground school, we indicate that there's some reference to the proper use of the autopilot, and they had some extensive slides and other information on icing conditions. But the specific, what you're saying in terms of you should disconnect the autopilot in icing conditions, we can't say with certainty unless Dr. Byrne can give an example.
They weren't authorized to use the autopilot in severe icing conditions.
That was by virtue of what? Colgan's training? Is that what you're saying?
Colgan's training and the company or in the manufacturer's limitations.
Okay, so I guess I would wonder. The reason I'm asking these questions is because if the level off and gear down maneuver had been done when he was manually flying the airplane, he would have had the tactile sensation of the reduced speed, increased angle of attack, all the things he would have had to do to maintain altitude once the gear was down, and that would have certainly increased his situational awareness, I think. And my question is, my ultimate question is, was he? You mentioned already that the captain's actions were inconsistent with Colgan's stall training. Certainly, I guess pulling back in response to the stall shaker, the stick shaker had to be inconsistent with the training. But my question was, is his use of the autopilot in this condition when he has said most ice I've seen on the leading edges in a long time? I don't know whether that meant severe to him or not. We'll never know, but that meant a lot of icing by any test. I just question whether not turning off the autopilot in the face of that statement was inconsistent with his Colgan training regarding the use of regarding the use of autopilots in icing conditions.
The difficulty, Vice Chairman Hart, is exactly what you said. The statement was made describing the ice, but it wasn't using standard phraseology. And so we don't know on the basis of his observation how he perceived the ice to whether it was severe. That he did not disconnect the autopilot suggests that he did not believe it was severe.
Thank you. That's all for me.
Vice Chairman Hart, let me, if I could just jump in as far as the manual control and the being in the loop to perceive these changes. Although the changes that you mentioned would have been facilitated if the detection of those changes would have been facilitated if the pilot was manually in the control loop flying without an autopilot. In March after the accident, a crew in Burlington, Vermont experienced inadvertent stick shaker because they forgot that the increased ref switch was, or the ref speed switch was in the increased position, and that captain was hand flying the airplane, turning base to final to the airport.
And what was the outcome of that encounter?
The crew recovered and landed the airplane.
Thank you.
That's a perfect lead-in because that was my next question. In the situation on the approach to Burlington, there were actually 3 people in the cockpit, including a check airman. And did any of them detect the low speed of the aircraft until the onset of the stick shaker?
No, none of the 3 pilots on board. The flying pilot stated that she was distracted looking outside for the airport, the runway. The first officer told us in interviews that he was executing a checklist at the time and was unaware, and the check airman did not see the event happen.
Did we have an opportunity to listen to the CVR for that crew?
No.
Do we know if there were any? Oh, okay.
The CVR was overwritten by the time we had the information.
Okay. Just trying to understand a little bit better about the monitoring errors that might have occurred in that accident, because it's very similar to this accident. Were they fatigued? Did they violate sterile cockpit? What was going on that was similar? What was going on that was different? We know that one of the things that was different in that situation was that the captain was hand flying the airplane at the time, correct?
Yes, and another critical difference is there was a check airman on the jump seat, and by his presence, you would expect that both pilots were performing in a standard manner.
A little higher compliance with rules and procedures, yes. But we'd also expect them to be watching the instruments and their airspeed, which is pretty critical. And he wasn't the check airman wasn't aware of it either, which just shows how easily it can slip past people's notice.
That's correct. Monitoring is not a 100% reliable human behavior.
And that captain was hand flying the airplane. Why do we think that that captain responded differently? Clearly they have the Colgan accident kind of in hindsight so that they might be a little bit more alert and a little bit more attuned, but why do we think that that captain responded differently? Was it because she was hand flying the aircraft and wasn't maybe startled and confused at the onset of the shaker and the autopilot disconnect? Or were her piloting skills perhaps better?
The fact that she was hand flying the airplane would have facilitated her re-engage, or she did not have to do what our captain had to do in terms of re-engage into a control loop after a event happened. She was already in the control loop and was able to recover with the addition of power.
Okay. And one of the things that I've heard pilots say is that speed is life. Captain Cox, can you tell me what that means?
Well, that's just sort of a way of emphasizing that every pilot needs to remember fundamentals first, regardless of automation, regardless of protections, regardless of cues, that pitch, power, and airspeed are what we are all about, and that's what we're doing when we're flying airplanes, and you must always know what airspeed you're at all the time and be fully in charge of that airplane and what speed you're flying.
And Dr. Byrne, do we have any other accidents that the safety board has investigated? I can recall at least a couple during my time at the board where the speed got slow and it resulted in the crew stalling the aircraft. Do we have any other examples where we've seen that?
Yes, the safety board's investigated multiple accidents in that area. We have a case in Eveleth involving a King Air. We have examples of aircraft in icing conditions, losing airspeed, and receiving the stall warning as well. And also Columbus, Ohio Jetstream accident about 20 years ago.
Captain Cox, did you want to say something?
We were really astonished at how similar that J3100 accident in Columbus was to this one. The circumstances were so similar in terms of the inattention allowing the airspeed to decline, the reaction to it. In many ways, almost an exact duplication. And I chaired a public hearing that the board held that involved an approach to Lubbock that resulted in an aircraft crashing on their final approach. Dr. Bauer, I think that you participated in that public hearing. Can you tell me some of the things that we learned about what manufacturers might be doing to address crews that might not be performing monitoring effectively and get slow?
Certainly. We learned during that public hearing, we had a presentation from ATR describing their aircraft performance monitoring system, which was a system they developed after the Roseland accident and several other international accidents involving crews allowing the airspeed to slow in icing conditions. The aircraft performance monitoring system provides basic 3 warnings to the crew. One, when their cruise speed starts to get low, just as visual warning, and then a secondary warning, which is a degraded performance warning, which is both a light and an oral warning, and last, a increased speed warning, or I should say advisory caution of both light and oral to let them know that they've reached their minimum icing speed, their minimum speed and icing conditions. This is active when their ice protection system is on and they are in flaps up, gear up. And it's an add-on system, something that can be added to ATRs currently in the fleet.
Okay. With this crew, and that also kind of piggybacks on a safety study that we've done at the board, where we looked at looking at the certification of aircraft and monitoring them through their life to understand if there are changes that need to be made to improve aircraft design, then that needs to be something that's monitored throughout the life of the aircraft. It's not just that the aircraft gets certified, it gets tossed over to whoever is flying it, and nothing else is done. I think this is a good example of people actually looking at an aircraft that is out there and looking at ways to improve it. So we know that it can be done. You know, I think, you know, we try to make sense of these accidents and understand what happened and what might have prevented them. And a couple of weeks ago, I was driving home, and on a narrow 2-lane road, and a creek had kind of gotten high. And it was a nighttime, dark conditions, and there was a lot of black ice on the road. And I was just driving along, my normal routine. Didn't really think much of it until I hit the ice, and I felt my car sliding, and had a panic response. I know I'm not supposed to brake when I'm on ice, so you know, I'm not really sure if I did or not, because I can't remember, because I'm pretty sure I was panicked. And as I'm sliding on the ice in slow motion, I can see in my brain, ahead of me, there's a car that's off the road, and all I can think is, please don't let me slide into that car. Please don't let me hit that car. Well, past that car, I see a big orange sign, a construction sign, that says high water on the road. And as I came through this successfully, past the car that was off the side of the road, I thought, gee, it really would have been helpful if they'd put that high water sign, or you know, caution ahead sign, back a little bit, so that I would have had an opportunity before I got to the black ice to slow down and to take preventative measures, so that it wasn't once I got in the problem that I saw that, hey, there's a sign that's up ahead that's telling me what's going on. I needed that before I got in that situation. And I think when I look at what this crew experienced, I have a sense that they needed something before they got into that situation. And looking at some of the technology that's out there, I think that it's appropriate for us to identify why they weren't monitoring, if this is happening to other crews, and if it is, what needs to be done to try to direct people's attention to maintaining the right airspeed. If speed is life, what can we do? And I know that Member Summerall's going to talk about that a little bit.
Well, thank you. And Vice Chairman, I'm glad you clarified that about the civilian pilots, since you and I are both civilian trained pilots, and I think we're both pretty darn good. But you keep asking me to go flying with you, so I'm glad you... but it does raise a great point, a great question, that one that keeps me up at night is where are tomorrow's pilots going to come from? And that's a great question. So I don't know the answer to that, but it's a great point. Mr. Ike, I see that you've already queued up the slide that I'd like, and if we could get this projected out for those in the audience. There we go. This is the primary flight display that is on the Q400. And Mr. Ike, could you take your mouse pointer? There you go. And so this barber pole, as I call it, is the low speed Q, and point exactly to the top of that. That is exactly the top of that. I'm sorry, to the top of the barber pole itself is where the stick shaker will activate. Is that correct, Captain Cox?
Yes, that's correct.
You and I both flew glass cockpit airplanes for a number of years, and when I looked at this, I thought, wow, this is a sort of Sesame Street style, hey, something's different about this primary flight display than from what I'm used to. So let's go to the next slide, and this would be an example of a speed scale on another regional aircraft. This one happens to be a regional jet, an Embraer 170 or 175 or EMB 190. And the point I want to make is here at 110 knots in this particular illustration, we see that would be the red there is equivalent to the barber pole. So at the top of the barber pole would be where the top at 110 knots on this illustration, the top of the red is where the stick shaker would occur. But notice what's on top of that. We have a yellow or amber cautionary range, which gives a little bit, is what the chairman was mentioning a few minutes ago. It is helping to give us just a little bit of advance notice, if you will, that, hey, we're not supposed to be, we're getting a little slow. And if we could go to the next slide, I think that's from this is from, it says 747-400. Dr. Byrne, I believe this is also basically the same speed scale as we'd find as the 777 or the 737 new generation aircraft as well, and maybe even similar to the speed scale on the 787. Is that basically correct?
Correct, approximate.
And so the point I want to make here is, again, on the current Boeing production aircraft, it has on top of that barber pole, it has an amber strip, an amber band on top of that. And the way I look at it, Mr. Ike, if you could now go to the last slide, which once again is the Q400, as a pilot, as speed is decreasing along that speed scale, as long as they are in that area that would be sort of considered the black area, the speed is basically normal. I mean, it's okay to be basically anywhere in that black area. Yes, that area that you're moving the mouse pointer. So as the speed comes down, a pilot would see, well, it's okay. It's okay. And it's not until they actually get to the top of the barber pole that all of a sudden the autopilot disconnects, the stick shaker activates, and there's no advance warning. At least if that pilot, one of the pilots would have looked up and seen that they were flying into an amber band, it might have given them some advance notice. And Dr. Byrne, what comments would you have along these lines?
Graduated warnings are beneficial, whether you're traveling down a road and looking for a high water sign or flying an airplane. Let me just offer an analog, not necessarily airspeed, but altitude and prevention of controlled flight into terrain accidents. All pilots should be trained to be able to perform a terrain escape maneuver. It's a high performance maneuver, but all pilots are trained to perform it and should be able to perform it under conditions of stress. In the early days, we had ground proximity warning systems that provided pilots with a cue, whoop whoop, pull up, at which point they need to perform that terrain escape maneuver. Current technology, we have TAWS, terrain awareness warning system, and TAWS provides crews with a visual representation of the terrain hazard, but more importantly, it also provides graduated warnings. That is, the early alerts that it provides the crews are caution terrain. Those alerts come before the instruction from the device to pull up. In that way, awareness is improved of the condition by the pilots, and the high performance maneuver that they should be able to perform does not have to be performed. They can avoid that threat.
Thank you. If we look at the primary flight display of the Q400, would you say that that is in conformance with Advisory Circular AC 120, 2511-A, which is titled Engine Electronic Flight Instrument Displays?
No, current design standards are moving towards requiring an alert or a caution before the stall warning is activated. And AC 2511A indicates that there should be a band providing at some reference value above stall speed, appropriate for the conditions that the aircraft is flying, and a cautionary band prior to the stall warning, which would be the red band area that currently exists on the Q400.
Thank you very much. And by definition, a warning is red according to FAR 25-1322, titled Flight Crew Alerting. So a warning is for conditions that require immediate flight crew awareness and immediate flight crew response, whereas caution, which would be yellow or amber, conditions that require immediate flight crew awareness and less urgent flight crew response. So, Dr. Byrne, do you think, after spending countless hours studying this accident, do you believe that if the Q400 would have been equipped with an amber band or yellow band on top of the barber pole, do you think that might have facilitated the flight crew's detection of the impending low-speed situation?
It might have, and by that I mean a caution before the stick shaker would be less startling to the pilot, and the condition is not perceived to be as severe. However, what needs to be noted here is neither pilot recognized the existing cues that were available to them on the primary flight display of the impending onset of that stick shaker. And those cues were conspicuous, but they went ignored. That's not unusual in terms of what we know about humans' abilities to monitor. And in that sense, an oral warning coupled to, or an oral alert coupled to, presented earlier, if either the first officer or the airplane itself had enunciated the impending condition, the circumstances may have been different.
Well, thank you. And to be clear again, if somebody would have looked up and seen that their airspeed was just in the black at a quick glance, that's normal for the most part. If they had looked up and seen that they were in the yellow or amber, it would have, in my opinion, after my professional opinion as a pilot, that would have, if they would have seen that, that would have sort of raised a red flag to them. So I do plan to offer a conclusion at the end of the board meeting, a finding regarding this, and I'm also going to propose at least 2 recommendations in this area. And not that this is an official recommendation, but it would seem to me we have airlines that call out the moment the radio altimeter becomes alive. It's sort of an awareness that, you know what, we're within 2,500 feet of the ground, the radio altimeter just became alive. And since this red cue, this barber pole, red and black cue, is coming up, it might be a good idea for some carriers to consider calling out the first indication of this low-speed cue as it starts to appear from the bottom of the primary flight display. That's my observation as a pilot. I will terminate the questions at this point because I have 16 seconds left.
He's in that amber band. Vice Chairman.
Just a quick follow-up. Correct me if I'm wrong, but those airplanes that have the yellow band, is it true that the number in the box, the airspeed number in the box, also turns to yellow when the airspeed gets into the yellow band?
That's correct. The Boeing example that Member Sumwalt showed, if speed deteriorates about 30% into that amber band, the actual indicated airspeed display, the digits, will flash yellow.
Okay, and the analogy that we all see to this every day is the traffic light, red, yellow, green. It doesn't go from red to green. It doesn't go from green to red and saying you're okay to all of a sudden you're not okay, but it has the yellow warning in between that says you're okay, that's green, yellow means watch out, and then red is stop. So that's the example of that we see every day in support of Member Sumwalt's position. Thank you.
Or in this case, red would not be stop, it would be go faster. I'd like to follow up on this line of questioning. In 1996, I think the FAA's Human Factors team wrote that existing stall warning systems were inadequate and that they recommended adding a low-speed alert. In 2002, one of the FAA's ARACs called for low-speed alerters in all new aircraft, all newly manufactured aircraft. I think that, Dr. Byrne, you've pointed out in your discussion with Member Sumwalt some situations where oral alerts were helpful. I was wondering if you could comment on what the benefits you would see in an oral alert in this situation like this.
Colors impart meaning, and provide information. They don't necessarily capture attention. Simply put, if an oral cue captures my attention. If someone I see is walking towards an unseen hazard to them, I don't wave my arms, I shout. And the reason is that I can process that information orally if I'm otherwise distracted through my visual means.
And that's why we have fire alarms that are oral and not just flashing lights or visual. Are there other things in the cockpit that merit oral alarms? Other situations, either caution or emergency?
There are many other oral alerts in a cockpit.
And why do the aircraft designers think it's prudent to have oral alerts in the cockpit?
An oral alert helps to capture someone's attention. You don't know from a design standpoint. You can't reliably predict where someone is looking all the time, or what somebody is doing, or what may be otherwise distracting them. But an oral alert is a very efficient means to capture someone's attention when they're otherwise engaged or distracted.
And in the accidents where we saw a low speed that resulted in a stall, what was the primary problem?
The crew's lack of awareness of that
they were not
impending
monitoring.
Deteriorating situation.
Okay. Mr. Hatter, I can tell that you're on the edge of your seat and you want to say something. Please go for it.
Well, I just want to mention that a stick shaker is a low-speed alert system, both tactile and oral, that it goes off, you hear it, you feel it, it goes off 5 to 7 knots above stall. So that is already built in, that there's a warning system to tell you that stall is approaching and to give you time to react.
But that also, that stick shaker is also accompanied by an autopilot disconnect that I think in some situations that we've seen on occasion that it's unexpected, and the pilot may have, in some situations, a handful of airplane. In other situations, not so much, but just be startled and take the wrong action. And I think the issue with an oral alert is really if the crew's not monitoring, really what we're trying to do is just redirect their attention or capture their attention to what they should be looking at. And it's very straightforward and it's very simple. I experienced I was low on gas in my minivan, and I have a visual indicator that tells me how low it's getting. I also have a light that comes on that tells me the fuel's low. But you know what? I didn't realize it, but when that light comes on, it also beeps. It makes a noise, so it compels your attention. Get some fuel now. And I think in the aircraft we see if there's a problem with fuel, are they going to get an oral alert on that?
An oral low fuel warning?
If they have a low fuel, it looks like Mr. Warren is ready. Go ahead.
Yeah, there would be a low fuel warning if it gets low enough.
Yep. And, you know, we've seen problems with people transferring fuel in different tanks not being balanced in the past. How about TCAS? Are they going to get an oral alert?
Of course. In fact, there are multiple oral alerts in the airplane.
And ground procs?
Absolutely.
And they also, some aircraft actually give the pilot feedback how many feet they are from the ground. They start to count down. And even though I've been told it's being used as a verb and not a noun, some aircraft call retard when they want you to flare. So I think that aircraft today are very sophisticated. They provide oral alert. Sometimes they provide direction, resolution advisories. They tell the aircraft which direction to go. We know that there are some aircraft that do have oral alerts already for low speed. Is that correct?
Yes, that's right.
I think that similar to the concerns that Member Sumwalt raised about the amber ban, I would also like to see a conclusion and a recommendation specifically addressing oral alerts, and regardless of whether the staff would like to propose that or they'd like it to come from the bench, we can discuss that at the end of the meeting. Mr. Howder?
Well, I think, a couple of things, and certainly we're not opposed to more bans or more oral alerts. That's not the issue. We've seen quite a few crews who over time have not adequately monitored and had stalls, some in severe icing conditions. Roselawn, for example, they had the autopilot on. They disconnected and had a handful of airplane. They didn't expect it, and they were in severe icing conditions. What we haven't seen before is this type of pilot reaction. In the stall events we've seen previously, pilots are either slow to react once the stall occurred, but we haven't seen a case where a pilot reacted this way in such a negative fashion. He instantaneously almost pulled back aggressively on the stick to almost 1.4, almost 1.5 Gs. That's a very unusual behavior, and quite frankly, I can't explain it. That's the real difference here. I'm not certain in this event whether the pilot had an oral alert, he would have responded any differently. His reaction was so sudden and such a negative response, I can't sell the case for an oral alert with this accident.
I seem to recall some discussion of other accidents where pilots stalled aircraft and actually were pulling back. One I think is cited in the report of Venezuela, maybe. Staff, are there others?
We also had the Pinnacle accident investigation where the crew was pulling back, but they were doing that to maintain altitude.
Yeah. And
there's some different ones there with Venezuela and Pinnacle. Very high altitude events. Right. However, they were trying to keep the airplane at its altitude and pulled back and entered this deep stall. This one is so different in its approach to stall scenario that I haven't seen anything like it before.
Well, I appreciate that each accident is different, and but I also appreciate that there might be the perception that this captain might not have responded appropriately to external stimuli, but I don't think that that makes the case for not providing an alert to all the other good pilots out there who might really benefit from it. And so I think that the research is there, the design is there, and the intent is there. We know we want crews to monitor, we want them to be more effective, and if we need to compel their attention to the task at hand, which is critical, we need to find any way to do that that is consistent with design and human factors principles. And I think our recommendations in the past have asked FAA to convene a panel to take a look at this and try to figure out how to address it. We issued the recommendation in 03, we reiterated it in 06, and here we are again looking at an incident which might have been prevented had there been better alerts to the crew in the cockpit. And so I think that the case is there, and we can discuss it when we get to the end of the board meeting. Any other comments from staff?
Just one. Certainly, your arguments and that of Dr. Byrne are very persuasive in the immediate case about an amber band and about an oral alert. I just think that we should often be concerned in this accident about the relative importance of technology versus trained performance. I would have flown 39 years as a professional pilot if I didn't like technology, so it's great to be able to make a recommendation and say, let's go out and improve the technology. You've made that case very well. I just always want us to be alert to the unintended consequences when sometimes these alerts conflict with one another, sometimes when there's so many that pilots just become inured to so many warnings. And if we're going to put in a new alert, we just want to make sure that they interact properly and they don't wind up causing more problems. And I think that's been the gist of the counter-argument.
I think, and that's exactly why we want to have people take a look at this and decide how to address it appropriately. But I think there are a plethora of alerts in the cockpit, and frankly, one that I hear all the time is the altitude chime, alerting crews when they're within 100,000 feet of their designated altitude that they're trying to achieve. They have trained that very well. They are very proficient. 6 for 5. 6 for 5. They're both looking, they're both paying attention. That's the point of that oral alert. Pay attention, we're getting close, get ready. If you're going to miss your altitude, certainly as others have pointed out to me, this is a significant alert. We don't want to have a midair collision if you violate your assigned altitude. But it's telling them before they're getting there, not when they get there, to pay attention. And so I think that that's the compelling case here. Break. We will take a 10-minute break and convene at 11:50 to continue with this round of questioning.
Thank you, Dr. Byrne. There was I want to return to the area that we were discussing right before the break, and that is the idea of low-speed alert systems. And there's an FAA Notice of Proposed Rulemaking that has been published in this past summer that states that alerts necessitating immediate crew awareness should be presented by 2 sensory modalities. Is that correct?
That's correct. It was a NPRM Notice of Proposed Rulemaking this summer for Part 25, 1322.
And for those of us from South Carolina, sensory modalities would be what?
Those are your basic 5 human senses. So we're talking, like for the example of stick shaker, that would be tactile and oral, as Captain Cox mentioned earlier, and or visual and oral, but 2 sensory modalities.
And so that's the point I want to make is that here in the FAA's Notice of Proposed Rulemaking, they are saying that alerts necessitating immediate crew awareness should have 2 sensory modalities. And that's what we're talking about here if we're talking about low-speed awareness systems. You know, it was mentioned before the break that we're worried about the unintended consequences. Well, I say that no matter what we do, everything that we do, every recommendation that we issue has potential negative consequences, and we do our best to manage those. But the reality is that icing has been a big problem. And here Bombardier comes in and puts a switch to increase the ref speeds, and now we find that somehow or another that might have led or might have contributed in some way to this accident. In the early 90s, people were worried about upset recovery, were they not, Mr. Howder? An accident that you spent 4 or 5 years of your life on. Airlines started employing upset recovery modules into their training, and yet we saw in American 587 that was a downside of a recommendation there, or of some thought. So no matter what we do, there's a potential downside, but our job is to identify the deficiencies the best we can and then come out with recommendations. And I'm in the camp, and I've changed my opinion on this, that the low-speed alert systems would be beneficial. Yes, we do have a stall warning system, but we need that advance notification because I think that the crew did apparently misrespond to the stick shaker. But if they would have never gotten to the stick shaker, they would have never had the opportunity to apply the wrong flight control inputs. And Dr. Byrne, do you agree that humans are not good monitors of highly reliable automated systems? That over time they lose that they lose their good monitoring ability?
Accident data and research conducted by NASA and others, aviation safety research demonstrates that.
So we're really saying that we just want a wake-up call, just something a little before, if the speed trend vector, if the aircraft projects that this aircraft is decelerating at a rate that doesn't look good, that in a few seconds you're going to be in a position that you don't want to be in, the aircraft is going to give us a wake-up call if the way I envision the low-speed alert system, to wake you up and say, hey, speed. In fact, an airplane that Captain Cox and I flew, an Airbus A320, does in fact have a system like that. If you're decelerating at a rate that it doesn't like, it will say speed, speed, speed. Dr. Byrne, I heard that Boeing is doing something along those lines. Can you explain to us what they're doing there?
In some of their aircraft, when the speed deteriorates into the amber band or goes into the amber band, and the cue of the flashing airspeed indicator begins, there's also an accompanying oral alert to help capture the pilot's attention.
And it's my understanding that all aircraft coming off the Boeing production line at this point either do or in the near future will have this system that you just described.
That's my understanding.
And by the way, the amber band that you mentioned was the amber band that the Q400 does not have.
Correct.
Right. So what we're talking about here is an extra layer of defense so that when the monitoring function breaks down, it's going to wake the pilots up, not literally, but it's going to sort of serve as a wake-up call to say, I want to make sure you know what you're doing here. So I'm going to support that. Okay. I want to talk just a bit about monitoring. Back up to that, we said that the board has found over the years a number of accidents where inadequate monitoring or challenging has been a factor. A 1994 study that the board came out with, 31 of the 37 accidents involved inadequate monitoring or challenging. And then since then, we've continued to see a number of accidents where monitoring is a problem. In response to our recommendation that we issued 3 years ago to the FAA to require that all pilot training programs be modified to contain modules that teach and emphasize monitoring skills and workload management and include opportunities to practice and demonstrate proficiency in these areas. In the response letter that the FAA sent us in response to that recommendation in May of 2007, the FAA stated that they believe that CRM adequately addresses monitoring, and it goes through a bibliography of places where monitoring is supposedly checked. 6155B2 number 3, 6158D, PTS, this and that and the other thing, aeronautical decision making. There are about 6 bullet points on this response letter that tell us where the FAA says that monitoring is adequately addressed. But I don't think they get it. And I want you to take this back with you. They don't get it. Just because it's written down somewhere doesn't mean that people are getting it. If they were getting it, we wouldn't have all of these accidents. We have to actually, just because it's written down, the guidance is probably sufficient. It's probably very good guidance. The advisory circular on monitoring nails it on AC 120-71A. It nails it. It's got the right information in there. What we now have to do is train people, actually train them in the simulator, how to manage their workload and monitor better. Accidents keep happening, so I'm going to suggest that the response, that CRM is not covering it. CRM teaches us to speak up or to challenge when something is unsafe or unwise. But in order to challenge that, to speak up, what must you first do? You've got to detect that something is wrong. And that is where the monitoring comes in. It helps you to detect that things are not right. So we're not there yet on monitoring. All right, let me talk about the ref speed switch. Can we pull up a picture? In fact, this one here that's queued up would be good. Let's go back and just look at this one again. Okay, the top of the barber pole. Now, what this ref speed switch did is it increased the barber pole by 15 knots. Is that correct, Ms. Ward? Or
that's correct.
And that was for the possibility that icing might be on the airplane. I think we're missing something here. I think the Colgan pilots were missing something, and I'm thinking that in our report we're missing something as well. I don't care where that barber pole is. I don't care what value it is. I don't care if it's 115 knots or 130 knots or 150 knots. A pilot fundamentally does not fly into a barber pole. And I think somewhere that was not the understanding at Colgan. I spoke with a pilot last week, and it wasn't immediately apparent, I think, to him, flying a Q400, that understanding was proliferated throughout the line. I looked at the Colgan QFM, Colgan Flight Manual, or Crew Flight Manual, whichever it is, Crew Flight Manual. I looked at the Colgan Q400 CFM. It had no information, no legends, nothing at all to describe what the symbology on this EFA system was. A pilot needs to be able to, and when I took an oral on an A320 or a F100, we spent a lot of time looking at this primary flight display. And I had to say, show the instructor, the examiner said, where does the stick shaker come on? And I had to place my pen exactly at the top of that barber pole. And at first he thought I laid my pencil down, my pen on the wrong spot. He said, where does it? I said, right here, right at the top of the barber pole. Okay, good. I just wanted to make sure that you knew that. But when I go back and look at the Colgan manuals, this CFM, excuse me, it did not have systems descriptions. Is that correct, Captain Cox?
They relied upon manufacturer's manual called the AOM for systems description.
And the AOM was physically kept where?
In a book in the airplane.
And so did they issue this information to the pilots at all? It's kept on the airplane.
It was available on CDs, which is the form that we have it in.
Okay, now did the pilots have those CDs? That's what I want to know. Did these accident pilots have those CDs?
We can't say for sure what the accident pilots had, but we know that the Colgan pilots on our group had those CDs.
Okay. Captain Cox explained to me prior to the accident what material Colgan had in their training program and in their manuals regarding this ref speed switch.
The primary source information for ground school introduction and training on this airplane we obtained through a series of slide sets that were used in the ground school. They were a systems description, and in the systems description displaying the ice protection system in the ground school training slides, it did discuss the switch. It did say, here is the switch, here's the function of the switch. What we looked for in addition to that was, when do you use this switch, how is it used, what are the limitations of it, and an integration of that into the simulator training and into the line training. And there we couldn't find any reference in terms of the simulator syllabus, in terms of other reference material that might have related how it works to when it's used.
So in the ground school, they basically said, here's the switch, this is what it does, it raises the amber bar by 15 or 20 knots or whatever, 15, 20, or 25 knots, depending on the flap setting. But again, you didn't find any other description of what that speed did in their modules on aerodata, ACARS, loft, situational and safety, or winter ops. Is that correct?
That's correct. Where we had slides and training that was oriented towards how do you actually use it, there was no mention of the switch.
And that's key. That's where the rubber meets the road, is that when you're flying the aircraft, there's two components of flying. You have to have the systems knowledge and know what the systems do, but then you have to be able to demonstrate that you know how to use those. Do you agree with that?
I do.
So is it unlikely, and I read this in the draft report, thus it is unlikely that crews were appropriately trained on the use of the ref speed switch, especially during simulator training. Is that correct? Is that accurate?
I believe that's true, yes.
Also in the report it says, after the Buffalo event and the Burlington Stick Shaker event, interviews with Colgan pilots determined, and I quote from the report, Colgan's approach procedures for setting airspeed bugs did not reinforce awareness of the ref speed switch position, which created an opportunity for confusion. And your thoughts on that?
The crew members that we interviewed typically could tell us what the switch was, where it was, and what it was supposed to do. But when we looked at their actual training and we looked at the procedures, including the checklists and the expanded checklist and the CFM, we didn't find the term ref speed switch included specifically in any of those standard operating procedures, where it would have been brought to their attention to physically check that switch and match it against the speed bugs.
Thank you. I do have other questions. I'm over my time, so Madam Chairman, I turn it back to you. Thank you. I do want to talk about the CFM again. This was a document. The CFM was a document that was apparently put together as an interim CFM. I took a look at it last week. Didn't have a lot of information in it. Again, it did not have systems descriptions. You're telling me they had a CD that they could look at. But this CFM had a number of false starts in terms of getting it from an interim manual to a full-fledged manual. And can you discuss that?
Well, when we first asked to be given all of the manuals that the crews would have and their training objects, we said, you know, this is not much of a manual. Is this what they have? And they said, well, that's what we provide them. It's an interim manual, and we do plan to have a permanent manual. In contrast, the Saab airplane, which they were already flying, did have a much more thorough crew manual because they'd had the airplane for a long time. So when, in a public hearing, as you may recall, we asked the POI, you know, what's the time limit on going from an interim to a final manual? He said there isn't any time limit. And I said, well, what steps have you taken to urge them to complete this? And he said, well, we've urged them, but we have to persuade them. We asked some of the managers at Colgan, why was this more mature manual not introduced sooner? Why did you tolerate such a minimal manual? What we were told, for instance, by the manager of flight standards was, we ask over and over again, where is this manual? So I think there were internal obstacles to getting a complete manual out there in front of the pilots in the proper documentation.
When you say internal to Colgan or internal within the FAA?
The FAA, the POI has considerable authority to approve manuals, and he definitely approved this interim manual in terms of precisely when he expected a better, more complete, thorough manual out there. I don't think he had a time limit, and I think that's a concern.
Thank you. I want to now move to the issue of tailplane icing. Do you recall that in the public hearing for the accident, the Bombardier representative stated that the Q400 was not susceptible to a tailplane stall?
Yes.
If that's the case, and what is an AOM again?
Airplane Operating Manual.
I've got a copy of the Airplane Operating Manual, Chapter 3, Emergency and Abnormal Procedures, and under landing, under the section dealing with landing, it says if a flap position, if landing flap selection is accompanied by stick force lightening or stick force irregularities, immediately retract the flaps to a lesser setting. Cycle the wing and tail de-icer boot several times. If possible, land using a smaller flap setting. Parenthetically, it says, this condition, which is the precursor to a tail stall, will not occur if AOM icing procedures are followed. End of paren. Okay, so explain this to me. If the airplane is not susceptible to tailplane stall, then why is this in the on the Bombardier Q400 AOM?
Well, you know, one of our parties brought that up in the public hearing, and we asked Bombardier in a public hearing, and they simply said it was an oversight, it was a mistake, it shouldn't have been included. What I'm left with is the impression that Bombardier never really stepped up and addressed this subject very, very clearly so that operators really understood the nature of the airplane. They could tell us after the fact that, well, it's not susceptible, but up to that time there was this sort of aura of mystery, you know, unstated question, is it or is it not? And I think that did leave some ambiguity out there for people trying to operate the airplane.
If I can interject here, could I have Dr. Bauer elaborate on the icing qualification of the airplane?
Please.
One thing I just want to add in terms of aircraft icing, when it was stated that the airplane was demonstrated to not be susceptible to tailplane stall, certainly we always see the limitations with regards to other aspects of of the airplane's operations, that it's not susceptible, subject to the conditions for which it has been tested, and that would be specifically the Appendix C icing envelope. Our other accidents have always shown that there are conditions that an airplane can get into for which it has not been tested, and other phenomena can happen. That could include a tailplane stall. We've certainly seen in the past when an airplane is stalled prior to the stall warning, even when it's operating in icing conditions for which it has not been tested.
Okay. I want to talk about the NASA video, NASA icing video, which when I was flying turboprops a few years ago, I found this video to be very well done. I found it to be quite useful. And I also found that the section on tailplane icing was very compelling. It really did make quite an impression on me. It got my attention, and quite frankly, it scared me. Because all of a sudden, here's a procedure that I've never heard of. Normally, we're going to recover from a stall by relaxing back pressure. Here's one where I've got to sort it all out, figure it out, and make the right decision. So in the public hearing, the Colgan Director of Flight Standards stated that Colgan did not teach pilots tailplane stall recovery techniques, and the company had no procedures for tailplane stalls in its CFM for the Q400. Does anybody remember that? Now, let me ask you this. Isn't showing it in ground school a video that contains tailplane stall and recovery procedures, is that not the same as teaching it?
Certainly, it's information that's being presented to the pilots in an official context. It is not in a manual. It is not as a procedure.
The King Air that I flew was probably subjected to tailplane stall with icing, yet we had no procedure at all in the manual for that at all. So I would propose that, do you agree that maybe by Colgan showing this, it might have introduced an element of negative training?
I definitely agree with that.
So absent any guidance to the contrary, like, hey guys, we're going to show you this video. It's 37 minutes long. It's great, but the section on tailplane icing doesn't apply to the Q400. So absent any guidance like that, wouldn't it be reasonable for a Colgan pilot to think that this is something that he or she should take note of?
It created a lot of ambiguity, and we interviewed a lot of pilots, and we got a lot of different answers about whether or not the airplane was susceptible and what you would do and how you would tell.
One of the preconceived notions I mentioned when I walked in, when we first started the questioning, that even I had preconceived notions. And one of the things that I believed going into this from almost the day after the accident, that this accident was related to a tailplane stall. But after I started looking at the facts, I have changed my opinion. But after all, the captain pulled back on the control wheel, which would be consistent with recovery from a tailplane stall, and the first officer retracted the flaps. And those are both somewhat consistent with the recovery from a tailplane. And from the outside, this may seem to fit. After all, pilots had seen the NASA video which explained the recovery procedure, and it was a very impressionable video. The video did explain that if you were to experience a tailplane stall, it would be most likely after extending the flaps. And in this case, the flaps were just being extended from 5 to 15. Is that correct? In fact, they were being...
That's correct.
They were in the process of transiting through 10, going to 15. And it made sense, again, from the outside, that the captain pulling back on the control wheel would be consistent with what that of the NASA video said. And the first officer's retraction of the flaps. But the video also stated that pilots needed to properly diagnose the icing problems while maintaining airspeed awareness, because the difference between a wing and a tailplane stall were subtle, but the recovery techniques were different. So, Dr. Byrne, how much time elapsed between the beginning of the stick shaker and the captain's pulling back of the control wheel?
Approximately 1 second.
Is that enough time to properly diagnose whether or not this is a wing stall or a tail stall, and then determine and apply the corrective actions?
that would be difficult. Through training, you want to try to instill discipline not to make inputs on controls until you've properly recognized and identified the situation.
So you're saying that, I think by inference there, I'm going to say that the captain did not have enough time to properly diagnose and apply the corrective procedures, so therefore his reaction was consistent with startle and confusion. Do you agree?
That's correct, and I'd like to correct you that you said he did not have enough time. He did not take enough time.
Okay, thank you. Did not take the time. Thank you. And another thing is that the first officer retracted the flaps all the way, whereas the NASA icing video just says return them to the previous setting. Is that correct, Captain Cox?
That's correct, and he also advanced power. And typically in a tailplane icing situation, you have excess speed, so you don't necessarily want to increase power.
Okay, and from this, I'm getting the idea that this reaction of the flight crew was not in response to the belief that they may have had tailplane icing. Madam Chairman, I will be glad to pause for questions. The chairman has just told me I'm the only thing between us and lunch. I want to talk about the stall training just momentarily. There's certainly been a lot of discussion and debate about stall training, so let me see if I can understand this. Captain Cox, are pilots required to train for, practice, and demonstrate proficiency with recovery from full stalls?
In order to be a certificated pilot, you must train full stalls. So when you get your private and your commercial certificate, yes, you're required to do that.
That's not the question. The question is for pilots flying for 121 operators, for the practical test standards for an ATP, are pilots required to practice for, to train, practice, and demonstrate proficiency with full stalls?
No.
No. And why not?
Well, for a variety of reasons. I think the first reason is that pilots are presumed to have been trained before becoming an airline pilot on how to recover from a full stall. That's one reason. Another reason is that historically simulators have not necessarily done a very good job of duplicating the post-stall environment, and so people who did training were concerned that pilots might get the wrong impression when they were doing this simulator training. And a third reason would be that stall series are always used as a method of measuring a pilot's skills in terms of maintaining altitude, heading, and airspeed.
And I believe that the issue about the simulator fidelity is a huge point. The board had testimony in the American 587 public hearing where a witness said that the use of simulators has some tremendous deficiencies or limitations for unusual or out of the ordinary flying. He says the simulators they can't be duplicated in a simulator. He says we discovered that in simulators, in some fairly simple maneuvers, they weren't representative of what the airplane should actually be doing. He said that they had seen cases where people in a simulator could get out of a stall by holding full back pressure and using power to fly out of it. So there's a possibility that if we train full stalls in current day simulators, that we will be introducing an element of negative training. Do you agree with that?
It's a serious concern, yes.
A serious concern. So should Colgan have been training full stalls in the simulator? Yes or no?
Yes.
You just said that if they, with current day simulators, should they have been training full stalls in the simulator? And we have somebody that wants to address this.
If I could defer to Mr. Kreider.
Thank you.
Well, I'd like to
point out a couple things. On 587, of course, that was a problem. It was the simulation was misprogrammed in the roll response of the to simulate a vortex. As far as stalls, there's been an advancement in the last few years. There's been a change of the rules in 2008. Part 60 became effective, and Part 60 requires that a stall be demonstrated in the simulator for a full stall and then initiation of recovery. Prior to that, all that you had to do was have the sequence of events properly maintained. Right now, at this point, we have 13.5% of the simulators are compliant with Part 60, are the equivalent. They would be able to pass that test. So we would agree definitely that you would want. It's very important to have a simulator certified and conformed to provide that stall training, and that a lot of stall training, till most simulators at this point do not, but we do have under this new requirement, which is now effective. It would be important to do that training in that 13.5% that are so equipped.
Okay, but for those 86.5% of the simulators out there today that don't have this capability, it would be negative training.
Could indeed have. That would be definitely a possibility.
Okay, thank you. I want to talk about the stall training, the approach to stall training that Colgan was doing. We have in the draft report that during training, pilots were instructed to maintain altitude, to maintain assigned altitude, and not deviate by more than 100 feet from the assigned altitude, which had been previously required by the practical test standards for a check ride. And so, Captain Cox, what's that all about? The practical test standard says that you should recover with a minimum loss of altitude, whereas apparently some people in Colgan were saying that they would fail a check ride if they did lose more than 100 feet.
About 7 years ago, the FAA changed their practical test standard slightly. They went from 100 feet to minimal altitude loss. From my point of view, that isn't too substantial. Airlines are allowed to use more restrictive standards than the PTS standard if they choose to. So it kind of comes down to what does the airline say their standard is. And I think the airline standard, according to their management, is minimal altitude loss. So we found a little bit of difference between what one check airman would say versus another. But the idea of the altitude, that stayed the same.
Okay, thank you. I do want to talk about the practical test standards, and these are the standards to which a pilot will be evaluated when he or she is taking a check ride. Is that what the PTS is?
That's what it is.
When I look under the task approaches to stalls, regarding the entry altitude, it says that when accomplished in a flight simulator, the entry altitude should be consistent with expected operational environment for the stall configuration. My question to you is, we're training a landing stall. Colgan's doing it at 5,000 feet. Is it, according to the language here, is it consistent with expected operational environment for the stall configuration to be fully configured with the gear down at 5,000 feet AGL?
I think it's important to be fair here. I think the PTS standards apply to all airlines for ATPs out there, and some airlines land at Denver where the ground is at 5,000 feet.
No, we're talking AGL, not MSL.
All right. Even so, it's commonplace in the industry for pilots to train for various kinds of stalls at a nominal altitude, and I don't think Colgan has done significantly different than what other airlines do in this regard. Certainly you can make the case that they could drop down a little bit lower and have a more realistic type of scenario.
I think, in fact, after the accident, that is one of the things that they have done. They have done it as quote unquote more realistic altitudes, but it does specifically say that, again, when accomplished in a simulator, not in an airplane, when done in a simulator, the entry altitude should be consistent with the expected operational environment for the stall condition. We don't configure the airplane for a landing at 5,000 feet AGL. It's not realistic to be training somebody to do a landing stall at 5,000 feet AGL. It ought to be done at altitudes more consistent with the configuration you'd be in with a landing. So I do think the pilots need to demonstrate they need both. They need recognition and recovery from the first indication of a stall, so that if you're at low altitude, you can recover with minimum altitude loss. But as we found in Pinnacle 3701, pilots need to understand that sometimes it's very important to lower that nose and trade a lot of airspeed, trade a lot of altitude for airspeed. Any thoughts on that?
Definitely important that a professional pilot have the skill to cope with every scenario that can take place, and that would include both high and low altitude, various kinds of upsets, approaches to the airport, as well as at high altitude, of course.
In the Burlington event, the autopilot was off, or was it on?
I believe the captain was hand flying the airplane.
Yeah, I think so as well. And I think that from just having the element of surprise when that autopilot kicks off and the stall and the stick shaker going off at the same time, that in itself would introduce startle and confusion. That we've used those terms in the report. So the way I see it, the current industry stall training could be improved by teaching recovery from a full stall once we have the simulator fidelity in that 13.5%. Not doing them as a pre-planned precision maneuver, but instead introducing an element of surprise. Doing them, as the PTS states, at altitudes consistent with expected operational environment, and entered with the altitude to introduce an element of surprise. Do you have any thoughts on that, Captain Cox?
Actually, we have a recommendation very much along those lines.
Very good. That's what I wanted to make the point of. We are going to recommend that. Madam Chairman, I'm getting towards the end. Would anybody like to follow up on anything? I want to talk about stick pusher training just for a second. When we wrote the green sheet coming out of Pinnacle 3701, we stated that there was potential unintended consequences and negative transfer associated with stick pusher training. What were those negative unintended consequences that we might have been worried about then, and do we have those same concerns now?
If not, we were concerned that if not done correctly, pilots may not have the adequate skills to be able to respect the pusher at altitude. And that recommendation was looking for an industry, a government industry working group or team to evaluate the validity of those concerns and and determine the need for this training.
The FAA addressed that by, they said they were going to reconvene the upset recovery training aid, which a lot of work has gone into the revision of that. But when they reconvened, they looked at the high altitude stall recovery procedure, which was a lot of what we were asking for. But did they address the stick pusher recovery that we had also asked for?
No, they did not.
Do we have any idea why?
I don't have an idea, no.
Did we have representatives on that working group?
No, we did not.
We did.
I didn't. I don't recall.
Okay. Somatographic illusion. Did you look at the possibility of the somatographic illusion? And what is somatographic illusion? I'm surprised I can even pronounce it.
I don't know if I can, but what the somatographic illusion is that quite simply when we feel, our body feels accelerations and decelerations, the otolith organs in our inner ear, part of our vestibular system, aren't, without adequate pitch reference, can confuse those accelerations and decelerations for tilting or pitching movements. Not unlike what you feel when you take off in an airplane, you're sitting in your seat, you're pressed back, but if you have your eyes closed, you may have the sensation that you're also tipping back before the aircraft actually does rotate. So in this case, one of our concerns was with the deceleration prior to the stick shaker. Were those cues sufficient enough to explain why the captain pulled in response to the shaker onset? And our analysis is that those cues were not of sufficient magnitude to explain the magnitude of the captain's response. They were to reduce the captain's perceived pitch by about 5 or 6 degrees, but he still would have had a positive pitch reference internally. And most importantly, on the primary flight display, he would have had the correct pitch reference.
Yes. And so even if there would have been some disillusion, some illusion, as soon as he or she looked at the primary flight display, they would have seen a horizon, and then we get most of our modal sensory information coming from our eyes, so that would have helped to resync their internal gyro, so to speak. Do you agree with that?
That's correct, and it's at times very difficult to resync as you're describing, but as we've said before, the most important thing is not to react without an understanding or an appreciation of what the situation or the dynamics of that aircraft is. And in this case, with that 1 second response and the pull, that's more consistent with startle and surprise. So it's very difficult that recognition would have been taking place.
Furthermore, somatogravic illusion, as you pointed out, is introduced by typically rapid acceleration or deceleration. And then here's the case: from the time that the low speed cue came into view, which is 21 knots, because the whole scale is 42 knots, so from the time that low speed cue would have started coming in from the bottom, it took 18 seconds for that low speed cue to come up to and match the current airspeed, to match the airspeed of the aircraft. So decelerating 21 knots in 18 seconds is just slightly more than 1 knot per second, which is really it's fairly standard deceleration there. It's even what they use for certification of stall testing in the simulator. So I don't think that somatogravic illusion was a factor based on the normal deceleration. Do you agree with that?
Staff agrees.
I need to interject, please. The scale for the low speed cue is plus or minus 42 knots, so if you do the same math, you're going to reach a conclusion of roughly 2 knots per second, 2 to 2.5 knots per second, as opposed to 1 knot per second.
Okay, thank you. So yes, I was looking from the lubber line, but yeah, so it starts. Okay, thank you for correcting me. Thanks. With that, it's the moment you've been waiting for. I have no more questions.
It's 12:36. We will take an hour break for lunch, and we will come back for the next panel at 1:30. Captain Cox.
Good afternoon. I'm going to address the captain's history, remedial training programs, pilot training records, and the Pilot Records Improvement Act, or PREA. The captain had received several disapprovals and had experienced training problems throughout his flying career. In October 1991, the captain was disapproved for his initial instrument airplane rating. In May 2002, the captain was disapproved for his initial commercial single-engine land certificate. In March 2004, the captain was disapproved for his initial commercial multi-engine land airplane certificate. And in October 2007, the captain was initially disapproved for an FAA airline transport pilot certificate and a type rating. In October 2005, the captain was graded trained to proficiency for normal and abnormal procedures on his initial Saab 340 check at Colgan. In October 2006, the captain was graded unsatisfactory on his recurrent Saab 340 flight check. And in October 2007, the captain was graded unsatisfactory on his Saab 340 upgrade proficiency check. Estimate training teaches a pilot to use a method known as cross-checking to continually assess and interpret performance, control, and navigation using aircraft instruments, and establishes the basis of a pilot's skills. The captain had not established a good foundation of attitude instrument flying skills early in his career. The captain's weaknesses in basic aircraft control and instrument flying continued, as evidenced by his difficulty in maintaining aircraft control on multiple flight checks. Colgan did not proactively address these issues before the captain began training to upgrade to the Q400. The captain successfully transitioned to the Q400 in December 2008. He'd been flying the Q400 for 2 months at the time of the accident. The captain's Q400 simulator instructor noted that the captain was rough on the flight controls and that he over-controlled the roll axis during an unusual attitudes maneuver. These observations were consistent with his previous aircraft control problems. Because of his continued weakness in basic aircraft control and attitude instrument flying, the captain would have been a candidate for remedial training. However, Colgan did not have a formal program for pilots who demonstrated weakness. The NTSB has previously issued Safety Recommendation A0514, which asks the FAA to establish programs for flight crew members with performance deficiencies. In response, the FAA issued a safety alert for operators, better known as a SAFO. The SAFO recommended that certificate holders implement a process for implementing remedial training programs. However, a SAFO is advisory only. During the investigation, NTSB staff found that few carriers implemented such programs before the accident. As of July 2009, only 12 of 36 responding air carriers had reported to the FAA that they complied with the SAFO. In October 2009, the FAA said 29 of the carriers had complied. And then just last week, the FAA publicly stated that all 100 air carriers have, and I quote, systems in place to comply with remedial training requirements. Colgan used an electronic computer record system to maintain training records for pilots. The electronic system contained only basic information of training events. The original, more detailed training records had been destroyed. Dates in Colgan's training records differed from those in FAA's records. Colgan attributed these to discrepancies in clerical error. Because of these errors, the dates of the captain's upgrade requalification events and his performance were not clear or certain, which prevented the events from being reviewed by company and FAA personnel. Some check airmen interviewed could not remember training details for the accident crew, so exact events could not be determined from their memory. Detailed paper records of the captain's performance at his previous airline provided greater insight into the captain's performance than the records maintained by Colgan. For example, remarks in these records showed that the captain had experienced problems with attitude instrument flying. Colgan complied with the Pilot Records Improvement Act. However, most new Colgan pilots were entry-level airline pilots who had no PREA history. Neither PREA nor FAA required airlines to check certificate history. However, air carriers have always had the ability to request these records from FAA as long as they obtained signed consent from the pilot applicant. The FAA amended its guidance on PREA in November 2007 to emphasize this fact, but Colgan did not obtain such consent from the first officer who was hired by the company after that date. Staff has proposed recommendations in this area. That concludes my presentation.
Member Sumwalt.
Madam Chairman, thank you. I did go rather long before lunch, as everyone remembers, so I would offer to yield my time to my colleagues and then come back.
Vice Chairman Hart.
Thank you. Just wondering if CRM training was part of the Colgan training, and are you going to talk about CRM issues in a later presentation, or is this a good time to do that?
CRM training was part of Colgan's training, and we can talk about it now.
Okay, and does that include recurrency, CRM recurrency, or how does that work?
Yeah, they had, Colgan had a both basic in-dock training, a one-day course, and then they also had recurrent training for pilots who had already been on the line. And
so I can take it from that both the captain and the first officer had been through Colgan's CRM training?
That is correct.
Okay, because it occurred to me, like, from the very start, there seemed to be a lack of coordination between the crew. So one of them hits the reference speed increase switch, and the other one doesn't know about it, so the other one is setting the bugs according to they're not reading from the same page, and so I'm just wondering, is that remarkable for you under the circumstances, or what are your thoughts about that?
We'll talk about that a little bit more in the next presentation on professionalism. However, the procedures, CRM can only go so far. A company needs to have the procedures in place to require those cross checks that to help facilitate crew awareness from one pilot to another.
Okay, because I'm asking, we'll get into it later then, but I'm asking because it seemed to permeate this entire flight all the way to the end when she's changing the flaps, she's changing the gear without really, the coordination that you would think would occur before all that happened. So, okay, well, I'll wait until you're to the next one to get into that further. Thank you.
So should we talk about CRM issues now, or are we saying later?
As long as they don't go into leadership, sterile cockpit, or portable electronic devices.
All right.
They may actually, if I could interject, they might actually be more appropriate for the next section.
Okay. All right. Fantastic. Thank you for helping us organize our time here. Can we talk a little bit about the training that these pilots received and what their background was? In particular, it seemed that there were some performance deficiencies for the captain, not just at Colgan, which Colgan had some awareness of his performance deficiencies during the annual checks. Each October, he had some challenges when he was taking his check rides or upgrades. There were other places that had some knowledge of his performance, and I'd like to talk a little bit about Gulfstream. In our accident investigation, since I've been at the board, we have seen a couple of accidents that have resulted in regional air carriers who employed pilots that had been trained at Gulfstream, and I'm trying to understand if there's any causal link here. The specific concern I have is, what is the incentive for an academy to fail out a pilot who's attempting to become a professional pilot when they are getting paid to train him? And so if you are going to pay someone $30,000 in order to get 250 hours of flight experience and a certain ticket punched, is there an incentive for that entity to fail him out?
Well, I think it's a good question. I think there is a bit of a vacuum in terms of providers of entry-level professional pilots, and I think Gulfstream is one of those who's been around a while and has provided a lot of pilots who have come into entry-level jobs, especially in the regional airline industry, and most of them have been successful. But the short answer is that it is a shortcut. Some pilots think there's a bit of a stigma for going in and paying, but other pilots, including the accident captain, were interested in moving as quickly as possible, and they were willing to incur the debt necessary to do the training. So I believe that Gulfstream had every intention of weeding out those who couldn't make it. When we talked to them, they said we give them a selection and a screening before we admit them into the program. But once you're into the program part way, you're committed. If at that time they find that you have difficulties, you may be out the money. So I think, yes, there's got to be an underlying incentive to get people through the program.
If I had a few words, it's not just Gulfstream. As Vice Chairman Hart mentioned, any of the commercial operations and non-military, there is an incentive to keep the student there as long as he can pay. And you'll see this with private pilots all the way up. If you've got money, we'll keep training you until you pass. And that does exist.
Is that an issue that we might look at in our upcoming forum?
I'm not sure how we're going to do it right now, but we're still trying to form that forum. It could be, but I don't want to guarantee it at the moment.
All right, I think the issue of quality of pilots and how they're trained is very important, because some of that foundational training is important later on. And I think passing, I look at the results for the testing that this pilot had, and I want to say we recognize everybody has a bad day now and again. Everybody is going to perhaps not perform on a test now and again. But I think that this pilot needed a good day to pass the test. And we're seeing a pattern here that is not being caught by anyone. And I liken it to a student that keeps getting passed from grade to grade to grade, and ultimately upon graduation hasn't mastered the material to the point which they should. And how do we keep them from getting passed on? And I want to understand the flight test failures. When a pilot goes in to take a check or get a license rating, what happens? They know what they're going to be tested on. Do they have a guide? Like when you go into the DMV, this is what you could be tested on to get your driver's license and your hazmat endorsement or your air brake endorsement. Are they telling you, here's the material, this is what you need to know?
Well, yes, of course. These standards are encapsulated in the PTS standards, and every flight instructor is required to, certify that his student is ready to take a flight check before he goes in, and he covers all those areas. And if he doesn't get through the check, and we did look into the statistics, and I think 29% of initial applicants for commercial certificate don't get by the first time. The instructor is required to review those problem areas and make sure that they're correct before he goes up. So you're right. It's a situation where if you address the problem, eventually you're going to pass. And it's a system that's designed to pass you up. And you have to demonstrate your ability to pass at least once before you move on to the next level.
And I think therein lies the problem. When they have a failure, they have a deficiency on a portion of the test. Do they get retested on the whole thing, or they only get tested on the portion that they didn't prevail on?
That depends on the examiner. In the captain's case, there was one flight check in which he was simply told you got to do it all over again. But on other occasions, there's one maneuver, two maneuvers that need to be repeated. So it depends. But of course, that's for certificate. Now, when you get to work for an airline, the question becomes: what is the airline doing, proactively to identify a consistent pattern? And that's one of the areas where we've got recommendations pending. And
in the past, the safety boards addressed this issue before. I looked back to a study that we did involving 37 flight crew involved accidents, and we did note that there was a higher number of flight crews involved in those accidents that had previous failure on a test. We've also done two other studies, or two reports since I've been at the board. One was a general aviation weather study where we identified a correlation between practical test failures and the likelihood for people to be involved in an accident later. We made recommendations from that GA weather study. We asked the FAA to develop a means to identify pilots whose overall performance history indicates that they are at future risk of accident involvement and develop a program to reduce risk for those pilots. In Air Sunshine, that was a ditching down in the Bahamas, we identified a pilot who had multiple test failures. He had failed 9 flight tests and still was flying passengers for hire in a single pilot operation. He had to take his flight instructor test 3 times. He failed it the first 2 times. I don't want somebody training other people to be a pilot when they can't pass the instructor test. We made a recommendation after the Air Sunshine accident for the FAA to address these multiple flight test failures. We specifically asked them to conduct a study to determine whether a number of flight checks a pilot can fail should be limited and whether the existing system of providing additional training after a notice of disapproval is adequate for pilots who have failed multiple flight checks. On the basis of this, the findings of the study, establish a flight check failure limit and modify the recheck training requirements if necessary. What I'm concerned about is in our report, we're really focusing on remedial training. What I want to understand is it's good to have remedial training because you might have a good pilot who has a bad day or is not executing a certain item. How do we get a bad pilot out of the system without continuing to pass them on check after check or year after year? Is there any method to address this, either from the FAA or the industry?
Well, I want to emphasize that our remedial training recommendation is focused on airlines. Once you're in the door at an airline and supposedly operating at a certain level, we think that more scrutiny needs to be made, more consistent records and management of everyone simply needs to be done. I think your question also went to the certificates, like the private and the commercial. That's a much broader area. We didn't really address that because we were focused on what happened in this particular accident.
Sure. And in this accident, do we believe that even though the pilot didn't disclose his previous flight test failures, all of them, he disclosed one of them, but not the other two, that Colgan had enough information to recognize that this pilot needed remedial training simply based on the information that they possessed through their annual checks?
Absolutely. It's their responsibility to know the performance of their pilots, and they had plenty of information.
And did they connect the dots?
We don't think so.
Okay. Thank you. I will come back for another round. Member Sumwalt.
Thank you. So the chairman had just mentioned that the captain on his employment application to Colgan had stated that he had only failed one check ride. In reality, he had failed, I believe, a total of 3 FAA check rides at that point. Is that correct?
That's right.
And the Colgan Vice President of Administration testified in a public hearing that if Colgan would have known of the captain's excessive prior failures, they would have terminated him. So I think the real question in my mind is, would they have hired him in the first place if they had known that?
During the many years of my career, that many failures disclosed on an airline application would be a pretty much automatic out. But I can't really speak for today. The supply and demand situation has changed dramatically, and I really don't know.
Well, and that's really what I want to know is, you know, she said that they would have terminated him if they knew that he falsified his application. I want to know if they knew that ahead of time, would they have even hired him? But I guess we don't know that answer. Is that Dr. Byrne or Captain Cox? Either of you know the answer to that from your interviews or from hearing testimony?
All I can tell you is that following the accident, Colgan did say that they had adopted a one failure policy for their hiring.
Okay, thank you. The Vice President of Administration for Colgan also testified, I believe, that they were not required to do checks outside of Pilot Records Improvement Act, which is true. All they're required to do is comply with the PREA. But the way I look at it is that regardless of what the Pilot Records Improvement Act says, you have a responsibility to know who's flying your airplanes. I ran a Part 91 operation, Corporate Flight Department, a few years ago, beginning in 2004, and we had to hire a pilot about 6 weeks after I got there, and I insisted that we were Part 91 operation. Pilot Records Improvement Act does not even apply to a Part 91 operations, but I insisted that we're going to go back and we're going to go back and look at prior failures because I want to know who's flying my airplanes. I've got a responsibility to my company and to those passengers who depend on me to run a safe operations, to know who's flying and what are their credentials and what's their record. And I didn't need an act of Congress to tell me that I had to find out about somebody before I hired that person. So that's just a viewpoint of somebody that has been placed in that position of hiring somebody, and it's a very important responsibility because pilot selection is such an important issue. If we make the wrong hiring selection decision, then that may lead to cascading issues down the road. I want to clarify something. I've read a good bit. There's been a lot of attention on this after the public hearing. Tell me this. Did the first officer, did she have, prior to the accident flight, did she have experience flying in icing conditions?
Prior to go to work at Colgan, she would have had very, very little. On her application, she had 6 hours of actual instrument. But subsequent to going to work for Colgan, we have plenty of evidence from the company that she had flown in icing conditions on a long number of many different flights.
She had been employed. She had just completed 1 year anniversary at Colgan. She went on the line. Probably went around 1st of March of the year prior to the accident.
Approximately.
So she would have had a little bit of the balance of that spring, plus probably from about October, November, December, January to fly in icing conditions at Colgan Airlines. I've gone back and looked at the cockpit voice recorder. It appears to me, I've listened to it and I've read the transcript, it appears to me that what she was making reference to was the fact that she did not have a lot of experience in icing prior to coming to work for Colgan. But at the time of the accident, she had flown approximately 1 season in icing. Is that correct?
Yes, I think you're right.
Thank you.
Vice Chairman?
Nothing at this time.
Is there a reason why we didn't reiterate the either the Air Sunshine or the GA weather study recs on the flight test, the number of flight test failures? I know that we're focusing on remedial training for pilots once they're in the system. Is that something that we might address in a future activity? Or does the staff not have concerns about the multiple FAA failures?
With regard to the Air Sunshine, I believe we are reiterating, there were 2 recommendations. Right. One asked for the number of flight check failures to be used, and I believe we are reiterating that one. The other one asked them to conduct a study, and on the basis of the study, limit those. That one is not reiterated.
Right. I think we're reiterating 01. Is that right?
That's correct.
And that's asking them to obtain notices of the disapprovals and evaluate it before hiring. The second one is to determine whether a number of flight checks a pilot can fail should be limited. And so I think that we are addressing the PREA type aspects of getting their records, but what we're not doing is making the hard decision. Asking them to do is to make the hard decision of how many strikes before you're out. And, you know, I recognize that burden might be on the carriers once that person's in the system, but is there some other mechanism to address this?
The second recommendation, the one on conducting a study and acting on it to limit the number of flight check failures, we had extensive discussions with them when that came out, and they did a study which has evidently never been published, but the findings of their study was that there was no relationship between flight check failures and safety. I believe staff was very curious to see the details of the study, because with a study there's always issues of how it's designed and how it's interpreted, and we were surprised by that finding. They have not provided the details.
And how long ago did they respond to us that they had done the study? It was several years ago, and they have not yet provided us a copy of the study, correct?
That's correct. The study was done approximately the beginning of 2006, so that would be about 4 years ago.
Okay. Well, I think that we have done several studies of our own. One was the study on the flight crew involved accidents, and we did note in that one that approximately half of the captains that were involved in accidents and a third of the first officers that were involved in accidents had previous flight test failures. Then we have the GA weather study that shows that there's a strong correlation between practical test failures and likelihood for an accident. And so, yes, I would be interested in seeing the basis of their position that it doesn't have anything to do. I think we're making a strong case in this accident that we feel that the performance deficiencies that the captain demonstrated on the accident flight can be closely tied to his previous poor performance on flight checks and tests. Captain Cox, are we drawing a conclusion or a correlation between his poor performance in the past and his performance on the flight?
Yes, but I think we should be cautious about making conclusions. And I think that a pilot's performance is a kind of a professional skill that's developed over many, many years. And to just use one metric is probably not wise. certainly we need to take it into account, we need to know about it, and we have to see whether corrections can be obtained in training, particularly in airlines. And there's plenty of opportunity for airlines to address this issue. We haven't found that there's a single metric that we can say and we can support that definitely says so many checks and you're out. That's just a step that's a little bit tough for us to try to justify.
We're not having to justify how many flight checks and you're out. We're asking the FAA to take a look at it and determine what's appropriate. And I think that incumbent upon them is the obligation to make sure that the pilots that are operating, especially those that are for hire and have certificates to fly other people, are not unable to perform when it comes to a flight test. I recognize some people have problems when they're in a test environment, but you know what? I don't want that person's test environment to be the accident that we have where there's an upset and they don't perform well. That's the reason why we're testing people, to see if they're up to snuff, and if they're not, we need to address that. So let me move on to a different line of questioning. In over 80% of the accidents in that safety study that we did involving the 1978 to 1990 accidents, 80% of them that involved crew errors, the captain was flying, and I think that this is something that's surprising to people. The study identified a high correlation between captains and first officers who were paired together for the first time as well. This information is also supported by other studies, including one from NASA, which says crews who are familiar with each other make fewer errors. And so I think we can see how this issue might be related. There are two questions here. So high time doesn't necessarily correlate to good performance all the time, because in that one we had a lot of captains that were high time that did not perform well. And the second is about CRM. Crews that are working together for the first time and may not have a lot of experience with each other, we're relying on that CRM training to help them get through that. We discussed monitoring in the previous presentation, and in that study we identified that we were concerned about the high incidence in the accident flights of the first officer's failure to challenge decision errors, or the captain, who are the flying pilots. The high incidence highlights a need for air carrier training programs to devote additional attention to the monitoring challenging function of crew members. It's 20 years after we issued this study, and we've closed recommendations based on CRM, but I think what this accident points out is that we still have some of the same problems that were identified 20 years ago. Have we fixed them? Do we need to do more? And that's just the question on the CRM, the monitoring and challenging.
I understand. There are other people here who are more expert than I as to past studies that have been done, and I would defer to them. But I think I'm going to the fundamental point that you're trying to make, which is what can airlines do to identify people coming in the door, particularly the large numbers of entry-level professional pilots, to make sure that they're properly screened and they're properly trained. And I think they can do a lot more. We have to recognize that we have a different population of pilots coming in the door at airlines now than we used to, and we have to adjust that training appropriately. And part of our recommendations regarding the remedial training and the record keeping, goes to the heart of that. These are techniques and tools that the FAA and companies can use. I might also add that not everybody uses quite the same standards, even though they say we go to the PTS standards. The board did an accident investigation 2 years ago at a regional airline, which hired from essentially the same population of entry-level pilots. And when we talked to them, we found that 22% of their pilots that were hired at the entry level were washed out, didn't make it through the first year. So we asked all the people at Colgan, what do you do? What's your entry-level rate? And nobody could tell us. We talked to all the management people there, and nobody really knew. So I thought that was a concern. And the next concern would be, apparently, it certainly wasn't anywhere close to 22%. So really, are we asking all airlines to apply the same kind of standards? Are we giving the same kind of scrutiny? And the answer is, I don't think so.
And we're going to address that in the coming months, I hope. Dr. Byrne, did you want to comment on the CRM issue?
Just briefly, I was jotting a couple notes down. The concept of the first officer challenging and have we gone far enough in the monitoring and CRM. After that recommendation from the 94 report, Advisory Circular 12151 was revised. That's the Advisory Circular on CRM. Monitoring is contained as a topic to be discussed in CRM, monitoring and challenging to help try to mitigate these problems of first officers not challenging a captain when the captain's flying. The industry's come quite a long way. CRM has evolved. We're in multiple generations now, 5th, 6th generation CRM. We've got the advent of programs like threat and error management or those concepts. Those are starting to get embedded into crew resource management programs. Colgan revised their CRM program after the accident to incorporate threat and error management. And also, but it's not just training what to do. You need to train pilots on how to do it, and that's where we have our staff's proposing a recommendation, or we have a recommendation that's open, and we're proposing to reiterate it on training for monitoring, how to train for monitoring. Colgan has, after the accident, implemented a program that they are training and they have in their manuals called VVM, verbalize, visualize, and monitor. And that's a technique that they're using in their flight operations, all phases of flight, to try to get crews on the same page as far as that it's important to monitor and capture errors and assess these state changes that are going on in the aircraft as far as its systems.
Thank you, Dr. Byrne.
One final thing, on top of the CRM aspects of it in monitoring, it's critically important to have sound standard operating procedures and standardization, so that when a first officer and a captain are flying together for the first time, you don't have to wait for experience to build and rapport to be developed to trust what that other pilot's going to be doing, that they will be doing the right thing all the time.
Thank you. Member Sumwalt.
Yeah, just a few follow-ups. And Dr. Byrne, I think you hit the nail on the head when you're talking about monitoring there, and that was the point I was trying to make earlier. Just because it's an advisory circular or in a PTS or something like that, that's not enough. We actually have to train people on how to do it and not just put something in an AC, and I think you hit the nail on the head. I want to go back to the Pilot Records Improvement Act, and the way that I see it is that those requirements do not cover basically two things that are important. They do not, if I worked for Part 1, if I was a flight instructor and then went to apply for an airline, would my records as a flight instructor, how I did as a flight instructor working for some flight school, would those be subjected to Pilot Records Improvement Act?
At the present time, no.
Yeah. So if I'm not working for an air carrier, then those records are sort of, they're moot. Nobody can really look at those.
Well, as we said, an airline can always go to the FAA and request those records.
Well,
if they have permission.
and that's right, and that's the other part is that, and when we say that this captain had 3 prior failures, we're talking about FAA failures, bust on FAA check rides, so it does not look at prior disapprovals, records of disapprovals, and as the chairman pointed out, we have issued a recommendation for 121 and 135 carriers to obtain notices of disapproval for flight checks for certificates and ratings for all pilot applicants and evaluate this information before making a hiring decision. Now, so the FAA in response to that came out with an FAA advisory circular to point out that you can get a pilot to sign this form, and if they sign that form, then you can get this additional information. But what is the status of that current recommendation, and are we not proposing to change it?
The recommendation is currently open, acceptable, alternate. I believe we are proposing in the report to reclassify that.
Yes, to reclassify that in a not so favorable fashion, and so why do we want to do that?
I believe the circumstances of this accident show that many of the carriers are not obtaining, they're either not aware or for some reason or another are not obtaining the permission, and they're not doing the full checks that would be available to them under PREA if
Yes,
they had.
and as it relates to this accident specifically, this advisory circular, AC 120-68 Delta, disregard that point. But it's still a point that it's only optional. It's not an industry standard for people up until this accident for people to be going out and doing more than the Pilot Records Improvement Act requires.
One of the points that the FAA raised in their initial response was that in order to require airlines to obtain more information rather than just making them aware that they could obtain it would virtually require an act, literally an act of Congress, similar to what was done with the Pilot Records Improvement Act. And even under favorable circumstances, that might take a very long time. They believe that by notifying all the airlines and encouraging them to do that, they could do that much more expeditiously.
Well, since it will require an act of Congress to change, the fact that the NTSB may reclassify that as an unacceptable response today, maybe that will signal to Congress how we feel about that particular issue. I have no further questions.
And I think, unfortunately, the FAA's position that it might take an act of Congress and that would take a long time, to me, that doesn't hold water because their regulatory activities have been taking significantly longer than getting a bill passed in Congress on most occasions. And so if we can address this, skin this cat one way or the other, whether or not the FAA wants to do it themselves or they want an act of Congress to do it, I think it needs to get done. I want to talk about something that I know is important to the families. We are not addressing the issue of flight time in this report. There's a difference between quality and quantity. I think in conversations with the staff, I would like for staff to maybe articulate why we may not be making a minimum hours recommendation for ATP.
In this particular accident, the flight hours of the accident crew was really not in question. They certainly had flight hours in excess of the minimum at the time of the accident. There's always a question of their flight time at the beginning of hiring, but it's not something that we specifically could tie to this particular accident. I think that's my rationale, at least.
It's a very difficult area because is flying for a small operator in a turboprop for 600 hours more valuable than somebody flying for 2,000 hours as an instructor in a Cessna 150. It's not just hours. It's the quality of the time. It's the quality of the instruction. And that's the problem we have there. We just come up with an hour mark. There's lots of ways to get 1,500 hours of flying time. You can tow banners at the beach. You can crop dust. You can do things like that. But does that really help you to be an airline pilot flying turboprop aircraft, high altitudes, in this kind of a situation, and icing conditions that we saw in this case? Maybe not.
Have we looked at other accidents where we saw high-time pilots who might not have had appropriate experience for the conditions that they were operating in? One that comes to my mind since I've been at the board was the Montrose, Colorado accident. We saw a captain and first officer who both had significantly high time, total time, but our staff did a very good job of actually looking at their experience, and they found that those crews had been largely operating in the southern part of the U.S. and had little to no experience in winter conditions, and in fact that this might have been the first time that those crews were flying in icing conditions in Montrose. Are there others that you all think that, or other recommendations that you think that we can address this issue of concern? Captain Cox, I've heard you talk several times about experience and maturity and time in the right seat to be assertive and to make decisions.
Well, needless to say, I think there's no substitute for experience or maturity, and those are things that you can't buy. Unfortunately, it takes time. And the difficult challenge for us is to come up with a recommendation that is fair and balanced and actually solves the problem. But that time comes very dearly. I have no doubt that with more time in seat, more time in preparation, more experience, all the crew members working in these airlines would make better judgments. But how you solve that is a challenge. I lean on the side of saying experience and maturity is a necessity for airline pilots, though.
As Captain Cox mentions, those are very difficult things to get, even if you're flying in certain conditions. As you mentioned, we have seen cases in the past where pilots who spent most of their time flying in the southern part of the United States and the islands find themselves in Colorado and have never really seen icing conditions before. That does happen. It's very high-time pilots. We've seen high-time pilots who've gotten into very unusual attitudes for which they were totally unprepared. In fact, as we found way back when in the U.S. Air 427 investigation, some senior captains, because they never go beyond 20 degrees of bank, you do that for 20,000 hours, suddenly you're not really equipped to handle a real upset and emergency because your whole frame of reference is only 20 degrees of bank and being very benign handling characteristics. One of the things I like to get into with our forum is the nature of the industry has changed so greatly. Years ago, you'd be hired into a carrier as a flight engineer, and you spent many years there before you became a first officer. So there's lots of opportunities to learn and observe before you got into the right seat and moved up. Now we have situations where pilots are going directly from one of the training academies into the right seat of a very high-performance small jet, flying upper altitudes, flying high speeds. That didn't happen 20 years ago. The industry's changed greatly, and that's something I would like to get into with our forum later on this year.
Are you all doing okay without a break if we go to the next panel? Or do you want to take a break? Proceed? Okay, we'll go to the next presentation. We'll take a break after we get through that.
Good afternoon. Contrary to sterile cockpit requirements, the pilots engaged in non-pertinent conversation below 10,000 feet. This distracted the crew from operational tasks during the descent, and they deviated from standard operating procedures. Although the non-pertinent conversation ended about 2 minutes before the appearance of the low-speed queue, it consumed time and attention that could have been used for operational tasks. Colgan pilots interviewed after the accident stated that pilots rarely deviated from sterile cockpit procedures. However, during the accident flight, neither pilot seemed hesitant to engage in non-pertinent conversation. Company and FAA oversight before the accident did not identify problems with sterile cockpit adherence, but after the accident, some deviations were identified. Colgan has since issued guidance to pilots and revised its training program to emphasize the importance of sterile cockpit procedures and the safety costs of deviations. Other recent accidents have involved breakdowns in cockpit discipline and noncompliance with sterile cockpit rule, showing how deviations can erode proven margins of safety. Although it is difficult to identify a specific reason for this behavior, industry data show that pilots who intentionally deviate from standard operating procedures are more likely to make other errors compared to pilots who do not intentionally deviate from procedures. The NTSB has previously issued recommendations in this area. For example, recommendation A06-7 asked the FAA to re-emphasize the importance of strict compliance with the sterile cockpit rule. The FAA issued SAFO 06004 to emphasize to operators the importance of sterile cockpit discipline. In addition, recommendation A07-8 asked the FAA to develop a program of education for pilots addressing professional standards and their role in ensuring safety of flight. The FAA has not developed a program that meets the intent of this recommendation. Ultimately, it is the pilot's responsibility to adhere to these procedures, and most pilots do. However, pilots work within a culture of professionalism established through the mutual efforts of the FAA, operators, and pilot groups. These and other stakeholders need to provide guidance to pilots that helps instill sound principles of professionalism, including adherence to standard operating and sterile cockpit procedures. Staff has proposed a recommendation in this area. The captain-enabled conversation that delayed checklist completion, conflicted with sterile cockpit procedures, and impeded timely error detection. Because he had been a captain for more than 2 years, his failure to establish the appropriate tone and show strong command authority is disconcerting. Operators are not required to provide upgrading captains with specific training on leadership skills. For many new captains, including the accident captain, the initial upgrade represents the first time that they are held responsible for leading and managing multiple crew members during air carrier operations. Colgan provided new captains a one-day course on duties and responsibilities, but the course focused on administrative duties. Some air carriers provide more extensive leadership training to their upgrading captains that includes modules on leadership, authority, and responsibility, briefing and debriefing techniques, decision-making and risk management, and offering practice scenarios. With industry changes, pilots have opportunities to upgrade to captain without having accumulated significant experience as a first officer in a Part 121 operation, making it more difficult to acquire the skills to manage a multi-crew airplane through mentoring and observation. Because of their critical role in establishing and maintaining safe operating conditions, operating captains would greatly benefit from specific training on command leadership skills. Staff has proposed recommendations in this area. The NTSB has identified hazards associated with the use of cell phones, including texting, in rail and highway accidents, and has issued recommendations to restrict their use during transport operations. During the taxi phase of the accident flight, the first officer sent a text message from her cell phone about 5.5 minutes before takeoff clearance. FAA guidance states that cell phones are not to be used after leaving the gate. Although Colgan's policy was consistent with this guidance, its pilot checklist did not address turning off cell phones in preparation for departure. The FAA issued SAFO 09003, cell phone use on the flight deck, to alert operators to the potential hazards associated with pilots leaving their phones on during critical phases of flight. The SAFO was issued after an FAA inspector at another airline heard a sound coming from a pilot's phone during the takeoff roll. The distracting potential of personal portable electronic devices extends to airborne operations. For example, in October 2009, a Northwest Airlines flight lost radio communications with ATC during cruise, and it overflew its destination airport. Preliminary information indicates that the pilots were distracted from monitoring the flight instruments because they were involved in a conversation that included the use of their personal laptop computers. These events illustrate that personal portable electronic devices can detract from pilots' abilities to monitor and cross-check instruments, detect hazards, and avoid errors. Staff has proposed a recommendation in this area. Thank you.
Member Somewhat.
Thank you. Dr. Byrne, you mentioned that when crews start intentionally deviating from SOPs, they are more likely to commit additional errors with consequential results. And do you recall something that the LOSA Collaborative provided us in response to another accident, I think Pinnacle 3701, no, I guess it was Comair, what is that factor that the LOSA Collaborative looked at? It was a factor of?
I believe it was a factor of 3, and we talked about that in both the Pinnacle accident and also Comair.
Okay. The significance of that is, I think it's highly significant, and this was an observation. University of LOSA line operation safety audits where trained observers go out and ride around on jump seats and collect data on threats and errors, and they found that those crews that deviated from SOPs are about 3 times more likely to commit additional errors with consequential results. And so to me, that sends a very powerful message to pilots that you might not see the significance of making a quote-unquote minor violation of the sterile cockpit or altering a procedure, but you are setting up a slippery slope to have additional consequential errors. The sterile cockpit, you know, when you start deviating from that, even if it's something that you think is just a minor violation, in my opinion, as somebody who flew the line for 24 years, it erodes discipline. When you don't follow it, it erodes discipline, professionalism, and concentration. And I think that the tone that was set throughout this flight, even though most of it was above 10,000 feet, it was in fact it was not a business-like attitude, and that's concerning. In fact, I think my colleagues and the staff are very concerned about accidents and incidents that we've seen, that we've investigated, where lack of professionalism has been an issue. When you think about it, everything in aviation hinges on those in the cockpit upholding their professional responsibility to report to work, prepared to work, and then carrying out that flight with the highest standards. And on Colgan Air Flight 3407, we saw a crew that, for whatever reason, neither reported for work, ready to work, due to their poor choice of sleeping arrangements, which we will get into later, nor did they carry out the flight with the highest standards. There was continuous conversation, starting on the ground as they taxied out. Much of that was probably with the parking brake set, but so that would mean that it was not technically a sterile cockpit violation. But there was a lot of conversation on the ground, a lot of conversation in the air, and I think that a combination of all of that sort of just relaxed the atmosphere in the cockpit to where people had let their guard down. I do believe that it is important to be comfortable in the cockpit. And in fact, the FAA advisory circular on CRM states that the tone in the cockpit should be friendly, relaxed, and supportive. But it also points out that the crew must ensure that cockpit discipline is maintained, crew vigilance is not reduced, and that critical items are not missed. And on this flight, clearly the conversation took precedence over accomplishing flight-related tasks, and as a result, critical items were missed. Dr. John Lauber served on this board for about 10 years and left at the end of 1994. But something that I often quote that Dr. Lauber said, I think he put it best, he said, and I quote, "There's a fine line separating a relaxed and easy atmosphere in the cockpit from a lax one where distractions can result in critical failures. Professionalism may be described as knowing the difference between the two." And that's what we're talking about here. We're talking about professionalism. The chairman has quoted it many times. I've used the quote many times. I didn't think of it, but I think it's right. Quite simply, professionalism means doing the right things even when no one is watching. A hallmark of an aviator's professionalism is insistence on strict adherence to the procedures, checklist usage, and sterile cockpit discipline. But you don't do those things for those flights where everything goes right. Instead, you do it that way so that it's for those flights where things go sour and you need something to fall back on. You fall back on procedures, standard operating procedures, and discipline that have been practiced repeatedly over time. You insist on doing things this way so that when faced with an unfamiliar situation, you are mentally prepared to deal with it because you can fall back on those procedures and discipline that are familiar to you. And the NTSB has seen far, far too many accidents where the lack of professionalism has been an issue. And I applaud staff's proposal, and I look forward to the forum that will be later this year where we do discuss maintaining high standards in aviation. Thank you for doing that, and I thank my colleagues for voting to hold that, and I will look forward to that very much. Thank you, Madam Chairman.
Thank you very much, Member Sumwalt. Vice Chairman Hart. Dr. Byrne, the sterile cockpit violation ended 2 minutes before, is it the onset of the stick shaker?
The sterile cockpit, the conversation lasted about 191 seconds, but it ended about 2 minutes prior to the onset of the stick shaker.
Okay. And when were they supposed to execute the various checklists? At the time that the upset occurred, were they behind?
At the time the upset occurred, they had completed all the checklists that they needed to complete. However, the descent in the approach checklist, the briefings were conducted late as compared to what standard operating procedure, the company requirements, and other pilots told us those checklists should be performed.
Okay, so previous checklists were a little late, but where they were in that phase of flight, they weren't behind on anything.
At that time, no.
No, but they were in the middle of executing a couple of different activities at that time.
They were in the middle of, they were initiating the before landing checklist, and they were doing final configuration changes.
Okay. This issue is one that kind of ties together a couple of areas that we're discussing today. We issued that recommendation, A067, on sterile cockpit as a result of our investigation of the corporate airlines flight that occurred in Kirksville. We asked the FAA to direct POIs of all 121 and 135 operators to reemphasize the importance of strict compliance with the sterile cockpit rule. We also noted the violations of sterile cockpit violations are the types of intentional noncompliance that can be detected through LOSA. On April 28, 2006, the FAA issued SAFO 06004, Approach and Landing Accident Reduction, Sterile Cockpit, and Fatigue, to emphasize the importance of this discipline. We closed that acceptable action in November 2006, and I was curious as to what we thought the practical effect of that SAFO that was issued that we closed. After we closed it in November of 2006, did we have any accidents since then where we've had sterile cockpit violations?
After the SAFO was issued, about 4 months later, we had ComAir in Lexington. And we had an accident involving an engine fire in St. Louis, in which the crew, as they were taxiing out for departure, were engaged, were not heeding the sterile cockpit rule. And that was a major air carrier. This accident and the fact that when we looked back at Colgan's training, and we were unable to find a lasting effect of the SAFO in Colgan's training, or as we investigate those other accidents.
Are we going to address monitoring right now, or is that for a later presentation? How we monitor crew compliance?
We can talk about that at this point, I believe.
Is that issue or that recommendation going to be discussed in another presentation? I'm talking about how we take a look at crew compliance with standard operating procedures, sterile cockpit, CRM. Are you going to talk about that in the last presentation on FOQA?
Yes, that will be the last presentation.
Okay. All right. I'll wait till we get to that one then to discuss that. Any other questions from my colleagues on professionalism?
Just a quick follow-up. Thank you. I know that you, Dr. Byrne, you mentioned that we proposed a recommendation regarding the portable personal electronic devices, and we mentioned including checklist reminders to remind them to turn off their checklist, their PEDs, flight crews. But when I go back and look at the SAFO that came out on that, it said that the Director of Operations of Part 121 and 135 certificate holders should perform a review of their respective GOM to determine if appropriate procedures are in place to remind crew members to turn off their cellular phones in preparation for departure. Then as it relates to the portion about the checklist, it says jump seat checklist should be reviewed to ensure checklist items remind personnel occupying a jump seat to turn off their cellular phones. So when I met with staff, I mentioned this, and it was said, I think something was said that, well, that's what the SAFO mentions, but the SAFO doesn't really mean cockpit checklist. It's talking about jump seat checklist.
What staff is looking for is clear guidance to flight crews to ensure that the cell phone, personal portable electronic devices, including cell phones, are turned off.
Okay. Now, we will talk about this when we get to the recommendation, but just so you know, so when we take a break, you'll know how I feel. I think we've got to protect that cockpit checklist, the flight deck checklist, and there's a lot of things we don't tell people to do before they sit down and strap on an airplane. We don't say to go to the restroom before you sit down, and I don't know if we need to be saying on a cockpit checklist, turn off your cell phones. I don't know. It's a philosophical question, but I was involved in writing checklists and procedures over the years, and I'm not crazy about the idea of it saying checklist as it relates to cockpit checklist. That's not exactly what the SAFO says, and so we can hold that discussion, but I kind of wanted to let you know that's where I am at this point.
Staff appreciates your concern, and we noted that there are procedures or there is guidance to pilots at Colgan. There were guidance to pilots, or the guidance may be ambiguous and needs to be tightened up in a way that ensures that these devices are not on in the cockpit.
I understand. Thank you.
Any additional questions from the board members? Seeing no questions on the additional questions on the professionalism presentation, we will take a 15-minute break and be back in here just a few minutes before 3. We'll reconvene for the last 2 presentations, and just so everyone in the audience and the staff have a sense of timing, we have 2 more presentations, correct? Our plan is to move through those 2 presentations, and then we'll take another break before we consider the adoption of the conclusions, probable cause recommendations, and the report. So we are ready for the next presentation, Dr. Byrne.
Good afternoon. Staff evaluated the role of fatigue in the crew's performance. Both pilots had some precursors of the fatigue before the accident. For example, the captain had reduced sleep opportunities in the previous 2 days, and during the scheduled 21-hour, 16-minute rest period before the accident, evidence indicates he stayed overnight in the crew room. He logged on to the company computer system at 3:10 in the morning, and his sleep would have been further interrupted and of poor quality due to the rest location. The accident occurred about the same time as the captain's normal bedtime, at which time he would have been awake for at least 15 hours. The first officer's overnight commute from Seattle afforded sleep opportunities of about 3.5 hours during 2 flights and 5.5 hours in the crew room after arriving at Newark. Although this amount of sleep approached the first officer's normal needs, sleep obtained would have been interrupted in poor quality because of the manner in which it was obtained. Both pilots' performance was inconsistent with other pilots' reports of their abilities, and therefore could be consistent with the known effects of fatigue. However, their performance was not degraded throughout the flight, and the errors made cannot be solely attributable to fatigue. Further, both pilots were engaged in conversational. In summary, although there is evidence that the pilots were likely experiencing some fatigue at the time of the accident, the degree to which it contributed to the errors made cannot be determined. The NTSB has issued numerous safety recommendations addressing fatigue, and reducing accidents caused by human fatigue has been on the NTSB's most wanted list of transportation safety improvements for 2 decades. Safety Recommendation A0610 asks the FAA to modify the flight crew hours of service regulations to account for factors shown by scientific research to affect alertness. Although the FAA recently established an aviation rulemaking committee to identify changes in this area, a science-based fatigue NPRM has not yet been issued. In this accident, recent schedules for both pilots were within flight and duty time requirements and not excessive in terms of accumulated flight time or duty periods worked, and the fatigue precursors were largely the result of the pilot's use of their rest time. Both pilots commuted to Newark from their homes outside the area. For many pilots, commuting may be a necessity because of industry changes, including base closures, and the cost of living at some bases. All pilots, including those who commute, have a responsibility to arrive work fit for duty. In this case, both pilots had an adequate rest period, but their choices in where and how they obtained sleep likely affected its quality and their ability to begin the trip as rested as possible. Most of Colgan's Newark-based pilots were commuters. Colgan had a non-punitive fatigue policy. However, company guidance did not address ways to mitigate fatigue from commuting or discourage commuting on the start day of the trip. Company policy prohibited sleeping overnight in the crew room because it was not an adequate rest facility, but the policy was not effectively enforced. After the accident, Colgan revised its training to address fatigue management and the hazards associated with fatigue, and issued a bulletin discussing fatigue causes and its effects on performance, and the importance of effectively using rest. Companies can help mitigate fatigue for commuting pilots by providing rest facilities, assisting pilots in identifying affordable accommodations, and planning flight schedules that support commuting. The circumstances of this accident demonstrate that operators have a responsibility to identify risks associated with commuting, implement strategies to mitigate these risks, and ensure that their commuting pilots are fit for duty. Staff has proposed a recommendation in this area. Thank you.
Member Sumwalt.
Madam Chairman, thank you. I do have a few questions, but I'd like to defer to my colleagues.
Vice Chairman Hart. Wow, that moved fast to me. Dr. Byrne, I think you mentioned some post-accident actions by Colgan. Did you talk about their revised fatigue policy in your presentation?
Excuse me, revised after the accident or
Yes.
the most recent December change?
Well, I'm interested in both, but did you mention that they had revised their reporting call-in policy?
Before the accident, the fatigue policy had a structure where pilots who called in fatigue called into operations or scheduling, and it was administered by the chief pilot in terms of any potential callback to understand why the fatigue was occurring on the operational side of the airline. After the accident, what Colgan did was redirect the calls that pilots make still go to scheduling for operational needs. That scheduling needs to know whether a pilot's available or not. But the reports that the pilots submit are reviewed not by flight operations personnel, but by flight safety personnel.
Okay, so post-accident, did they change their call-in policy where no questions were asked? It seemed like that was a bit of the way it was described.
Yes, it was described to us as no questions asked prior and also after, but the difference, no questions asked doesn't mean no report needs to be filed.
Sure.
The company wanted the crews to fill out a report after the fatigue call so that the company could understand the reason for the fatigue call and make changes in their policy. On the other hand, if the fatigue call was frivolous, also that would be of concern to the company as well. But one of the key concerns in terms of the perceptions was by having the report being reviewed in flight operations, it was seen as a possibility of being punitive versus a pure no jeopardy policy, whereas now having flight safety be the gatekeeper as far as reviewing those fatigue calls and making a determination on whether or not they're valid, that creates a better cultural aspect as far as a non-punitive fatigue policy.
Okay, but they revised their policy again for a second time post-accident, I believe in December?
On December 30, the company issued a read and sign memo through flight operations. However, the content of the memo was from the Vice President of Safety and Regulatory Compliance. And it was offering interim fatigue policy guidance. The concern was that the company over the past few months had been learning about some issues that led to fatigue through their scheduling practices with this no jeopardy policy, but they were starting to experience increasing instances of fatigue calls without any logical reason for them. And what they called frivolous fatigue calls, and it was starting to affect their operation. Calls coming in on a Friday or a Saturday predominantly, a dramatic increase in the number of calls in the first 3 weeks of December.
Okay, and so they canceled their policy the way it was because they felt like it was being abused. Do you think the fatigue posture at Colgan has better, worse, or stayed the same since the accident?
Information that since the accident, significant information has been provided to pilots, which is a very good thing. They issued a bulletin after the accident, as I described in my talk. They've also, in their overhaul of the CRM program, which was initiated prior to the accident, have incorporated discussion of fatigue and mitigation steps for fatigue. So information is getting out to pilots. On the concept of the fatigue policy, clearly it's a difficult issue for a carrier. If pilots are misusing a fatigue policy and using it in place of other ways to take leave, that's a problem from an operational standpoint, and so it seems that the company is trying to walk the balance between having a purely no jeopardy fatigue policy and trying to run an operation. Changes that they made for the December 30 memo clarifications were that fatigue calls would not be accepted if the rest period was at least 8 or 12 hours prior to it, or when coming off duty. As one of these pilots was who traveled from Seattle. That's a concern in the sense that that even with those extensive rest periods, there are still opportunities for a pilot to become fatigued. But the company stated in its memo and in a conversation after the memo was issued that they are still considering and still evaluating fatigue calls made under those two conditions, and we'll treat them as valid calls with a valid reason.
Well, and I think we saw in Shuttle America that we had a captain who had been off duty. He was coming off duty. He actually volunteered for duty, but he did not get the necessary sleep to report to duty well rested. He had 1 hour in the previous 32 hours approximately, and he was tired. He was admittedly tired. He knew he was, but he'd had some problems in the past with them accepting mark-offs from duty, and so there was concern that he didn't want to mark off for fatigue because he thought he might be disciplined for it. In fact, they had sent out a letter to a large percentage of their pilots in the month before the accident that basically said any additional unexcused absences could result in termination. So we made a recommendation after that investigation that carriers have non-punitive fatigue policies. And so I am concerned that they've reversed course less than a year after the accident on trying to establish a policy that might be seen as something collaborative, and instead it's turned into something that you know, is the words that we're using are abused and punitive. And I don't think that's where anyone wants to be when it comes to fatigue. If people are not fatigued and rested, they shouldn't be in the cockpit. And everybody needs to work together to make sure that doesn't happen.
And I agree. I think the other word is collaborative, and part of that memo outlined that the company was planning on establishing a fatigue review board later this month. And part of the responsibility of that board would be to help evaluate the fatigue calls. So that's getting all the stakeholders to work together, the pilot union, the flight attendants union, and the company to review the validity of these calls and hopefully to assure that it's a non-punitive policy for true fatigue calls, and most importantly that if a pilot is truly fatigued, that they have no hesitation about calling in fatigued and have no fear of repercussion for their career.
And are they still keeping the lights on in the crew room?
We have not been told otherwise.
Okay. I'll yield to my colleagues. I have additional questions. Member Sumwalt.
Thank you. So, Dr. Byrne, I think that it's important that if we are going to make a fatigue determination, that we have to be able to prove that their performance was degraded. And currently, as you said, the draft conclusion is the pilot's performance was likely impaired because of fatigue. And I don't think anybody would argue with that. But the extent of their impairment and the degree to which it contributed to their performance deficiencies that occurred during the flight cannot be conclusively determined. And I remember from the Comair accident, we knew that the air traffic controller had been awake, I think, 23 out of the past 24 hours or something like that, and we made a similar sort of finding there. So if you will, outline to me how we came up with that determination that we couldn't determine the extent of which fatigue impacted or impaired or did not impair his performance, his or her performance.
One of the problems, we've outlined some of the errors that the crew made throughout the day, and one of the problems with fatigue is that its effect on performance is not necessarily specific. Other influences on behavior can degrade performance equally. So we have trouble in terms of isolating. We don't have a marker for fatigue. We don't have a specific behavior other than falling asleep to help us truly delineate whether fatigue played a role in that event. In this case of significance is that when the cockpit voice recorder begins, which is about a half hour after the crew pushed back from the gate, we already have a crew that is engaged in significant conversation, and as you mentioned earlier today, it's setting the tone for what we see later in the flight. And this the continuous conversation, the distracting potential on both processing information in the environment and adhering to standard operating procedures can't be discounted, and that's one of our difficulties in isolating fatigue in this case. The other difficulty is the captain's past history of performance failures. It's unreasonable to think that each time he failed it was due to fatigue, the sheer number of them. So that we have a pilot that has those failures in the past, we have to account for that in the current situation, especially based on the circumstances of the event and his reaction to the stick shaker.
Thank you. Now we do know, I mean, they had the ultimate performance failure there, and the failure to monitor and failure to challenge. And I think in the draft report you mentioned that that fatigue, one of the symptoms of fatigue can be, certainly we know it's reduced alertness, lethargy, decreased monitoring. So those were performance deficiencies, and how can we say, and I'm asking here because I have a feeling it's going to come up later, how do those issues, can we not tie those to fatigue?
We can't isolate them from fatigue, and that's the problem. I think one of the issues with the fatigue is it's not just the performance consequences of fatigue, but it's also the strength of the precursors. What we know about the crew's previous activities when the accident occurred, and just for quick review, fatigue can be brought about by any number of things. One of them is loss of sleep over a period of days. The other is being awake for an extended period of time. You have circadian disruption, changes in time zone, and sleep disorders. And you also have time on task effects in terms of workload. So all these work together. All these are factors that we look at. And in this case, we have a day at the base that research indicates, NASA research shows regional airline operations, the pilots involved with, do report that long duty days with very little flight time can be fatiguing. But at the same time, you also have a very significant issue in terms of when you long duty days with quite a lot of flight time, going up and down 6 times, that can be also fatiguing. We don't have that in this case.
What we got out of the August the 18th, 1993 accident at Guantanamo Bay is we came up with NASA. In fact, one of our board members to be nominated, who will fill one of these seats if confirmed by the Senate, was the one I think that did the work for this on behalf of the board back in 93, 94 in that investigation. And this was a fatigue-related accident. It was the first accident the NTSB ever determined that, commercial aviation accident, that the NTSB ever determined that fatigue was a causal factor. And there was a metric there that Dr. Rosekind and his colleagues at NASA came up with: time since awakening, cumulative sleep debt, and time of day. Now let's see how this crew rings each of these bells. Time since awakening, for the captain, I think you said he had been awake for about 15 hours. Is that correct?
That's correct, but I need to caution you that we have unknowns in this area too.
I'm sorry, you have what? I didn't.
We have unknowns in this area in terms of we don't have anyone who's actually observing either pilot sleeping, with the exception of some reports at Newark and the pilots who, for the first officer, and the pilots who were jump seating with her on the flights in from Seattle. So I guess the specificity of our data, we were making assumptions that when the captain got up, based on electronic records of his activities and also based on observations of him being in the crew room early in the morning.
Yes, but do you feel comfortable that he was awake for at least 15 hours, or is that what you're not absolutely certain of?
Feel comfortable that it's at least 15 hours.
At least 15, and do we have that information, time since awakening, on the first officer?
That would be based on based on electronic records that show a lack of activities, either text messages or telephone calls, and the preponderance of observational reports. We are estimating her time since awakening as about 9 hours.
Okay, 9 hours and 15 hours. How about cumulative sleep loss? What do we show for that for each of the 2 pilots?
For the for the captain, he was on a 2-day trip in the days prior. So based on that and the fact that pilots do not normally get their required amount of sleep when they're on trips, it's likely that he was accumulating some sleep loss over that 2-day period.
Okay, and we can't quantify that for either of them, I guess.
No, but he had extended rest times, or both of the rest periods on the 2-day trip were of adequate length that he could have gotten his normal rest period. The difficulty for him that would have cut short his sleep time would have been early awakenings.
One thing we do know, though, is that he likely slept in the crew room, and she did commute from the West Coast to the East Coast on the morning of the accident. So the quality of their sleep would be somewhat questionable. Is that correct?
That's correct.
And how about time of day? Now, I believe we normally associate this fatigue with about 2 points during the day, normally from about 2 to 6 in the morning, somewhere nocturnal windows about 2 to 6 in the morning, and then we have an afternoon slump about right now, in fact. Somewhere between, what's that, about 2 and 6, 3 and 6, somewhere in there?
Yeah, that works. It varies, but typically we have a mid-late afternoon dip, and we also have the same thing mid-late or early morning, 3 to 5.
It's going to be hard to say for her where her circadian clock was, because she had been jumping back and forth between the East Coast and the West Coast. But the accident did occur at 10:16, 10:17 in the evening, and as I recall, some of the research shows. So in other words, that was outside of that circadian low point. But oftentimes, as I recall, right before we go to bed, around 9 o'clock in the evening, our circadian rhythm is actually up at a peak again.
Yeah, there's a paradoxical increase in alertness as you're approaching normal bedtime. In typical, if you have the valleys as far as of alertness that we talked about, 3 to 5 a.m., 3 to 5 p.m., you also have peaks in alertness that start increasing in the early evening hours.
So of the three metrics that we as the NTSB have used over the years, it sounds like we're only ringing the bell on one of those, and for sure, and that is the time since awakening, and that's for the captain, where we show at least 15 hours, but we can't really show that for the first officer. She'd been awake for about 9 hours. Cumulative sleep debt, it's hard to quantify, but we do know that it was not associated, that circadian low point that we normally associate with reduced alertness and performance. So I can only see one of those three that we can really draw a circle around and say this is where they were fatigued. And so at this point, well, I'll defer on how I feel about this particular conclusion, because I think others have more to say, but I just wanted to probe around that. Thank you for your time.
Vice Chairman Hart. Okay, I'll go ahead and pick up where the conversation ended. I believe that fatigue should be a contributing factor in our probable cause determination. As stated, we look at 4 core fatigue factors. They are 1, sleep, which is a combination of acute sleep loss and cumulative sleep debt. The second that has been discussed is continuous hours of wakefulness. The third is circadian factors, such as the time of day or whether there was disruption, circadian disruption associated with crossing time zones. And the fourth is sleep disorders. Of these 4 fatigue factors, I recognize that all 4 might not be present, but we have not necessarily had a requirement for all 4 or even a multiple to be present in previous accident investigations. Time since awakening or sleep debt has been enough in some of those other accidents to identify that as contributing. First, let's talk about a lack of sleep. I think that we can agree that was present for both the captain and the first officer. Studies show that just 2 hours less sleep a night is equivalent to 0.05 BAC, and 4 hours is equivalent to 0.10. In this accident, both the captain and the first officer likely had acute sleep loss. If we look at the, and the issue associated with sleep deficit and sleep debt is how much does that person normally sleep? What's their normal sleep time, and how much do they get at that point? I think if we look at the captain's schedule, his normal bedtime, according to his wife, was 2200, and he'd wake up at 0900. His wife said he'd wake up earlier if he had to get with the kids. So if he sleeps from 2200 to 0900, he's getting 11 hours of sleep a night. Plus, she said sometimes he takes a nap. So to me, that's a lot of sleep. I don't usually get that much sleep. I suspect my colleagues don't get that much sleep. Perhaps he's recovering from a sleep debt for the times when he's on duty. At home, he's recovering. His wife also said in a separate statement that he got 8 to 10 hours of sleep. So that would certainly be less than the 11. So let's say we go with a conservative number and say that he gets 8 to 10 hours of sleep a night. He wasn't diagnosed with any sleep disorders. And so if we do a fatigue look back on his schedules, and let's just go the 3 duty days that he was on before. The night of February 9th, he arrived from Tampa at 20:05. His last phone call was 22:47. He spent the night in the crew room. He had an 05:30 report time. That is significantly later and earlier than his normal sleep times. He had a report time of 05:30. This is significant for someone who doesn't usually wake up until 9 o'clock in the morning. This is later than normal bedtime by about 1 hour, and it's earlier than his normal awake time by 3 to 4 hours. So maybe while he's in the crew room, at best, he might be getting 6 hours of sleep for a 5:30 show time if his last phone call was at 22:47. So he's beginning to accrue a sleep debt. Depending on how much credit we give him for sleeping in the crew room, whether that's good quality sleep, I'm not sure. But let's just say we give him credit for some good quality sleep in the crew room. He probably got 6 hours of sleep. So he's accumulating a debt 2 to 4 hours if he's an 8 to 10 hour sleeper. The night of February 10th, he had a 30-minute phone call at 21:02. He was in bed maybe by his normal bedtime in a hotel that night at 2200. He had a show time at the airport that was early. He was in the breakfast area at the hotel by 0500. Again, earlier than his normal awake time. So we're assuming if he was in the breakfast area at 0500, he had to get up at maybe 4:30 if he wasn't having to do a lot of prep time. So let's say he got to bed at his normal sleep time, 2200, and he had to get up at 0430. That's 6.5 hours of sleep. Again, continuing to accrue a debt if he's an 8 to 10 hour sleeper. The night of February 11th, he's in the crew room. This is the night before the accident. We know he has interrupted sleep in the crew room because he logged on to crew track at 3:10. Let's just say we give him credit for going to sleep at 10 o'clock in the crew room. He had to wake up at some point, interrupt his sleep, and then maybe get back to sleep and wake up again. So even if we give him best case scenario, 6 to 8 hours, still 2 to 4 hours less than his normal sleep. So when I look at the deficit and the debt, he has it. The quality of your sleep in an away from home location is reduced. In a crew room is going to be significantly reduced. We knew he was awake at some point during that rest period, so he didn't get a straight sleep period. He was continuous awake hours, 15 or more. That's if we estimate, I guess, that he was awake at 0700. And I have significant doubts that this sleep in the crew room is quality sleep. The first officer, we can talk about her schedule and go through sleep debt and deficit, but I can see my time's getting tight. I think, the issue is that the captain had some issues that are associated with fatigue. He had deficit, he had debt, and he had time since awakening was significant. The safety board has looked at accidents, in particular in this flight crew involved study, and we basically kind of put the Mendoza line at 12 hours, time since awakening. Crews that were awake for more than 12 hours made significantly more performance errors. He was clearly in that group. The accident occurred at 22:17. This is the time of day that the captain would normally go to sleep, and therefore it's a time where he may have been predisposed to sleep, even though there might be a bump. For the first officer, in the preceding 34 hours, she only had 8.5 hours of sleep, and that's only if we give her credit for 5 good hours of sleep in the crew room on the morning of the accident. I don't feel comfortable giving her credit for 5 good quality hours of sleep in the crew room on the morning of the accident. In the factual, I know that there's a flight attendant who said she saw her on the morning of the accident at 11 in the 11 o'clock hour, and she asked her how commuting was going, and the first officer said, great. That's not indicative to me of someone who's asleep. And so I'm not sure that we give her credit for 5 hours of quality sleep in the crew room. Even if she slept in a recliner, it's daytime hours, there's crew coming in and out, there's people eating, people talking on the phone, people watching TV. So if she got something less than that, she's definitely operating in a deficit. Research has demonstrated that crews that are on long-haul flights in quarters that are designed for rest, where it's dark and they can get horizontal, don't achieve the same quality as home sleep. If the crews in those studies in controlled environments that are designed for sleep aren't getting good sleep, how do we expect a crew that's in a busy room with the lights on and people moving around and making noise to get good sleep? In terms of circadian disruption, I've had some challenges understanding this for the first officer because she was basically bouncing between East Coast and West Coast, and so I wasn't really sure which time she was on. When you look at her periods of duty in the days preceding the accident, she spent a significant amount of time on the East Coast, actually more time on the East Coast in the preceding week than she was on the West Coast when she was off duty. She commuted across 3 different time zones to report to work. And on the night of the accident, she traveled on a 3.5-hour flight with a stop in Memphis and then a 2-hour flight to get to Newark. I don't know about you all, but when I fly all night, even if it's a nonstop, I wake up, if I've slept at all, at my destination, and I'm certainly not good to go for that day. I think that what we can show is that there are some fatigue factors present here. And when it is a factor, it undermines performance, which can lead to bad decision making, reduced attention and vigilance, slower response time, and poor communication. The pilot's performance deficiencies in this case may well be attributed to fatigue, deficiencies such as the failure to detect the decaying speed, the failure to recognize the presence of the low speed cue, poor workload management, sterile cockpit violations, and failure to ensure that checklists, callouts, and standard operating procedures were followed. Further, they didn't recognize the stall condition or take corrective action. Fatigue factors and performance deficiencies that are present in this accident investigation are not unlike other accidents previously investigated by the board during the time that I've been here. Investigations where the safety board determined that fatigue was a causal or contributing factor. For example, in the Shuttle America accident in 2007, the safety board determined that fatigue was one of 4 contributing factors, such that the captain's fatigue affected his ability to effectively plan for and monitor the approach and landing. Didn't require both crews to be fatigued, just the captain. And this was a captain who also suffered from insomnia, so potentially a sleep disorder. In Pinnacle, Traverse City, in 2007, the safety board found that the poor decision making by the pilots likely reflected the effects of fatigue produced by a long, demanding duty day. And for the captain, the duties associated with check airmen. And in corporate airlines in Kirksville, fatigue was also cited as a contributing factor. Many of the factors that we see in our investigation today are similar to those in those other 3 accidents. Like the pilots in Kirksville, the captain and the first officer are violating the sterile cockpit rule. They're animated and talkative for most of the flight, even though they were fatigued. Although the captain in Kirksville did have a hotel room to rest in, he told his fiancée that the quality of his sleep the night before the accident, like the captain and the first officer in Colgan, was poor. And during long delays on the day of the accident, he tried to rest on a couch in the crew room. In Pinnacle, where fatigue likely led to poor decision making by the pilots, The captain and the first officer were flying together for the first time, similar to Colgan, and sleep was a factor for both of them. The captain had been awake for 17 hours compared to 15 in Colgan, with a cumulative debt between 4.5 and 6 hours. This is 2 hours fewer than the pilot in Colgan. Unlike the captain in Colgan, who slept poorly in the crew room the night before the accident, the Pinnacle captain slept soundly and had a full night's sleep in a hotel room. I can go on, and I appreciate the patience of my colleagues to let me address this. I do think that these cases that I'm mentioning highlight how fatigue can affect a pilot. Fatigue is not an on-off switch. You can violate sterile cockpit and be fatigued. You can be a poor performer and be fatigued. Fatigue can exacerbate poor performance, and it creates safety risks that I don't think we can ignore. So I'll yield to my colleagues for further discussion, and I appreciate their attention.
Thank you, Madam Chairman, and I guess we're already kind of getting the debate points out for later in the meeting, but I don't think that anyone disagrees that this crew was fatigued. What the real question is, the degree to which fatigue affected their performance, and that's the real question. And I think that I want to mention a couple of things. If the captain went to bed at 2200, 10 o'clock at night, and usually woke up at 10 or 9, that is 11 hours of sleep. I'm wondering if his body really needs that, or just given the opportunity, he takes advantage of that. I know that I am you probably don't believe this, but I am a big sleeper. Given the opportunity, I will pull those covers up over my head and I'll sleep late, if I can. But that's not necessarily that my body needs that. I didn't get a whole lot of sleep last night, but I think I got enough to be alert today. I think there is a difference between how much we prefer to get, given the opportunity, and how much our body physiologically needs. So I doubt that a healthy male, 48 years old, requires 11 hours of sleep to replenish the sleep deficit. Now, I do want to ask a question, and the study that you mentioned a few minutes ago, Madam Chairman, was that the crews were awake more than 12 hours, or was that their time on duty for more than 12? I'm under the impression it's, if you're referring to the Kirksville report, I believe that would refer to the time on duty of more than 12 hours and not necessarily a time since awakening.
I believe in the 1994 Safety Board study on crew-involved errors, they actually looked at 11 hours, and so that was their kind of line, and it was time since awakening.
Okay.
And 12 hours was considered critical in that crews that were on duty, or that were, I'm sorry, awake for more than 12 hours tended to make more errors.
Okay, thanks. And believe me, I am a proponent of eliminating or minimizing fatigue in the transportation business. I just want to make sure that when we come out with a probable cause, I think we have an obligation to be able to prove it the best we can. Probable is a word we've discussed that in board meetings. It's subjected to a lot of interpretation. I want to be able to go back if we vote on it and say, you know what, I can point to this, and this is what I can hang my hat on. And I think the chairman's making an argument towards that. I'd like to see it kind of plotted out. A few minutes ago, Dr. Byrne, I said, all right, give me the TSA, the cumulative sleep loss and the time of day. What was the fourth one that you had mentioned? Sleep disorder, which is a discrete, either somebody has a disorder or they don't, so they don't have that either that we know of. Again, I'm only ringing that bell on one of those, and that's time since awakening, and that's only for the captain. So I do agree that that their quality of sleep was not good before the accident. In fact, as somebody who made a living flying airplanes for about 3 decades, I'm not at all impressed of their choice to commute in the case of the first officer, to fly across the country and try and get some sleep on the day before an accident or the day before a flight, or the fact that he stayed in the crew room. I commuted my entire 24 years with the airline, and even though in those later years I only had an hour and a half, 2-hour drive to the airport, if I had a 7 o'clock departure, I did not wake up at 3 o'clock in the morning so that I could leave the house at 4, drive for 2 hours, and be there for 6 a.m. showtime. I would go up the afternoon before, get a hotel on my own expense. Wouldn't get up there at 9 o'clock at night. I'd want to get up there at a reasonable hour so I could be there and have some dinner and get in bed at a reasonable hour. I think that is a professional responsibility that was missed in this case. But the question will be, do we have enough information to say that that was a probable part of the probable cause of contributing to the accident? And at this point, I'm not there. But I think that if we can map it all out, and I know that's what the chairman just attempted to do, but I'd like to kind of go through it. But I'm not there at this point. I maybe can be, but I think we need to deliberate it when we get to that point in the probable cause.
Vice Chairman, you have any questions or comments?
No.
I think one of the things I had some concerns about in the submissions that I read was it seemed that if we were to look objectively at this accident, to me the decisions that the crews had to make about commuting, we know that this is a base where we had 70% of the pilots that were commuting, 20% of them were over 1,000 miles from the base. It seemed that there were some challenges for crews who were commuting into this base and for the company. Colgan stated that their guiding principle was never to compromise safety, and that it's their first priority. They had a policy that they required crews to sign that basically said, it's your responsibility to show up rested. You can't use the crew room, assign an initial thing. But, and I think that they seem to say, sure, you can commute, but we're not going to help you with scheduling or figure out how to make this better. I think the crews have a responsibility too in the decisions that they make and the choices that they make. But I did see that there were a lot of challenges for people whose bases might be changed multiple times, and who might have families located elsewhere. And so I really felt that this commuting issue is one that everyone wants to turn their head away from. The pilots don't want to talk about it. The airlines don't want to talk about it. The FAA put together their ARC on fatigue this summer and didn't deal with fatigue. And and didn't deal with commuting. See, it's fatigue setting in, and I've only been time since awakening about 10 hours.
I was monitoring and cross-checking.
So we got good CRM. I feel like that this is an issue that needs to be addressed, and if you peel back the layers of this onion, it's very unattractive, and nobody wants to address it. I think that these pilots were fatigued. I look around this audience, and I'm sure it's no reflection on the riveting subject matter, but I see people sleeping in the audience. Some staff kind of nodding a little bit. I think that let's think about what our performance would be like, all of us, at 10 o'clock. Let's stay in this room for 6 more hours, see how we're feeling. And you know what? We're all going to sleep in that room back there just to see how we do it. Nobody wants to do that. I think that this issue is one that needs to be addressed, and people have to stop turning a blind eye to it. And if we cannot say that these two crew members were fatigued based on their sleep deficit, their sleep debt, the quality of sleep that they had, and their time since awakening, then we're turning our head away from an issue that needs to be addressed too. There is nothing that says with these fatigue factors that one of them can't be enough. I look at the previous accident reports that we've issued. One of them is enough. Continuous time awake is enough. Sleep deficit, having bad sleep just the night before, it's enough. It doesn't have to be both crews. It can be one of the crew members to be fatigued for it to be cited in the probable cause. So I think that it's not inconsistent with how we have treated fatigue during the time that I've been at the board, and I intend to offer an amendment to the probable cause. I believe it's important, and I think that if we can't acknowledge that these two were fatigued, then who can?
Thank you. Certainly, I don't think that any of the three of us are wanting to turn a blind eye to anything. I think we've asked probing questions. We've looked in every corner. We're looking under rocks. We're pointing out things that we don't like. That's our job. But probable cause is sort of a sacrosanct thing there that it has to be done right. And what I'm going to propose, Madam Chairman, is that when we do break, I'd like for you to fill in the blanks. Write it down. We know the time since awakening. I want to know. Write it down. Tell me what the cumulative sleep debt was for each of them. The time of the day we already know, and there was no sleep disorder. I'm not going to turn a blind eye to anything, but I've got to have evidence to be able to say that something is the way that it is when it comes to the probable cause. That's all I'm saying. So, thank you.
Just so you have it, continuous hours awake for the captain's 15, if we estimate if he woke at 7, and that's giving him credit for good quality sleep in the crew room, which I'm not sure I buy into. The sleep deficit short term is 2 hours, but possibly more due to the quality of sleep. The sleep debt is longer term. In the last two of the last 3 nights he was in the crew room, each day he accumulated 2 to 4 hours of sleep loss. That's cumulative 6 to 12 in the last 3 days for debt. So he's got time since awakening, deficit, and debt.
Now, excuse me for interrupting. When you say cumulative sleep loss, are you
over those 3-day period,
assuming that that's based on his normal of 11 hours?
No, that would be 8 to 10 hours.
But you had to subtract it from one number. So which one did you use, 8 or 10?
It's 6 to 12 based on 8 to 10. So if we use 8 and he's losing 2 hours each night, it's 6. Okay. And if it's 10 and he's losing 4 hours each night, it's 12.
Okay, so you're saying that his cumulative sleep loss is between
6 to 12.
6 to 12 hours?
For the last 3 nights.
That is significant in my opinion. And, okay, in the time of day, we're going to rule that one out.
Well, I think because it's his normal sleep time, he's an East Coast person, and it's normal sleep time, I think the staff have acknowledged that that the fact that the accident occurred at the time when he would normally go to bed is an issue.
But if you look at a circadian cycle, that's not 10:15, 10:18 in the evening is not at the circadian low point. Right. In fact, it's up toward the top of the cycle. So just because somebody goes to bed, as Dr. Burns said, there's a sort of a paradoxical rising of the circadian cycle right before we go to bed. So we're not the scientists, Dr. Burns, but is that correct?
Yes, it is, and I guess I don't mean to interject, but I will in the sense that the concept of fatigue is also, there are individual differences in terms of people's ability to be resilient to these factors, and we have cumulative sleep loss effects, but we also have time of day effects that are also have been translated over to blood alcohol equivalents. Those tend to start around 17 hours awake for a 0.05 equivalent. Other articles or guidance to pilots that actually says as you remain awake past 16 hours, your probability of experiencing fatigue begins to increase. Staff is not discounting the potential for fatigue in this accident based on how these crew members obtain their sleep. What staff has difficulty with is ascribing a percent variance accounted for. How much of this accident was due to the results or due to the influences of fatigue? And fatigue is not a black and white issue. It's not binary. It is a graduated issue that has individual slopes for different people in terms of how it manifests itself and how much, what precursors an individual needs to show performance decrements. There are studies, there are hard and fast rules. We have our own research that shows the longer you're awake, the more likely you are to make errors. But of note in this case is the captain had performance errors prior to this day, a documented record of performance errors. And that is of concern to staff, that staff believes that the had fatigue or those performance errors are significant in how the captain responded. Also significant is the fact that we don't see an evolution of behavior in that cockpit over the course of the flight. We see a atypical tone in terms of what we would expect based on pilot reports about how both of these pilots behaved and adhered to procedure and adhered to sterile cockpit. But it's significantly concerning to staff that both pilots freely engaged in this behavior, and at no point in the 2-hour flight did either pilot step up and say, stop, we are outside the bounds of sterile cockpit, or we are missing checklists, we need to get back on track. So that goes to that the tone was set prior to departure. And clearly both pilots had some sleep. There are restorative qualities to that sleep that they've got, even if there is a debt. The crew member, on the captain's side, the first officer who flew with him during that 2-day trip when he was accumulating the sleep debt, Madam Chairman, that you're referring to, the quantity of which we don't know, that first officer reported that the captain appeared awake and alert during the flights. So whatever debt he was experiencing then was not reflecting on his performance on those 2 flights. I'm starting to ramble myself, so I'm going to stop at this point.
Right, but we just need the presence of the factors to know, and we know that he was sleeping less than normally on those 2 nights before. I recognize that someone might have said he was alert while they were with him, but he was going to bed at either his normal bedtime or later, and he was arising earlier for report times that were significantly earlier. So that's accruing a deficit and a debt.
Yeah, we have evidence, or his wife is saying he needs 8 hours of rest, 8 hours of sleep to feel rested. I can't explain the extra hours that she's reporting. We don't always have clear pictures of these data when we get them. But we have we have a record where we don't have evidence that he's missing trips early in the morning. This is something that he was used to in terms, or it was part of flying for the captain. It doesn't say that he's not experiencing fatigue, but for us, it's the concept of how much fatigue is he experiencing. He was self-described as a evening person. That would give him a benefit for operating at the time that this flight was operating.
Right, but what was his normal bedtime?
According to his wife, his normal bedtime was around 10 o'clock.
Yeah.
Let's compare this accident to American Airlines Little Rock. That accident involved a captain who was a experienced captain, had risen in the ranks of the airline up to a check airman and a chief pilot at the Chicago base. That captain was operating his aircraft into Little Rock, made questionable decisions that the board cited in its report, and it cited that those decisions were influenced by, in part, the effects of fatigue. In this case, or in the Little Rock case, that captain was up for over 16 hours and operating 2 hours past his normal bedtime. In this case, we have a pilot, and by that time, you are well heading down that slope, and that accident happened around midnight versus 10 o'clock in the evening. And the check airman chief pilot, the captain of that flight, also had no record of performance failures. Yet, we couldn't explain his behavior and the precursors of fatigue and the long work day that the pilot had. The duty day was 14 plus hours. Those factors, staff in that accident believed, rose to the contributing factor level.
Any additional questions?
I guess it's not a question, but I think typically we have basically a two-pronged standard that we apply when determining that fatigue is a probable part of probable cause. And one of those is that is someone fatigued? And I think the chairman has convinced me, and I felt this way initially, that they were fatigued. I mean, she's basically proven it with those numbers. But I think the other prong is that we have to show is how did the fatigue affect their performance. And what it sounds like to me, from reading the report and what I've heard today, is that his performance on the night of the accident was in fact consistent with his prior history of failures. Didn't he not do so well in some prior training on landing stall recovery?
That's correct.
And didn't he fail to perform that maneuver correctly on the night of the accident?
Most specifically, the most recent evidence we really have is his most recent training in the Q400, where one of the simulator instructors did talk about over-controlling in an unusual attitudes maneuver, which is very indicative of a poor cross-check. So he had a recent experience as well with that.
Okay. Well, thank you. In my opinion, we have not met both of those prongs. Thank you.
Does that mean that since his poor performance was primarily the issue, that there can be no other factors? And so if we're going to identify sterile cockpit as a contributing factor, that sterile isn't one of the reasons why they might have had degraded performance, that it can solely be attributed to his previous flight test failures? Is there only one thing that we can attribute? Can't there be a myriad of issues that result in degraded performance?
If you're asking me, it's a wide range of subjectivism that comes in to this particular issue that you've discussed very thoroughly, and I personally think that Dr. Burns explained it pretty well. I don't really have a lot more to say about that.
I'm sorry, I wasn't necessarily asking you a question. I'm asking if it's an on-off switch. Do we only think that probable cause is one thing? Why do we have contributing factors? Can something contribute to an accident to a lesser extent than the primary cause? And why do we think sterile cockpit is a contributing factor? They weren't violating at the time, but don't we think it contributed to their lax performance?
The concept of the sterile cockpit goes back to the tone, and the conversation and the pervasive conversation through the flight is creating an environment that does not facilitate trapping errors.
And if pilots are fatigued, we know that they don't do a good job monitoring. They don't interpret warnings appropriately. They implement standard procedures slowly or in the wrong order or miss a step. They get fixated on an issue. They lose situational awareness. I think my position is that if an alert pilot has a certain foundational level of performance, fatigue is going to lower that performance and create safety risks, just like sterile cockpit violations. Performance impairments create risk. Fatigue results in performance degradation. It's not whether or not these guys are snoring on the CVR. It's, do they have memory reduction? Do they have degraded decision making? Do they have reduced communication, reaction time? It's something that we know undermines performance. That's why it's been on our most wanted list, because we think it's an important issue.
With respect to the memory reduction, just an anecdote from the flight. The captain was conducting a briefing, and it was interrupted by air traffic control. The interruption lasted almost a minute, just a little bit shy of a minute, and the captain immediately resumed, without missing a beat, his briefing exactly where he left off. He didn't restate anything, but he picked up the briefing exactly where he left off. So that's one of the struggles that staff has, is that the performance was not degraded. We can't characterize everything they did in the flight as poor. There were some things that they did in the flight that were timely, some things that they did in the flight that were consistent with standard operating procedures, and we're not seeing pervasive performance deficits. And true, one of the symptoms of fatigue or consequences of fatigue is performance becomes more variable. But we are seeing some of the skilled behavior, some of the routine behavior, and some of the higher level process factors are not degraded to the extent that staff feels warrants inclusion in the probable cause.
Very well. Any other additional comments? I think we're ready to proceed to the last presentation.
I'm going to address FOQA programs first, followed by FAA oversight and the SAFO process. Flight Operational Quality Assurance is commonly referred to as FOQA, is a voluntary FAA safety program that uses recorded flight data to identify risks and take corrective action. FOQA, it depends on quick access recorders, or in some cases, flight data recorders for data collection. FOQA programs are addressed in Advisory Circular 12082, which advises that these programs can provide objective safety information that would not otherwise be obtainable. The NTSB has previously issued a recommendation related to FOQA. Safety Recommendation A0711 asks the FAA to strongly encourage and provide assistance to all regional air carriers to implement FOQA programs. The recommendation was classified closed acceptable action in January 2008. Colgan's FOQA implementation and operations plan was approved by FAA in October 2008. However, the program was not implemented at the time of the accident because of unanticipated issues affecting the installation of FOQA hardware. Colgan is now implementing FOQA for its Q100 fleet. Stall warnings resulting from a mismatch between the ref speed switch and airspeed bugs may be more common than currently realized, given the circumstances of the accident flight and a similar event in Burlington, Vermont that we've already spoken about, which was 1 month afterward. FOQA data would help to identify the frequency and circumstances of stall warnings, which would result in improved checklists and procedures. The other two U.S. operators of Q400s were regional airlines, but neither had a FOQA program, so Colgan was not able to benefit from their safety data on stall warning occurrences. FOQA is well established at major airlines. However, at the time of the accident, the FAA had made no systematic attempt to determine whether newer or smaller airlines, including regional airlines, were participating in FOQA programs, and whether newer aircraft, including the Q400, were included in FOQA data monitoring efforts. Also, the FAA had not surveyed the Part 121 air carrier fleet to determine how many airplanes are quick access recorder capable. Without installed QARs, FOQA implementation could be more expensive and time consuming. In October 2009, FAA data showed that FOQA data was available for 43% of airline aircraft. However, only 5 regional airlines had FOQA programs planned or underway at that time. In December of 2009, the FAA administrator asked operators without FOQA to implement the program. Last week, the FAA said that 35 out of 100 air carriers had committed to having FOQA programs, and that 11 of those carriers had agreed to start FOQA programs within the last 6 months. FAA said when these carriers have implemented FOQA, they will represent 94% of the commercial fleet. This is more than double the number of airplanes reported to have FOQA recorders 3 months ago. However, FOQA remains a voluntary program, and staff has proposed recommendations in this area. Let me now move to the subject of FAA oversight and SAFOs. FAA records of oversight activities at Colgan showed no deficiencies related directly to the accident. However, Colgan's significant growth between February of 2007 and February 2008 required surveillance retargeting by FAA. During that time, the company added 15 new Q400s to its fleet and hired a large number of pilots to fly the airplane, which represented a 30% increase in company size. However, additional inspectors were not assigned full-time for Q400 surveillance. This additional oversight was also warranted because the POI described the safety culture at the company as not proactive, and the APM described the company as similar to a startup airline. Colgan has 30 additional Q400s on order, continuing the company's expansion and rapid growth. The POI received his Q400 training in 2007, which was the same time that Colgan line pilots were being trained. And the first Q400 APM was replaced by a new APM who was trained on the Q400 in 2008, after Colgan had begun service with the airplane. Although these FAA and aviation safety inspectors were experienced pilots, they were responsible for overseeing the newly introduced service of an airplane, including proving runs for which they were not previously qualified and had not flown except during simulator training. As a result, the inspectors had to continue to become familiar with the airplane while they were conducting their day-to-day management of the certificate. The rapid expansion or growth of an air carrier could affect its training programs. However, the POI did not recommend that the company provide remedial or supplemental training to the accident captain or other pilots with persistence training deficiencies, even though SAFO 06015, issued in 2006, recommended the implementation of such training. In fact, he was unaware of the SAFO. Most of the company check airmen interviewed did not have Part 121 experience other than at Colgan. This situation warranted additional FAA oversight of Colgan's check airmen and aircrew program designees to ensure that training and checking standards were not affected by pressure to upgrade pilots to Q400 captains or to train newly hired pilots as Q400 first officers. Q400 qualified FAA inspectors from all FAA regions at Part 142 training centers could have augmented the certificate's inspectors and provided further quality assurance. Both the Department of Defense and the International Air Transport Association conducted audits which required corrective actions by Colgan, but the POI did not get copies of these audits and did not fully understand their content. He believed that IATA's findings were minor and that a DoD issue was not within the scope of his responsibilities because it wasn't mandated by the FAA. Colgan's internal evaluation program was found to be deficient during these audits. A sound internal evaluation program would have identified the significant training records errors found during the investigation. The issues, however, with Colgan's IEP have since been corrected to the satisfaction of those auditing organizations. According to FAA Order 8000.87A, SAFOs contain important safety information that is often critical. However, SAFOs are not included in inspectors' work programs because, according to the FAA, its inspectors are heavily tasked. The FAA does not routinely track whether the recommended actions included in SAFOs have been adopted, citing inspector workload as a reason. Also, FAA is not required to measure if a SAFO has achieved its intended result. Staff has proposed recommendations in this area. That does conclude my presentation.
Thank you, Captain Cox. Member Sumwalt.
Thank you. While we're on the topic of FAA oversight, in December of '09, Colgan's headquarters moved from Manassas to Memphis, and the Certificate Management Office of the FAA is still basically out at Dulles, Washington Dulles. Is that true?
Yes, that's right.
Now, do we have concerns? I know that in the case of, say, U.S. Airways, which you and I each used to fly for, the Certificate Management Office for that airline is in Pittsburgh, but the major operations for U.S. Air are Charlotte and Phoenix, the major training bases and major operations bases. And so do we have concerns about this long-distance type of surveillance by the FAA?
Very much so. The industry, as you well know, is quite dynamic. We have people that pick up new routes and new code-share partners and change routes all the time, and headquarters move and training centers move. This seems to challenge FAA CMOs to try to figure out where do we place our inspectors to get the most bang for the buck. We certainly have encountered other accidents or other incidents that we've looked into where they had the same problem, where inspectors were located, for instance, in Chicago, and yet now all the training was being done in Charlotte and all the flying on the East Coast, and the inspectors always told us that this was really tough.
Yeah, I have a personal concern about that, so I appreciate your candor on that. At the public hearing, the Principal Operations Inspector, the FAA POI that was overseeing Colgan, stated that he was concerned about the lack of detailed information in Colgan's training records. He had other concerns, saying that he felt that the pilots may not be providing enough information through their ASAP program, enough feedback to the company through their reporting programs. He felt that the company was more reactive than he'd like to see, not quite as proactive. So when POIs aren't comfortable with things, what can they do to get comfortable? Are they being constrained? Are they having their hands tied in doing their jobs? What's the deal there?
I think in a nutshell, POIs are asked to do an awful lot with very limited resources. And as a result, if they don't have the power to say no, and they don't take the authority to say no, you're not ready, you're not going to take this operation, they do the best they can to keep up, but things do slip through the cracks. So I think this is an important point. Backing up the POI up through his chain of command in the FAA is very important.
Thank you. I want to go to the issue now of, well, let me ask you this. Recently, I had the opportunity to sit down with some FAA folks a few weeks ago, and we had made a recommendation recently to seek specific authority for something, and the FAA folks said, well, we don't really go to Congress and seek authority. So I see that we've got a proposed recommendation here. Mr. Howder, perhaps you would answer this, but what are we asking when we say seek specific authority, and the FAA is saying, well, we don't go to Congress and ask for authority. So how would you like to answer this question?
I'll probably defer to our general counsel, but it's my understanding that the FAA can seek authority if they choose to. But I'll defer to Gary.
Member Sumwalt, I think what staff is referring to is sort of the origins of the FOQA sharing program with the FAA. The FOQA program is basically built on a federal statute and an FAA rulemaking exercise that built the underpinnings of protecting the data that came in. One of the concerns that almost any industry has in sharing proprietary data with the federal government is that the federal government will not be able to protect it in the face of FOIA. There are provisions under FOIA where you can, but where that proprietary nature is somewhat ambiguous, sometimes it's better to have what's called an Exemption 3 statute to protect it under FOIA, and that Exemption 3 says if another statute prohibits its release, you can protect it. Well, interestingly, Congress, presumably at the request of the FAA, back in 1996, gave them a statutory B3 exemption for voluntarily provided safety data. That resulted eventually in 2001 in a formal rulemaking exercise within the FAA to address that voluntarily submitted data. So currently, they have provisions to protect under FOIA, in the face of FOIA, that FOQA data that comes to them that's shared with them by other airlines. So I believe staff is saying that if you make it mandatory, you potentially shake the foundation of the current FOQA structure, and you may need to go back to Congress for a revamping of the original statute, and then that would be followed by another rulemaking exercise.
Thank you, Mr. Halbert. And I just want to make sure that given that the FAA officials had voiced that we weren't asking them to do something that was outside of our authority to ask them to do that, or more importantly, outside of their authority to go to Congress and seek that statutory authority.
Member Summerall, we have issued recommendations to other DOT agencies such as Federal Railroad, Federal Transit Administration with regard to fatigue, asking them to seek authority. So it's not an unprecedented activity on the part of the Safety Board.
And thank you very much, Mr. Marcus. Thank you for that. To be clear, we do have a proposed recommendation for Part 121, 135, and 91K operators to routinely download and analyze all available sources of safety information as part of their FOQA programs to identify deviations from the established norms and procedures, and then provide appropriate protections to ensure the confidentiality of the de-identified aggregate data, and to make sure that the information is used for safety-related, not punitive purposes. And what do we mean by all available sources of safety information? Spell that out for me, please.
Well, essentially, this is the same recommendation we made for the helicopter emergency medical services. And taking a look at how technology has changed in the helicopter industry, they have small boxes that record video, audio, and data for the helicopters. It's being installed on Bell and Eurocopters now. Technology is changing greatly. Things are becoming more easier to use. And so staff believes that to the greatest extent possible, FOQA is an extremely powerful tool. We've shown it has prevented accidents. It's found many glitches in the system been cured. And therefore, all data available should be collected and analyzed to help further safety. But at the same time, we recognize that data needs to be protected such that it will not be used to the detriment of people who want to improve safety.
Are you referring specifically to using cockpit voice recorders in a FOQA program?
It can include cockpit voice recorders, yes, sir.
You know, I want to say that I was opposed to this, badly opposed to this idea when I heard about it in the public hearing. And I voiced that in the public hearing. Since then, though, we have seen proposed legislation that would be viewed by pilots as being rather onerous, punitive. And I won't comment on proposed legislation. That's not what we do here. But I think this train's going to move out of the station. This train is going to move. Somebody's either going to require cockpit voice recorders to be used in a punitive fashion, or we can come out and make a recommendation that they be used in a safety environment. And I have been a long proponent of FOQA programs. Used to work in a FOQA office analyzing FOQA data. And I do believe that those programs definitely have safety benefits. So although I don't like the idea of downloading cockpit voice recorders, I think if it is done in a non-punitive fashion and used to supplement safety data, I will support it. Thank you.
Vice Chairman Hart.
Thank you. As some of you may know, this subject is near and dear to my heart because that statute that General Counsel Halbert talked about, that was FAA reauthorization 1996, I was the one who spearheaded the legislation to protect that information from Freedom of Information Act if it were voluntarily given to the FAA. So first of all, that certainly has a lot to do with your question, Member Sumwalt, about whether the FAA has authority to go to Congress, because that's exactly what we did back then to get that legislation. In fact, since I knew the NTSB always wore a white hat, because it's the only agency I ever knew that went to Congress with a budget and came back, the budget came back from Congress bigger than what it went, I figured, wow, we'd have even a better chance of getting this legislation if we went and did it jointly with the NTSB, which we did. So that's why the NTSB now has the same protection of regarding voluntarily supplied information. The operative word there was voluntary, however. So that's my concern with this approach to mandate FOQA, because FOQA has been a marvelously successful program, and as the slide shows, it's reached 94% of the flying of the commercial fleet. Question is, that hugely successful program that resulted in a 65% reduction in fatal accident rate in only 10 years in an industry that in 1997, at the beginning of that 10 years, was already considered very safe. The question is whether going after that other 6% by mandating it is going to possibly kill the whole program, because, as General Counsel has said, if the information is mandatory, I believe I agree with his analysis that the protection is probably going to be lost, which I think could significantly undercut the program. So I'm obviously not going to vote in favor of mandating FOQA unless we can have some assurance of getting this legislation that would protect it, which frankly I'm not sanguine about, because I think FOQA has been such a huge success story. I'd hate to throw the baby out with the bathwater by rewarding that wonderful success with mandating it. I think that would be a huge mistake. Irrespective, I mean, first of all, I don't think the FAA is going to do it, but I think it looks bad for us to even propose it, because I think we stand the chance of looking like we want to throw the baby out with the bathwater. I would be interested in knowing what was the reason we made the recommendation to the FAA about encouraging more use of FOQA amongst the regionals. What was the reason that was closed acceptable?
The recommendation was closed acceptable because the recommendation asked that POIs be notified and encouraged to encourage their assigned carriers to do it. The FAA issued a SAFO that was distributed to the POIs that said, FOQA is a good program, please do it.
Did we have any indication that more regionals, I think you've mentioned this in the report, but frankly I've forgotten, whether more regionals signed up for FOQA as a result of that effort? Or do we just know that the POIs did what they were asked in the recommendation?
We know that the POIs were informed, which was what the recommendation asked for.
Thank you.
I don't understand the metric that 94% of the fleet is covered. In the report, we talk about how many carriers have FOQA and how many regional carriers have FOQA. And to me, I thought that quite a few regional carriers were lacking FOQA programs. So can you explain that 94% number?
Well, I think it's incumbent on the FAA to explain that number, since it only came out last week in a press release without any direct response to us when we asked about it. What we do know is that we have hard numbers from October 26th of last year, only 3 months ago, that indicated that 3,100 airplanes out of a airline fleet of approximately 7,146 airplanes actually had FOQA recorders. So that's really 43%. So we're saying in 3 months' time, it's suddenly more than doubled. I think we must be talking probably, although I have to read between the lines here, about some sort of verbal commitments that have been made in the 11th hour, prior to this board meeting, and I think to the extent that people have made these commitments, that's commendable and that's wonderful. But most of those 11 that were cited as newly joining were regional airlines that had just refused to go along in the past for one reason or another. So I don't necessarily think that you can simply take these assurances that, yes, I'm going to go forward in this program is something that really was voluntary. I think it's very important to recognize that you have to follow through on these programs. You can't just put it down on paper and say, I have an I&O plan, and then never implement the program. It's rare that the ones who most need to do the voluntary work are oftentimes the ones who are least likely to actually follow through and do it. So that's why we're moving towards mandatory.
Mr. Hatter, did you want to say something?
No, I agree. We cannot justify that number. We've looked at it, and we're not sure how it was derived. But also I want to point out that we've seen many times in the past where FOQA programs have been shut down for extensive periods of time due to issues within a company. During that time period, the data didn't flow, and we believe the safety was reduced. That's one of the reasons we want to push for having these programs. Let's make sure they stay intact. However, they do need some type of protections to ensure the data is used appropriately.
Can a carrier say they have a FOQA program but not equip their entire fleet?
Well, as a perfect example, there's a regional airline that is nominally a FOQA carrier, has 260 airplanes, and only has 10 actual airplanes that have FOQA recorders. So if you choose to creatively interpret that, you can say that all those passengers and all those miles and all those airplanes with that airline are counted as a FOQA operation, but it's very misleading.
Vice Chairman, do you have a comment?
Yeah, I don't mean to interrupt, but that 94% number actually surprised me too. I was wondering, did it mean that carriers carrying 94% of the U.S. passenger traffic have FOQA in at least one of their airplanes or something like that?
Yeah. I think the challenge is in the fact that the answer to the call to action was published last week, and we have not received a lot of support documentation that's behind some of the positions that have been taken in a summary document. So let me get on to a couple of questions. We made a recommendation after the Pinnacle accident in Jefferson City. A0709 asked FAA to require all 14 CFR Part 121 operators to incorporate in their oversight program periodic LOSA observations on methods to address and correct findings from the observations. In their response to us, FAA stated that LOSA was not necessarily the only way in which an operator could accomplish oversight of the safety of its operations, and that the most effective response to this recommendation is implementation of a safety management system that includes safety audits as a key element. We responded to them that we believe that in the benefits of establishing and operating an effective SMS system, especially if it included a LOSA program. What's the status of our recommendation for the FAA to require SMS for all operators?
The recommendation is currently open acceptable. We have their letter from April of 2007, and we haven't received any further updates.
Have they published a final rule on SMS?
They have not. They originally had a date of the beginning of 2009. They missed that date. I know that they are working on it. I don't believe there's an NPRM that's yet been issued.
And we're out of compliance, the United States is, with ICAO requirements because we don't have SMS programs, correct?
That's my understanding.
Dr. Bryan, you want to say something?
I was just going to jump in and say that the FAA issued a advance notice of rulemaking, right, proposed rulemaking this summer to solicit input on SMS from industry.
Right. I think my interest is the final rule because as many times we get advance notices or notices, it's really incumbent upon them to actually pull the trigger and finish it and not just keep talking about it. We made it that with that recommendation, the FAA responded to us that they thought SMS was effective because it includes safety audits as a key element. It seems the FAA thinks that safety audits are a key element of the SMS program, but yet there were audits of carriers right now, including 2 in this situation, that weren't necessarily made available to the FAA, nor did they seek them and incorporate them into their oversight activities. What will change in the future, and do we expect FAA to benefit from that information gleaned in audits, absence having an SMS structure? And I'd like to add that at least one of those audits was paid for by the U.S. taxpayers through the Department of Defense. And so other government agency audits, how does the FAA incorporate those into their oversight activities?
Yeah, the POI said in the public hearing that it was ironic he had to approve the auditor to ride the jump seat, and yet he couldn't have access to the results of the audit other than just a verbal briefing. So, I mean, the short answer is the FAA really doesn't have an official means of obtaining these audits, and it's something that we have to understand better, and I believe we're going to look into in the future.
Okay. Let's talk about the FAA's answering the call to action document. I was struck when I read it that on page 4, they stated that The Buffalo accident, in quotes, revealed previously undiscovered risks that the FAA is addressing in their call to action. Are there any new issues that are being addressed in the call to action that the NTSB hasn't addressed in prior recommendations?
Well, I can think of.
On the call to action, they had a plan that contained a number of initiatives that were to be undertaken by the industry. I know that we just received the report last week, and we haven't had an opportunity to incorporate their actions, and we'll talk about that when we move to further consideration. But Administrator Babbitt did very quickly, after he was confirmed, convene an ARC, and I talked about how they jettisoned the commuting issue from their fatigue ARC early on, but they convened an ARC with a short fuse, with a 45-day fuse, and they were going to kind of really quickly put out some information on fatigue, flight, and duty time modifications. That kind of kept getting pushed, and then the discussion was that it would come out in the beginning of the year. I heard last week that now we're looking at the spring. What does this bode for how well we're going to get this accomplished, this fatigue issue?
Staff has heard April, and like you, staff is waiting and hoping that it does arrive on time.
Perhaps we'll have another opportunity to assess the on-time departure and delivery arrival of this. The training program review guidance. FAA said it was going to publish a SAFO on conducting a training program to review of training program review in the context of a safety management system. To date, the SAFO hasn't been published, and the draft of the SAFO was contained in the FAA's report last week. Have you all had a chance to review the SAFO, the draft SAFO that they published, or maybe not prepared to comment?
Staff hasn't had an opportunity to do that.
I'm a little bit, I think my skepticism is whether or not the SAFO is going to accomplish anything. Unfortunately, we have a history of seeing the FAA act on things that we're asking them to require or have as a mandatory directive. They issue a SAFO, we close our recommendation, just like on sterile cockpit. We closed it based on a SAFO. A couple months later, we have ComAir. We have other accidents. We in our public hearing on the remedial training, the POI for Colgan said he wasn't even aware of the SAFO on it. And so I really question whether or not SAFOs have the ability to do what we expect. It says that in that SAFO that they were going to do this program review in the context of a safety management system. But we just talked about that there's no requirement for a safety management system, nor is there final guidance on how it's supposed to be implemented. This is a little bit confusing to me, and so it seems that the FAA is being slightly disingenuous about how this is going to occur by referencing an SMS and a SAFO. How do we think they're going to pull this off?
I think the bottom line is we don't know. We're as confused as you are, and we're anxious to see what comes up.
Okay. Do my colleagues have additional questions? Okay. Chris, it's okay. I can yield to you. I'm on a tear on the call to action. Should I keep going? Yes. Okay. The air carrier's commitments to the most effective practices. When they had the initial call to action, they met with a number of Part 121 carriers, and based on reports by the FAA, a number of verbal commitments were made by the carriers on pilot records, FOQA, and ASAP programs. For the record, was NTSB a participant in this action meeting?
No, we were not.
So then they sent a letter out to all the 121 certificated carriers. Of the 101 carriers, 3 aren't in business anymore, so there's 98 of them. They received responses from 80 of the carriers. Have you all seen the responses to the survey that they sent out?
Well, there are several different surveys, so we want to make sure we specify which ones. The first one they sent out, which was in March in response to our essential initiative there, it was due in 90 days. We asked for it, and we only received it about 2 weeks ago. And there were only 36 responses of all of the carriers, and only 12 of those appeared to give indications that they actually had a remedial program. However, that's been a moving target throughout the year as we've conducted our investigation. The numbers keep piling up. But the bottom line is we are a week before the board meeting, and we have a press release that says now everybody's in compliance, but we don't have evidence that that's really the case. We certainly have received some of the information, including a follow-up order that was sent out. We
have
don't
we
have
asked for the additional information?
Oh, sure.
We've asked for it. Have we received it?
We have received a response, but we haven't received the information that was only released last Thursday. We're in a state of having partial information, but not complete information that allows us to say, oh, sure, that's fine, you did a good job.
All right, so when we're talking about their focused inspection initiative for identifying, tracking, and training low time and poor performing pilots, FAA directed its POIs to hold meetings with carriers to encourage them to develop systems if they didn't already have them in place, and this was issued in a notice. But if you read the notice, it says it's a one-time focused review. But the FAA is putting forward that they're going to be tracking corrective actions with the ATOS system. Are they sending conflicting messages?
We're in the tough position of trying to analyze information that we only just received, and I might add that the results of the most recent so-called survey of the carriers was also released, just last week to the public. And if you read through it, they asked many questions, but they didn't ask the simple question: do you or do you not have a remedial program that conforms to the SAFO? They didn't ask that question. So we have a lot of mixed information out there that needs some real analysis before we can give you a credible answer that says, okay, yeah, this is really working. And in the absence of that, we think we have a perfectly good idea, which is a recommendation. It says let's go forward with this, with the original recommendation, A0514.
And my last question is, can we close any of our outstanding recommendations to the FAA based on their call to action or their answer to the call to action?
I think the answer to that is we can't say until we have a chance to really analyze the information that's out there. And there's a lot of information, and it's there. From what I've been able to see, I can't go and find a recommendation that says do A, and in their call to action they say 100% of people do A.
We don't have the supporting data to even understand what the position that they've taken in the report that was produced last week is.
That's correct.
Okay, thank you. Member Sumwalt.
Yes, is it an ICAO, has ICAO established FOQA as a standard?
Yes.
Yes. So what does that mean if ICAO has established something as a standard, and they did that in 2005? What does that mean?
It means that we're a signatory state to ICAO. If we don't do what the ICAO says is standard around the world, we have to publish an exception and say we do it differently. Here's how we do it. Other states, of course, can do the same thing, and we find that some other states have actually gone forward and adopted the ICAO standard.
So what does that ICAO standard say? Does it state that FOQA programs will be mandatory, or that they will be established, or what does it say?
I don't have the language right in front of me, so I don't think it's fair for me to try to tell you exact language.
Okay, thank you. That's fair enough. The question. Let's just do the math on this. I don't know where this 94% came from, and I don't believe it because. Yeah, well, I'll just do the quick math on it. 50% of airline departures are regional carriers, and 25% of all traffic in the United States, all passengers, are on regional carriers. But only 2 of the 27 regional carriers have FOQA programs. So I was never really good at math, but I can't figure that one out even if I was good. So I don't care if it's 44% or 94%. We have long held a standard here at the NTSB that we are looking for one level of safety. And until 100% of those carriers have FOQA programs, I'm not going to be happy. What I worry about is even if it was 98%, I worry about the bottom feeders. I worry about that 2% that doesn't have it, because the traveling public deserves and they expect one level of safety regardless of which 121 carrier they walk out and get on. So I am supporting the notion that it should be mandatory. We had a board meeting 3 years ago. Steve Cheelander was sitting right here, and this came up in Pinnacle 3701. And Steve was sort of urging us to go towards mandating FOQA, and I didn't think it was a good idea at the time. But 3 years have elapsed. Not a whole lot has happened as far as the regional carriers getting on board with FOQA. So I'm prepared to approve it as a mandatory program. I realize that that gets into legal aspects about now that it's mandatory, then maybe that information can be FOIA'd and things like that. Our job is to point out deficiencies and let other people figure out how to implement it. Thank you, Madam Chairman.
Vice Chairman Hart.
Thank you. I think we would all agree that 100% would be desirable for FOQA. The question is whether perfect could be the enemy of the good if we're already covering some large number, and I don't know whether it's 94% or not, but let me tell you where that number comes from, and these numbers are not confirmed by me, so this is just what we heard from the FAA when I made this inquiry a few days ago. Of the 82 121 operators, 22 currently have both FOQA and ASAP programs in place. 28 have ASAP and state their intention to implement FOQA. No indication of when. 10 operators with ASAP did not state their intention to implement FOQA. 19 operators who have neither program at present stated that they will establish one or both. And 3 operators stated that they do not intend to establish either FOQA or ASAP. So that adds up to the 82. Then in terms of airplanes, and again, this is unconfirmed, and we can have staff look into these. 98% of aircraft operating under Part 121 are flown by operators that have or intend to implement ASAP. 94% of aircraft operating under Part 121 are flown by operators that have or intend to implement both ASAP and FOQA. So that's the numbers that I have, and I'll give them to you guys to dig into. So again, that's not confirmed on my part, but that's just that. Apparently, that's where the 94% comes from.
So there's the trick there, is that I'm talking about which ones have it, not which one intends to have it. My wife will be quick to tell me that the road to hell is paved with good intentions. I want to know how many people have it.
I'm not defending the numbers. I'm just telling you what the information was that we got from the FAA, which apparently backs up this 94% number that we've received.
Thank you, Vice Chairman, for sharing that information with us. Staff, one question that I have for you all, does Colgan have a FOQA program?
I think that's a good question and right on point. When we asked the POI in a public hearing, he said that they had 1 step out of 10 moved forward. Afterward, we found out, yes, in fact, they have on paper, they have approved. They had an I&O plan, implementation, and operations plan that says all these things we're going to do, but actually very little had actually been done. Since that time, of course, they've moved quite rapidly. I think they've had good motivation to move rapidly, and that's all well and good. But unfortunately, you can go out and get approved on paper, and then for one reason or another, just never move forward. And I think that's where we were.
But my question is, does Colgan have a FOQA program right now? Do they have an actual FOQA program that's in operation?
There are stages. Mm-hmm. They're further along than they were. One of the key elements that they had just announced is that they have now got an agreement in principle with the ALPA.
Has it been signed?
An MOU hasn't been signed.
Okay, they don't have a FOQA program yet.
And they're not collecting information that can then in turn be analyzed and used to tell you how you're doing.
So I think kind of the experience that I've had at the board is fool me once, shame on me, or fool me once, shame on you, fool me twice, shame on me. And I remember at the public hearing last May, they told us they were going to have FOQA program by July. And as you all were working on the report, you all were checking in with them, constant updates. I see that they received 14 QARs for its Q400 fleet, so that means that it's not going to equip its entire fleet of aircraft. It's going to equip certain aircraft, and that they were working on the equipment and the agreements, and it still hasn't been executed, is my sense from you all. So I think, unfortunately, we've seen in a number of accidents, unfortunately, those regional carriers that have FOQA programs, do you know who they are? I think one of them's Pinnacle.
Yes.
They were the recipient of our recommendation, and we had a public hearing, and they were put on the spot about getting an ASAP FOQA program, and they, you know, ultimately ended up getting one. It took longer than they thought, but here we are with Colgan in the same posture. What about all of the other regional carriers? Do we have to wait until they have an accident and have them appear here for us to get them to move on a FOQA program?
It does seem to be a motivator.
Okay. Any additional questions from my colleagues? Vice Chairman.
The analog that occurs to me is when ground proximity warning systems were $200,000, $300,000, $500,000. We were happy to recommend their implementation on $80 or $100 million airplanes, but recognize that it's not practical to recommend their implementation on a $2 million airplane, and so we did not. Just in this case, I think a lot of the holdup for FOQA for smaller carriers is that there are a lot of fixed costs associated with it that make it not as practical for a smaller operator as for a bigger operator. So I wonder if we could explore a couple of options. For example, having the smaller carriers work together as a collective to not have to each pay the full cost of a FOQA program, but to share and to have information going into joint FOQA programs. Or another option would be an example that 777 owners showed was very successful when the Boeing 777s first came into operation, is that the 777 owners got together and sat around the table to share their experiences on this new airplane, and they brought the operators, and they also brought Boeing as the manufacturer and the pilots, and they all sat at the table together and shared their experiences on this new airplane so they could learn about the quirks of the new airplane and learn from each other, so every operator didn't have to have a problem and fix it before it got fixed, because now they're relying on the collective experience of all the operators collectively who have that airplane. So that allows people to learn about problems and fix them before they actually experience the problem. So those are some examples of alternates that occur to me, because my impression is that the resistance to FOQA is the large fixed cost relative to the size of the carrier. So I wonder if we could explore that rather than, you know, making the perfect be the enemy of the good.
And I wonder if perhaps this might not be an issue that we could address in our code sharing event, if there are any agglomeration economies of scale associated with major carriers having already established FOQA programs and parameters and staff and equipment.
May I offer one comment in response to what you said? FOQA's evolved, and you know what you're talking about is certainly true. I mean, the initial cost in getting started, we had the demo project program that got the carriers initially started, and that was all very well and good. Today, there are outside vendors who actually provide software analysis on a fee-for-service basis. They're available for some people who may have problems in terms of doing the software analysis. And I might simply add that sharing of information between carriers is something that's part of our recommendation, and it's something that I know your SIS team does to some extent using FOQA data, but you have to start with the data. The Q400 is an airplane that has no FOQA data collected in the United States at all today, because the only operators are regional carriers and none of them have FOQA programs. So there's a big hole there that needs to be filled. No data, no sharing.
That's a very good point. And when I talked about the sharing with the 777s, it didn't rely mostly on FOQA. It was relying mostly on pilot reports. It's actually in that same sense. So I'm glad you raised that point. Also, you raised a point about FOQAs becoming less expensive, and that's true with ground proximity warning systems, which are now on big airplanes and small airplanes. It's the same concept.
Yeah, there's sort of an economy of scale that's been taking place. FOQA was a pretty mature program. In the early days, we all had doubts about whether or not the confidentiality could be preserved. We all had doubts whether it was really going to be valuable. We've received, had a pretty good momentum now. We've had 20 years of experience with this, and a lot of the objections have been overcome as long as it's run properly. So I think we can say now with more confidence than we used to that everybody needs to go ahead and get on board here.
Well, to the chairman's point, which is a very good one, maybe we could explore whether they could have their co-chair help them with the implementation of a FOQA program. That's something we might explore in that co-chairing meeting.
We'll add that to the list.
Thank you, Mr. Howder. Do I have any additional comments or questions from the board members? Seeing none, I believe that was our last staff presentation. Excellent job by all, and it is not yet 5 o'clock. We will go ahead and take a 15-minute break, do some switching, and be ready for consideration of the conclusions, probable cause, recommendations, and adoption of the report. Conclude.
Hour. I think we'll be lucky to get out of here by 6:30.
Thank you. Dr. Meyer, will you now read the findings of the investigation? If any board member has any questions or comments, please let me know after all of the findings are read. I recognize there's a lot of findings, so we'll do all of our changes at the end.
Yes, ma'am. The staff are proposing 45 findings. I'll read each of them. Number 1, the flight crew was properly certificated and qualified in accordance with applicable federal regulations. 2, the airplane was properly certified, equipped, and maintained in accordance with federal regulations. 3, the recovered components showed no evidence of any pre-impact structural, engine, or system failures, including no indications of any problems with the airplane's ice protection system. 4, the air traffic controllers who were responsible for the flight during its approach to Buffalo Niagara International Airport performed their duties properly and responded immediately and appropriately to the loss of radio and radar contact with the flight. 5, this accident was not survivable. 6, the captain's inappropriate aft control column inputs in response to the stick shaker caused the airplane's wing to stall. 7, the minimal aircraft performance degradation resulting from ice accumulation did not affect the flight crew's ability to fly and control the airplane. 8, explicit cues associated with the impending stick shaker onset, including the decreasing margin between indicated airspeed and the low speed cue, the airspeed trend vector pointing downward into the low speed cue, the changing color of the numbers on the airplane's indicated airspeed display, and the airplane's excessive nose-up pitch attitude were presented on the flight instruments with adequate time for the pilots to initiate corrective action, but neither pilot responded to the presence of these cues. 9, the reason the captain did not recognize the impending onset of the stick shaker could not be determined from the available evidence, but the first officer's tasks at the time the low-speed cue was visible would have likely reduced opportunities for her timely recognition of the impending event. The failure of both pilots to detect this situation was the result of a significant breakdown in their monitoring responsibilities and workload management. 10, the flight crew did not consider the position of the reference speed switch when the stick shaker activated. 11, the captain's response to the stick shaker activation would have been automatic, but his improper flight control inputs were inconsistent with his training. My apologies, number 11 should read, the captain's response to stick shaker activations should have been automatic, but his improper flight control inputs were inconsistent with his training and were instead consistent with startle and confusion. 12, the captain did not recognize the stick pusher's action to decrease angle of attack as a proper step in a stall recovery and his improper flight control inputs to override the stick pusher exacerbated the situation. 13, it is unlikely that the captain was deliberately attempting to perform a tailplane stall recovery. 14, no evidence indicated that the Q400 was susceptible to a tailplane stall. 15, although the reasons the first officer retracted the flaps and suggested raising the gear could not be determined from the available information, these actions were inconsistent with company stall recovery procedures and training. 16, the low-speed cue, the activation of the stick shaker, and the captain's aggressive and inappropriate response to the stick shaker do not support the need for a redundant low airspeed oral alert. 17, the captain's failure to effectively manage the flight, 1, enabled conversation that delayed checklist completion and conflicted with sterile cockpit procedures, and 2, created an environment that impeded timely error detection. 18, the monitoring errors made by the accident flight crew demonstrate the continuing need for specific pilot training on active monitoring skills. 19, Colgan Air's standard operating procedures at the time of the accident did not promote effective monitoring behavior. 20, specific leadership training for upgrading captains would help standardize and reinforce the critical command authority skills needed by a pilot in command during air carrier operations. 21, because of the continuing number of accidents involving a breakdown of sterile cockpit discipline, collaborative action by the Federal Aviation Administration and the aviation industry to promptly address this issue is warranted. 22, the flight crew member's performance during the flight, including the captain's deviation from standard operating procedures and the first officer's failure to challenge these deviations, was not consistent with the crew resource management training that they had received or the concepts in the Federal Aviation Administration CRM guidance. 23, the pilot's performance was likely impaired because of fatigue, but the extent of their impairment and the degree to which it contributed to the performance deficiencies that occurred during the flight cannot be conclusively determined. 24, all pilots, including those who commute to their home base of operations, have a personal responsibility to wisely manage their off-duty time and effectively use available rest periods so that they can arrive for work fit for duty. The accident pilots did not do so by using an inappropriate facility during their last rest period before the accident flight. 25, Colgan Air did not proactively address the pilot fatigue hazards associated with operations at a predominantly commuter base. 26, operators have a responsibility to identify risks associated with commuting, implement strategies to mitigate these risks, and ensure that their commuting pilots are fit for duty. 27, the first officer's illness symptoms did not likely affect her performance directly during the flight. 28, the captain had not established a good foundation of attitude instrument flying skills early in his career, and his continued weaknesses in basic aircraft control and instrument flying were not identified and adequately addressed. 29, remedial training and additional oversight for pilots with training deficiencies and failures would help ensure that the pilots have mastered the necessary skills for safe flight. 30, Colgan Air's electronic pilot training records did not contain sufficient detail for the company or its principal operations inspector to properly analyze the captain's trend of unsatisfactory performance. 31, notices of disapproval need to be considered along with other available information about pilot applicants so that air carriers can fully identify those pilots who have a history of unsatisfactory performance. 32, Colgan Air did not use all available sources of information on the flight crew's qualifications and previous performance to determine the crew's suitability for work at the company. 33, Colgan Air's procedures and training at the time of the accident did not specifically require flight crews to cross-check the approach speed bug settings in relation to the reference speed switch position. Such awareness is important because a mismatch between the bugs and the switch could lead to an early stall warning. 34, the current air carrier approach to stall training did not fully prepare the flight crew for an unexpected stall in the Q400 and did not address the actions that are needed to recover from a fully developed stall. 35, The circumstances of this and other accidents in which pilots have responded incorrectly to the stick pusher demonstrate the continuing need to train pilots on the actions of the stick pusher and the airplane's initial response to the pusher. 36. Pilots could have a better understanding of an airplane's flight characteristics during the post-stall flight regime if realistic, fully developed stall models were incorporated into simulators that are approved for such training. 37. The inclusion of the National Aeronautics and Space Administration icing video in Colgan Air's winter operations training may lead pilots to assume that a tailplane stall might be possible in the Q400, resulting in negative training. 38. The current Federal Aviation Administration surveillance standards for oversight at air carriers undergoing rapid growth and increasing complexity of operations do not guarantee that any challenges encountered by the carriers as a result of these changes will be appropriately mitigated. 39. Mandatory flight operational quality assurance programs would enhance flight safety because all operators would have readily available data to identify operational risks and use in developing corrective actions. 40. The viability of flight operational quality assurance programs depends on the confidentiality of the data, which would currently not be guaranteed if operators were required to implement these programs. 41. The systematic monitoring of all available safety data as part of a flight operational quality assurance program could provide operators with objective information regarding the manner in which flights are conducted, and a periodic review of this information would enhance flight safety by assisting operators in detecting and correcting deviations from standard operating procedures. 42. Distractions caused by personal portable electronic devices affect flight safety because they can detract from a flight crew's ability to monitor and cross-check instruments, detect hazards, and avoid errors. 43. The current use of safety alerts for operators to transmit safety-critical information is not effective because oversight and documentation of an operator's response are not required and critical safety issues may not be effectively addressed. 44. Weather documents missing key weather products or containing products that are no longer valid prevent flight crew members from having relevant, readily available weather-related safety information for pre-flight and in-flight decision-making. And finally, 45, detailed icing definitions that include accretion rates and recommended pilot actions would help pilots more accurately determine the icing conditions to report in airframe icing pilot reports and more effectively respond to those conditions.
Dr. Meyer, thank you for that. I know you need a drink of water now. Is there any discussion from the board members?
Yes, Madam Chairman, and by the way, I only got 44 conclusions or findings. How did we jump? It seemed like we jumped around 40.
38's the new 40.
Thank you. So how many are there?
There were 45. There was, in the latest draft, one unnumbered, so it inadvertently left off. That was renumbered in the manner in which the managing director read them.
I see. So 38 was, in fact, should actually be
renumbered.
Renumbered.
Yep.
Yeah. Okay. Thank you. Yes, Madam Chairman, I have a motion. I would like to move that we add a finding to state as follows. The Q400 airspeed indicator lacked low-speed awareness features such as an amber band above the low-speed Q and or airspeed numbers that changed to amber as speed decreased towards the low-speed Q. And had such features been installed, they might have facilitated the crew's detection of the impending low-speed situation. That is my motion.
Is there any discussion? Second, any discussion? Any comments from the staff?
We have no problem with the concept. I guess might bothers us a little bit because we don't know with this cruise action what happened.
I took that wording, actually changed that wording. It was a may yesterday, and I made it a might this morning because it was consistent with some proposed language that I was handed yesterday afternoon as it might relate to low airspeed alert systems. And I think that the point is, if it did lack it, and it might have given the crew an additional heads up.
In consultation with Evan, he's fine with it, and I'll go with him.
Thank you, Mr. Howder.
We have no objection.
Thank you, Mr. Howder. Are there any other comments from the staff on the proposed conclusion? Ms. Ward, do you all need a minute to review it?
Could you give us 30 seconds, please?
Absolutely.
He's already rejected display.
No, he rejected a complete rewrite on it, so we're trying to tweak it now.
Okay. I would either one. It both seem to be the same, right?
I don't think we need the and or. I think we just need the or. I would change numbers to display, airspeed display, right? Okay, then leave it. Then let's not fight that. Then after the Q, we could go with this or your provision. Okay. 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 All right. Do you want me to read that, or do you want to read that? Could have facilitated the crew's detection of developing low-speed situations.
Yeah, they're the same. All right, we can.
Okay. You want me to read this one? Madam Chairman.
Mr. Halbert.
Staff has a proposed edit that I believe captures the essential elements of what Member Sumwalt is seeking, but it's a bit of wordsmithing.
Okay.
And this is the suggestion. Up until the word Q, it virtually stays the same. We're striking and or and just making it or. Instead of numbers, we're putting in indications, though we're receptive to that remaining as numbers, and then changing the latter part of it. So I'm going to read it straight through. The Q400 airspeed indicator lacked low-speed awareness features such as an amber band above the low-speed Q or airspeed indications that changed to amber as speed decreased towards the low-speed Q that could have facilitated the crew's detection of the developing low-speed situation.
So really, I personally do not object to the last part of that could have. I don't object to that. I'd like to see it, but I think I hear what I think you heard, something like that. But so really, we're making the and, because some aircraft, for example, the G550. Does not have the amber band, but it does have numbers that change to red, or I'm sorry, to amber. And so this had neither. And so.
Could you read that again, please?
Yes, I can. The Q400 airspeed indicator lacked low-speed awareness features such as an amber band above the low-speed Q or airspeed indications that changed to amber as speed decreased towards the low-speed Q that could have facilitated the crew's detection of the developing low-speed situation.
I have no objection to that language. I would adopt that as my proposed, my revised amendment, or correction, my revised motion.
Ms. Ward.
I just want a clarification. Is that to go in place of 16?
No, it's an additional.
And a new one? Okay.
I think it's important to point out that the primary flight display issue is a distinct issue, that even if we weren't talking about low-speed awareness cues, which, by the way, the draft report was not going to, the draft report says that that would not have helped. But even if we take the low-speed awareness issue out, the low-speed alert systems, this primary flight display still lacked those features. So I wanted to bifurcate the two. First of all, let's address the primary flight display and the fact that many airplanes older than this one have been flying around that had these features that this aircraft does not have. I want to address that first, and perhaps if the board wants to entertain the low-speed alert system, we can do that in just a moment. But I think they're distinct but complementary issues.
I understand. What I'm trying to help is the writer to see where we're going to...
It's okay. We've got another amendment coming on the oral, and we'll make that motion then. Because your motion was simply to add a conclusion, correct?
That is correct.
Yes.
This is
Okay.
for an additional conclusion. And I think that we would also need some text to support that, just a little bit, but some text. So there's my motion. The revised motion is as read by the General Counsel. And there it is.
Mr. Hatter, any additional staff discussion? Dr. Berner, Ms. Ward, we ready to call the question?
Yes.
Okay. Vice Chairman, any concerns?
I'm in favor of it.
Okay, call the question. All in favor of adopting the amendment as offered by Member Sumwalt and then revised by staff, a signal with the hand and aye.
Aye.
Aye. The additional finding has been adopted. Are there any additional proposals from my colleagues to modify any of the conclusions or add any changes? Vice Chairman.
Yes, and I apologize for not having written this beforehand, but I didn't know where this was going to go, so I'm on number 39. And my motion would be, before the beginning of that, if data from, and then continue, mandatory flight operational quality assurance programs, and then add the words, were protected from disclosure to the public, comma, such programs, and then read the rest of it, would enhance flight safety because all operators would have readily available data to identify operational risks and use in developing corrective actions. And I'm happy to read that again.
Please read it again.
The additional words are in front of...
Can we just read it from beginning? Because
yeah.
I'm not even sure I'm on the right recommendation.
Number 39 starts mandatory flight operational quality assurance programs? Yes. Okay. And this is not recommendation, it's finding we're talking about. Okay. If data from mandatory flight operational quality assurance programs were protected from disclosure to the public, comma, such programs would enhance flight safety because all operators would have readily available data to identify operational risks and use in developing corrective actions.
I think we're going to have to probably read it again before we vote on it, but in case there's some changes that might go on, could we get a second on the motion? I'll second for purposes of discussion. Could we get comments from the board members first?
I just want to make sure I've got the words down so I know what I'm voting on.
Staff, do you have any changes before we start reading another version? Do we need a timeout?
That we're discussing here, I think actually it would complement the two recs we want. One is to have the data and one to have adequate protections in place. So offhand, I don't see any objections.
Okay. Is there any word smithing from the staff, or should the vice chairman read it again for a vote?
If you could read it again, I appreciate it.
Okay.
If data from mandatory flight operational quality assurance programs were protected from disclosure to the public, such programs would enhance flight safety because all operators would have readily available data to identify operational risks and use in developing corrective actions.
Madam Chairman, if we could take a break in place, I think the General Counsel would like to discuss this language with us. It's just
okay, I'll tell you what. Let's make sure we don't have any more amendments. So let's table this amendment. Any other changes? Any other modifications to the conclusions? I have language that has been provided by staff. I'd like to make a motion to strike unless the staff would like to do this on low speed alerts. Okay, I'm going to make a motion to strike finding 16 that says the low speed cue, the activation and the stick shaker, activation of the stick shaker and the captain's aggressive and inappropriate response to the stick shaker do not support the need for a redundant low speed oral alert. I'm proposing to strike that conclusion and to replace it with a new conclusion that reads, the NTSB the NTSB concludes that an oral warning in advance of the stick shaker would have provided a redundant cue of the visual indication of the rising low-speed cue and might have elicited a timely response from the pilots before the onset of the stick shaker. We have draft language for the report in section 2.3.3 that would accompany this new conclusion if approved.
I second the motion.
Is there any discussion?
As you know, staff was divided on this, and so this is a conclusion and words that were created by staff, so therefore we'll go with the board's determination.
Thank you. Vice Chairman, any comments? All those in favor of the motion signal with a hand and aye. 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 The motion carries. Are there any other modifications to the conclusion? Okay. We're going to take a brief rest. We're not moving. We're not going anywhere for staff to consider the Vice Chairman's motion on 39.
Jennifer, tell them it's okay with me. The family assistance program is still inactive with the family members. Did the airline provide a member to travel with them and to help them as necessary? I don't see anyone. Otherwise, you think they'd be dressed appropriately, but.
Someone from the airline?
Yeah. I don't see. I don't think so. Mm-hmm.
He's right in the middle of the second row. He's been involved with the family. Because I guess they've been at here.
Mm-hmm.
Successful accident and unsuccessful accident.
Yeah, well, that's. Yep.
Another one is first officer.
I guess those changes are okay with Kevin then, right? No problem. I can. It's okay with you.
Well, within the liberty of the board.
Is that your personal computer, or is that, Kevin, is that your personal?
Madam Chairman, the staff's ready to continue.
Staff, do you have a proposal for revisions on the tabled amendment that was offered by the Vice Chairman?
Yes, ma'am. The Vice Chairman had asked for some modifications to 39. The staff has considered that. He would add, his modification would change 39 by adding some concepts about preventing the data from public disclosure. The staff believes that that fundamentally changes 39 in a direction that is already encapsulated in 40. And thus does not fully convey what the staff is trying to communicate by 39. We believe the two findings serve as adequate and functional companions and ought to stay as we've drafted them. It would be our preference that 39 not be changed.
Okay, Vice Chairman, you have any comments?
I understand that viewpoint, but my opinion is that 39 is incorrect unless 40 happens. That's why I did it that way. Without 40, then 39 is no longer factually accurate, in my opinion.
We have 40. 40 is one of the proposed.
Right.
Right,
And
but
the conclusions, they're not recommendations.
Yeah, they're just.
We agree with you that they are both important and they both need to be read together.
Would you like to have further discussion, or would you like to call the question? Or withdraw?
Mr. Vice Chairman, if I could jump in here. On the proposal to 39, if we changed it in the direction that you were seeking to move it, it would almost become a synonym or say the same thing as number 40. I would propose this. 39, left as is, extols the virtue of requiring FOQA programs, even if those FOQA programs remain within an airline. 40 perhaps could be, we could add at the end, and if shared with the FAA to capture the concept that you're wanting to articulate, is that if you mandate FOQA programs and they're sharing with the FAA, we've got to have confidentiality of that information.
Give me the specific wording again, please.
On 40, this would be on page 262, the unnumbered 40 at the top of the page, we would add something at the end that said, and shared with the FAA.
I can go with that.
I think that doesn't read correctly. Share the data with FAA. Maybe.
Here's what I would propose. This is on 40. The viability of the flight operational quality assurance programs depends on the confidentiality of the data, which would currently not be guaranteed if operators were required to implement these programs and required to share the data with the FAA.
Any discussion? Wait, we've got a modification to 39 that's pending. Vice Chairman, would you like to withdraw it, or do you want to vote on it?
I can accept the change that's suggested by General
Okay,
Counsel.
so we need to withdraw the amendment 39.
Okay, so done. Withdraw.
And you need to move the language that was suggested by the General Counsel if you choose to do that.
Yes, I do that. I'll do that.
Second. All those in favor to adopt the revision to finding 40 as read by our General Counsel signal with the hand and aye. 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 The ayes have it. The conclusion has been modified. Are there any other modifications or changes to the conclusions? We'll take a vote on all the findings as revised. All in favor of approving the findings as revised signal with the hand and aye. 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 The ayes have it. The findings have been adopted. Dr. Meyer, will you read the probable cause as presented in the draft report?
Yes, ma'am. The National Transportation Safety Board determines that the probable cause of this accident was the captain's inappropriate response to the activation of the stick shaker, which led to an aerodynamic stall from which the airplane did not recover. Contributing to the accident were 1, the flight crew's failure to monitor airspeed in relation to the rising position of the low-speed queue. 2, the flight crew's failure to adhere to sterile cockpit procedures. 3, the captain's failure to effectively manage the flight. And 4, Colgan Air's lack of standardized procedures for airspeed selection and management during approaches and icing conditions.
Is there any discussion?
Madam Chairman, I just have a question I'd like for staff to clarify for me, if I may, please. This number 4, Colgan's lack of standardized procedures for airspeed selection and management during approaches and icing conditions. Help me to understand that. They did have procedures, but I think what you're saying is that those procedures were not, at the time of the accident, were not well known with the crew. Is that what you're saying with the crews? Is that what you're saying?
Well, we're really saying that the procedures were not adequate. The procedures didn't fully address.
Okay. And I don't necessarily want to get into wordsmithing, but the way it is now, you are saying that there was a lack of standardized procedures, but the procedures were there. So what did you just say? You said that they were not adequate?
They weren't adequate. They were inadequate.
Was this an example where the procedures were not in the checklist, if I remember correctly?
The checklist omitted some important things that were later added after the accident.
Okay, well, that's what I'm looking for. So the lack of, and again, I don't want to be wordsmithing at 6:02 in the evening, but are you saying the lack of adequate procedures? Or are you the lack of standardized procedures? Or the lack of adequate standardized procedures?
Could you give us 30 seconds, please?
We're ready.
Staff's like to modify finding number 4, Colgan's inadequate procedures for airspeed selection and management during approaches in icing conditions.
Lack of adequate, Colgan's inadequate procedures.
Right.
Is that where you are?
Yes.
Madam Chairman, I'd like to propose that as a motion that we replace the lack of standardized with says Colgan Air's inadequate procedures.
Is there a second? Second. Any discussion? All in favor, signal with a hand and aye. 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 The ayes have it. The motion has been adopted. Any other changes to the probable cause? I know. I have at the desk an amendment to modify the probable cause. I would like to insert the following after contributing factor number 4. The flight crew's fatigue due to their failure to obtain adequate rest prior to reporting for duty, and it would continue with a 5. Would you like me to read the entire thing? No? Okay. I offer this amendment. I think it's supported by by the findings that we just adopted, where we determined that the pilot's performance was likely impaired because of fatigue, but the extent of their impairment and to the degree to which it contributed to the performance deficiencies that occurred on the flight cannot be conclusively determined. I agree. It's very difficult to conclusively determine how much any of these issues were a factor in the accident, but I do think that we have demonstrated and supported that they were fatigued. I think that the facts of the investigation and our conclusions have identified that the captain and the first officer were fatigued. And like the sterile cockpit violations, which are cited as a contributing factor in the accident, fatigue chipped away at the margins of safety the crew believed would insulate them from an accident. And I believe it should be a contributing factor. So is there a second, I think, I apologize for not asking for that before. A second for my motion?
I'll second for discussion.
Sure. Any discussion? Staff, board members?
Yes, ma'am. Thank you. And I'm going, I'm just not going to go back through where we were a couple of hours ago. I think I've stated my position on this. I think fatigue was certainly present. No question in my mind, and that's what we say in conclusion in finding number 23. The pilot's performance was likely impaired because of fatigue, but the extent of their impairment and the degree to which it contributed to the performance deficiencies that occurred during the flight cannot be conclusively determined. And I think that when we get to the probable cause, we do have to be able to show somewhat of a nexus there, and in fact it would be inconsistent with finding 23 if we had put this in the probable cause due to the wording of the finding that we just adopted. So although I do believe that the crew was fatigued, I do support finding 23. Therefore, I do not support putting it in the probable cause because we could not show that that linkage between their fatigue and their performance. Again, we've got basically a two-pronged approach, two-pronged test. Were they fatigued? Yes. Did it affect their performance? We really don't know for sure. So that's my position on that. Thank you, Madam Chairman.
And I would just say that it's not inconsistent with the way that we're treating sterile cockpit in the findings. We identified that it created an environment that impeded timely error detection, and that's about as far as we can go. But yeah, we put contributing was their failure to adhere to sterile cockpit. We know the degrading effects of fatigue, and they're articulated. I don't think it's an on-off switch, and we don't have a blood test for fatigue, so we can't determine that they were fatigued 25%, 50%, 75%, but I do think that whatever your base level of performance is, if you're fatigued, it's going to have an effect on that. And I believe it did in this instant. Vice Chairman?
So that brings it down to me. I agree completely that they were fatigued. I also agree that it's not black and white. It's hard to draw a line. And with all due respect to the chair, I'm going to defer to the experts, to the fatigue experts, on the degree to which we can say that it led to these failures, many of which didn't surprise me in light of the previous activities of this captain. And I would add to that to me, the more important part is that we will have a recommendation for the FAA to address fatigue risks, because I think the fatigue risks are definitely there and need to be addressed. But I would also not agree with that we have the level of objectivity to be able to put it in the probable cause as a contributing factor.
All in favor signal with a hand and aye. Aye. All opposed? Nay. The nays have it. The motion does not carry. Any additional amendments? All in favor of adopting the probable cause as revised by Member Sumwalt, signal with a hand and aye. 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 The ayes have it. The probable cause as revised has been adopted. Dr. Meyer, will you please read the recommendations?
Yes, ma'am. Staff are proposing 23 recommendations to the Federal Aviation Administration. The first, require 14 Code of Federal Regulations, Part 121, 135, and 91K operators to review their standard operating procedures to verify that they are consistent with the flight crew monitoring techniques described in Advisory Circular 120-71A, Standard Operating Procedures for Flight Deck Crew Members. If the procedures are found not to be consistent, revise the procedures according to the AC guidance and to promote effective monitoring. 2. Issue an advisory circular with guidance on leadership training for upgrading captains at 14 Code of Federal Regulations, Part 121, 135, and 91K operators, including methods and techniques for effective leadership, professional standards of conduct, strategies for briefing and debriefing, reinforcement and correction skills, and other knowledge, skills, and abilities that are critical for air carrier operations. 3. Require all 14 Code of Federal Regulations, Part 121, 135, and 91K operators to provide a specific course on leadership training to their upgrading captains that is consistent with advisory circular requested in Safety Recommendation 2. Develop and distribute to all pilots multimedia guidance materials on professionalism in aircraft operations that contain standards of performance for professionalism, best practices for sterile cockpit adherence, techniques for assessing and correcting pilot deviations, examples and scenarios, and a detailed review of accidents involving breakdowns in sterile cockpit and other procedures, including this accident. Obtain the input of operators and air carrier and general aviation pilot groups in the development and distribution of these guidance materials. 5. Require all 14 Code of Federal Regulations, Part 121, 135, and 91K operators to address fatigue risks associated with commuting, including identifying pilots who commute, establishing policy and guidance to mitigate fatigue risks for commuting pilots, using schedules and practices to minimize opportunities for fatigue in commuting pilots, and developing or identifying rest facilities for commuting pilots. 6. Require 14 Code of Federal Regulations, Part 121, 135, and 91K operators to document and retain electronic and or paper records of pilot training and checking events in sufficient detail so that the carrier and its principal operations inspector can fully assess a pilot's entire training performance. 7. Require 14 Code of Federal Regulations, Part 121, 135, and 91K operators to include the training records requested in Safety Recommendation 6 as part of the remedial training program requested in Safety Recommendation A0514. 8. Require 14 Code of Federal Regulations, Part 121, 135, and 91K operators to provide the training records requested in Safety Recommendation 6 to hiring employers to fulfill their requirements under the Pilot Records Improvement Act. 9. Develop a process for verifying, validating, auditing, and amending pilot training records at 14 Code of Federal Regulations, Part 121, 135, and 91K operators to guarantee the accuracy and completeness of the records. 10. Direct all 14 Code of Federal Regulations, Part 121, 135, and 91K operators of airplanes equipped with a reference speed switch or similar device to 1. Develop procedures that establish that during approach and landing, airspeed reference bugs are always matched to the position of the switch. And 2. Implement specific training to ensure that pilots demonstrate proficiency in this area. 11. Require 14 Code of Federal Regulations, Part 121, 135, and 91K operators and 14 Code of Federal Regulations, Part 142 training centers to develop and conduct training that incorporates stalls that are fully developed, are unexpected, involve autopilot disengagement, and include airplane-specific features such as a reference speed switch. 12. Require all 14 Code of Federal Regulations, Part 121, 135, and 91K operators of stick pusher equipped aircraft to provide their pilots with pusher familiarization training, pusher familiarization simulator training. 13. Define and codify minimum simulator model fidelity requirements to support an expanded set of stall recovery training requirements, including recovery from stalls that are fully developed. These simulator fidelity requirements should address areas such as required angle of attack and side slip angle ranges, motion cueing, proof of match with post-stall flight test data, and warnings to indicate when the simulator flight envelope has been exceeded. 14. Identify which airplanes operated under 14 Code of Federal Regulations, Part 121, 135, and 91K are susceptible to tailplane stalls, and then 1. Require operators of those airplanes to provide an appropriate airplane-specific tailplane stall recovery procedure in their training manuals and company procedures, and 2. Direct operators of those airplanes that are not susceptible to tailplane stalls to ensure that training and company guidance for the airplanes explicitly state this lack of susceptibility and contain no references to tailplane stall recovery procedures. 15. Develop more stringent standards for surveillance of 14 Code of Federal Regulations, Part 121, 135, and 91K operators that are experiencing rapid growth, increased complexity of operations, accidents and/or incidents, or other changes that warrant increased oversight, including the following. 1. Verify that inspector staffing is adequate to accomplish the enhanced surveillance that is promulgated by the new standards. 2. Increase staffing for those certificates with insufficient staffing levels. And 3. Augment the inspector staff with available and airplane-type qualified inspectors from all Federal Aviation Administration regions and 14 Code of Federal Regulations, Part 142 training centers to provide quality assurance over the operator's aircrew program designee workforce. 16. Require all 14 Code of Federal Regulations, Part 121, 135, and 91K operators to 1. Develop and implement flight operational quality assurance programs that collect objective flight data. 2. Analyze these data and implement corrective actions to identified system safety issues. And 3. Share the de-identified aggregate data generated through these analyses with other interested parties in the aviation industry, including the Federal Aviation Administration, through appropriate means. 17. Seek specific statutory and/or regulatory authority to protect data that operators are required to share as part of their flight operational quality assurance programs. 18. Require 14 Code of Federal Regulations, Part 121, 135, and 91K operators to 1. Routinely download and analyze all available sources of safety information as part of their flight operational quality assurance program, to identify deviations from established norms and procedures. 2. Provide appropriate protections to ensure the confidentiality of the de-identified aggregate data. And 3. Ensure that this information is used for safety-related and not punitive purposes. 19. Require 14 Code of Federal Regulations, Part 121, 135, and 91K operators to incorporate explicit guidance to pilots, including checklist reminders as appropriate, prohibiting the use of personal portable electronic devices on the flight deck. 20. implement a process to document that all 14 Code of Federal Regulations, Part 121, 135, and 91K operators have taken appropriate action in response to safety critical information transmitted through the Safety Alert for Operators process or another method. 21. Require 14 Code of Federal Regulations, Part 121, 135, and 91K operators to revise methodology for programming their adverse weather phenomena reporting and forecasting subsystems so that the subsystem-generated weather document for each flight contains all pertinent weather information, including airman's meteorological information, significant meteorological information, and other National Weather Service in-flight weather advisories, and omits weather information that is no longer valid. 22, require principal operations inspectors of 14 Code of Federal Regulations, Part 121, 135, and 91K operators to periodically review the weather documents generated for their carriers to verify that those documents are consistent with the information requested in Safety Recommendation 21. 23, update the definitions for reportable icing intensities in the Aeronautical Information Manual so that the definitions are consistent with the more detailed intensities described in Advisory Circular 91-74A, Pilot Guide, Flight and Icing Conditions. Staff are also proposing that the board reiterate 3 recommendations in this report. The first would be A05-1, require all Part 121 and 135 air carriers to obtain any notices of disapproval for flight checks, for certificates, and ratings for all pilot applicants and evaluate this information before making a hiring decision. We're also proposing reiterating A05-14, require all 14 Code of Federal Regulations Part 121 air carrier operators to establish training programs for flight crew members who have demonstrated performance deficiencies or experienced failures in the training environment that would require a review of their whole performance history at the company and administer additional oversight and training to ensure that performance deficiencies are addressed and corrected. And finally, A0713, require that all pilot training programs be modified to contain modules that teach and emphasize monitoring skills and workload management and include opportunities to practice and demonstrate proficiency in these areas. Finally, staff are proposing that previously issued recommendations be reclassified in this report. Specifically, safety recommendations A0353 and 54 would be reclassified open unacceptable response.
Dr. Meyer, I apologize. I know this is the way that they're drafted in the report, but I'm thinking for the audience, they don't know what these recommendations are, and so maybe Mr. Marcus, if you could come up with what the actual text of these recommendations are while we do some business here, then we can actually read those out for the benefit of the public who's watching that doesn't have that information in a report in front of them. If that's all right, if there are any modifications to the recommendations, Member Simone.
Madam Chairman, I'd like to propose 2 new recommendations to the FAA. These have been handed out to my colleagues on the board and to staff. And so proposed 2 new recs to the FAA. Review the designs of airspeed indicator display systems on all aircraft certified under 14 CFR Part 25 and equipped with electronic flight instrument systems to ensure that they depict a yellow/amber cautionary band above the low speed cue and or the digits on the airspeed indicator change from white to amber/yellow as the speed approaches the low speed cue. And the next proposed addition would be for those airspeed indicator systems that lack the features specified in the recommendation just read, require that those systems be modified to be in compliance with FAA Advisory Circular 25-11A. And that is my motion, Madam Chairman.
Would you like to move both of them together or one at a time?
Your preference, Madam Chairman.
Let's do them one at a time in case there's some wordsmithing, then we can vote on each one.
Thank you. I move to adopt the, well, anyway, I'm proposing them one at a time.
Sure. I second the motions. Any discussion? Vice Chairman Hart?
No discussion.
Staff? Dr. Meyer, do you all need a couple minutes? Okay, why don't we also figure out what other changes we have so then we can take a complete timeout on all of the issues?
That one, specifically on those two, are all findings, are all recommendations
Yeah,
together?
let's go ahead and get them all out there so we can kind of address all of them. Are there any other recommendations proposed? Member Sumwalt, Vice Chairman Hart?
Yes, but I actually have a couple of questions first in order to know whether I'm going to propose anything else. On recommendations number 2 and 3, recommendation 2 talks about put out an advisory circular, and then recommendation 3 talks about require what's in the advisory circular. And since we know that requires requiring what's in the advisory circular requires a regulation, and so I'm wondering, was this intentional? This duplication, the idea being let's put out an advisory circular so we don't have to. So it's immediate, and we don't have to wait for the regulatory process, and if the regulatory process fails, then we still have the advisory circular. Is that the thought? Is that duplication intentional?
That is intentional on staff's behalf, not unlike what happened with CRM, where an advisory circular came out several years before rulemaking.
Okay. Next question is on recommendation number 9. Correction number 11 on page 266, line 17. Line 17 talks about stalls that are fully developed, semicolon, are unexpected, semicolon, and I think that's a great idea, but I wonder how do you, in the simulator session, create an unexpected stall? Is that realistic, or how do you do that? Or do we leave that to them to figure out how to do that and just put it in the recommendation? Because I don't frankly see how anybody who's on their game is going to be surprised by a stall in the simulator section.
May I address that?
Yes, please.
We already know that at least one operator is already doing this. They essentially take it away from the flying pilot as far as taking the initiative, and they have the instructor set the scenario up, not unlike an engine failure or a wind shear event. Naturally you can't say we're not going to have this event because it would be part of the training, but it's the way that it's approached and the manner in which it's approached that's really there. And the use of the term unexpected is a shorthand way of saying we don't want the pilot to do it himself as part of a pre-programmed type of exercise. That's really the meaning of it.
Okay, so rather than do a step-by-step, do this with the power, do this with the attitude, do this with the flaps, this with the landing gear, you would sort of almost eyes covered and then set up a scenario, okay, it's your airplane kind of thing? Is that what you're thinking?
Well, just based on my experience flying simulators, there's plenty of opportunities during a 4-hour simulator session to introduce a rapid reduction in airspeed. That can be done in most simulators at the volition of the instructor or the check airman. If the airplane is in a configuration that is reasonably close, you can wind the airspeed down in a hurry, cause that thing to happen, and have a reaction. But I think it's important to allow the operators to determine how exactly they want to go about doing this thing.
Yeah, I think it's a great idea. I just didn't know how you would do it in the real world to create an unexpected stall for somebody who's got their act together. Okay. Page 268, number 18. Line 14, routinely download and analyze all available sources. I know we stated that in the findings that all available sources would help, but if we're doing it as a recommendation, that's a pretty loose all available sources is pretty loose. I'm wondering, is there a way to tighten that up so it's not kind of an impossible recommendation?
We have Dr. Colley, who's an RE, and also Mr. Cash, if they'd like to address it.
That's called empowerment. I love it.
We have multiple things going on at once here. I think going back, I've got two thoughts here. But on all available sources, it was intentional to leave it that way. It's identical to what we did on the helicopter emergency services recommendation.
So did the contemplation include ATC data? Did it include service difficulty reports? Did it include, I mean, that's pretty loose. That's why, was that intentional?
It was intentional. We didn't want to limit it because it could be things that are developed in the future that we don't have yet, but it include video, audio, whatever there might be that the operator could have to put into the program that would be helpful.
Okay, well, that's all my questions. The only change I had to suggest was on that same page 268, recommendation number 16. And do you want me to tell what that is, what my suggestion for that is now? My suggestion was put 17 before 16, and then number 16 would be the same as it is now, except it would have the introductory phrase, if the FAA obtains the authority recommended in recommendation number, now 16. And that would be the introductory phrase to what would now be number 17.
Staff would be fine with that change.
Vice Chairman, I'm sorry, can you read, I know you're putting 17 before 16, and then on 16 you're saying if the FAA
obtains the authority recommended in recommendation number 16, I guess it would be now.
What if they don't?
Then I'm not in favor of mandating FOQA if they don't.
Is that staff's intention?
I think staff has no objection to that. We would suggest that number 16 be worded, I guess it would be a new number 17, but it would be worded once the specific statutory authority to protect data has been obtained, require all 14.
That's okay too. And as a footnote to that, I would say that I think it's very unrealistic to expect that 135 and 91K operators are going to start FOQA programs, but I don't have any objection to putting it in the recommendation.
Okay. Do we have additional proposals?
Madam Chairman, I have one question and one strikeout. So my question would be on recommendation 5. We talk about we want the air carriers to developing or identifying rest facilities for commuting pilots. I asked this question in my meeting with staff. When we say developing, because I know we're going to get a bunch of emails from the airline saying, do you expect us to start running a hotel or a dormitory or something? So what do we mean when we say developing rest facilities?
Once again, we left it fairly open that they can either go out like some carriers have done and actually created rest facilities, or they could find some other arrangements to make sure that the pilots had rest facilities. We just want the issue addressed, but we'll leave it kind of open as to how they get around to it.
Okay, when the people call me and send me email, I'm going to tell them that that's what our intent is. But we don't really necessarily expect them to go out and get in the hotel business. Is that correct?
Some may choose to do that.
Okay.
That they need to address the problem. How they do that, we'll let them do.
Thank you. Madam Chairman, I'd like to make a motion on recommendation 19, and I will read it. It currently says require 14 CFR Part 121 135 and 91K operators to incorporate explicit guidelines to pilots, including checklist reminders as appropriate, prohibiting the use of personal portable electronic devices on the flight deck. And my motion is that we scratch, including checklist reminders. That is my motion.
Second for the purposes of discussion.
Staff, do you have an opinion?
Staff appreciates the concept of cluttering a checklist with non-essential items. There are any number of ways. Staff's language was as appropriate, so if necessary, a company could choose to put it on a checklist or put it on a briefing card for a pre-flight briefing, crew briefing. Staff's intention is that this get addressed and get addressed up front, not put in a manual that is not reinforced on the line. Somehow what we would like is something that's oriented to pilots and reinforced.
Why do we think it's important to put it in the checklist? Do we think they're going to do it if it's not in the checklist?
The checklist is but one option that a company that we envision that it could take.
Does this company already have a prohibition against using cell phones while they push back from the gate?
Colgan did, yes.
Okay, and why didn't the crew follow it? Do you think they forgot?
The issue that staff observed was what happened in this accident. The guidance is there. It's not necessarily specific to pilots. We would like it more specific to pilots. We would like better reinforcement as far as its relationship to the sterile cockpit rule 121.542 and the FAA SAFO. Although it wasn't an intended action, it was an observation made and part of the description of the event that inspector noted that it was an item that was not in the company's checklist procedures.
Yes, but I want to go back to what I did say. I said this earlier, but when I asked this question and expressed my concern about this verbiage when I met with staff, I was told that this was the language that the SAFO incorporated, but again, when I went back and looked at the SAFO, it wasn't concerning the flight deck checklist, it was concerning the jump seat checklist. So it doesn't say that. It doesn't say flight deck. The SAFO doesn't refer to flight deck checklist. It says check and make sure that appropriate procedures are in place to remind crew members to turn off their cellular phones in preparation for departure. Then it gets into jump seat checklist. So that's my motion.
Member Somewhat, can you just explain to me what your heartburn is? I'm sorry, I'm just getting confused about the jump seat checklist. Don't we want crews, regardless of whether or not someone's in the jump seat, not to be using personal devices or have them on so that they might ring as a distraction during a critical phase of flight? Yes,
and the point's well taken there that we don't want a distraction, and certainly we have more. Back when I was flying, we didn't have things like BlackBerries, and there's a proliferation of these things, and I do agree with that. I think that the checklist needs to be related to those items that are related to flying the aircraft. We don't say things like make a PA announcement to the passengers. We don't say things like personal in nature, like go and eat some lunch. We try to keep the checklist uncluttered, and as somebody who has worked on developing procedures, I think it's important that we maintain that. But that's my motion, and I'm just stating my feelings.
Technology is friend and foe sometimes. I received an email of someone who's watching the board meeting who is a chief instructor at a regional airline, and he commented on this discussion that we had earlier. He said there's always a fine balance between micromanaging a crew and compliance with procedures. If we over-proceduralize our requirements, we move away from 100% compliance. On the other hand, if we have no procedures, we have no standardization. So a balance is needed, and although it pains me to have to add cell phones to the checklist, it seems like a simple thing to do to retain the needed discipline. I believe that the proliferation of devices and not recognizing what the next generation is going to be is critical. We've already seen two incidents or accidents where we know that crews are violating company procedures. I think that as we've been very firm about sterile cockpit compliance and not tolerating any deviations, minor or otherwise, I think we need to take a hard stand in the aviation industry, just as we've done in other modes, about no personal electronic devices while you're operating. It's pretty straightforward and it's simple, and I think if we found it in 2 events in the last year, it's likely that it's probably a little bit more widespread not being addressed. I would say if you're a captain and you have a first officer who might be using something, it's one cue, it's one way for you to say, it's time to put that away now. Turn it off, put it away, and help enforce some discipline in the cockpit.
Looks like it's my turn again. I think that to the extent it's a safety of flight item, and I can easily envision situations in which that's the case, I think that a checklist is an appropriate place to put it.
Call for the question.
Okay, call the question. We actually have several amendments that we haven't voted on. We've got to get back to them, but Member Sumwalt's called the question. All in favor of the proposed modification, signal with a hand and aye. Aye. Those opposed, nay. The nays have it. The motion does not carry. Are there any other amendments? We need to kind of get back to the staff on some pending.
Yes, Vice Chairman Hart, Member Sumwalt had proposed 2 safety recommendations that we have been working on a little bit as we've been progressing, and Mr. Howder is prepared to suggest an alternative that would combine them into one that we think still preserves the meaning of what Member Sumwalt was trying to do. Thank you.
Okay, and we have some other pending, correct, from the Vice Chairman. Are we still working on those, or are we getting there?
I think they already accepted the one that I proposed.
Yeah, I think we took care of it.
They might have accepted the language, but we didn't vote on the change.
No, you're right. We'd have to vote on it. I'm just saying they already said it was okay with them.
But you have not taken the formal vote on 1617 yet.
All right. Well, I guess I'm surprised that staff has accepted 1617 as written. And doesn't this gut the mandatory on FOQA? Aren't we giving ourselves aren't we basically saying if they don't get this approval, then we're not going to pursue, we don't want them to pursue the mandatory? Is that the position that staff's taking?
Yeah. It's a very fine line, and we understand the Vice Chairman's concern that without protections, it's very unlikely that operators will do it. And so we see the concern there. We need the protections. If we just say require, I doubt that it will happen.
You okay with this? You're okay? You're okay with this?
Okay, and so I want to hear the front part of 16, which becomes 17 again. It's once the FAA. Mr. Halbert, do you have that verbiage?
The front-end words that I had written down were once the specific statutory or regulatory authority to protect data has been obtained, require all 14 Code of Federal Regulations, Part 121, et cetera.
All right, so the FAA can basically say to us, as I've heard them say recently in a meeting, we don't have the authority to ask for anything. And then this is done. We go down on both of them.
I think we could actually propose a slight alternative to that might cure that problem. We could accept the Vice Chairman's amendment in a slightly different way. We could split recommendation 16 into 2 different recommendations so that the first one would read, require all 14 Code of Federal Regulations, Part 121, 135, and 91K operators to 1, develop and implement flight operational quality assurance programs that collect objective flight data. 2, analyze these data and implement corrective actions to identified system safety issues. And then a new recommendation: once the specific statutory or regulatory authority to protect data has been obtained, share the de-identified aggregate data generated through these analyses with other interested parties in the aviation industry, including the Federal Aviation Administration, through appropriate means.
Yeah, I just, I think if we predicate everything on FAA seeking authority, they're going to come right back to us within 90 days and say, we don't have the authority, and then this whole thing just goes down. Our point was, we asked you to encourage it years ago. Nothing really has changed with respect to regional carriers. We are trying to change the paradigm and say, we really want you to do this. We're serious about it. Mandate it. And you know what? If they don't want to mandate it or don't think people will participate in it because it's mandated, then it's incumbent on them to come back to us with an alternative, to show us how they are getting more people into the FOQA program. They have not shown us that. I think that's the problem, is, what pressure results in change. And I think if we totally let them have a pass on this to say, seek the authority, and then if you get the authority, we were in a meeting with senior officials at FAA. They explicitly told us, we don't have the authority to ask Congress to give us things. I would not be satisfied if that was the response that came back. That would not advance this issue one iota.
I think what Dr. Meyer just presented is a fairly good concept to require basically number 1 and 2. That would require an airline to develop a FOQA program. It's the sharing of data with the FAA that becomes the issue in terms of FOIA and things like that. So at least you require the operators to develop the FOQA programs.
Okay, is there any further discussion? It looks like Ms. Weinstein is at the table now. Yeah. Sorry, are you all ready?
I think we're ready. I'm
okay. Did Ms. Weinstein have an amendment? Are you guys changing the?
No. But we'd be happy to try to further explain it if we haven't done an adequate job of that.
I think you've done a good job, but I think that what's going on right now is we're fatigued, and I think that there's some decisions that are being made. Tactical decision errors that are going on right now. Judgment is going. I think we've got get-there-itis, and we're starting to shed stuff left and right that we had firm stances on before. And so I want to make sure that we're going into this knowing exactly what we're doing, because once these recommendations are adopted, that's what we got.
I agree it's a challenge. I think that the staff are not intending to back off from the position that mandatory FOQA programs are necessary. But we also are not intending to back off from the issue that there is a need for the ability to protect data that is shared with the FAA from public disclosure. Okay. And that only gets into that point 3 in the currently drafted recommendation 16. And that's why it seemed attractive to us to split those two up such that we would be asking the FAA to mandate the first 2 points, developing a FOQA program and analyzing the data within the airline, and then share the data with the FAA once the specific protection is available.
Okay, so Probably the easier thing than to have all these different 3 recommendations is to take 3 and append it to the end of 17, correct? You're telling them to seek the authority for this and then share it, right?
Yeah, that would
All
definitely
right,
work.
we need to figure out what the amendments are and offer them.
I would note that the sharing is not a problem until they're sharing it with the FAA. Sharing with each other is not a problem. That doesn't require, sharing with each other does not require the statutory regulatory authority. It's only the sharing with the FAA that requires that authority. So they could still do the sharing with each other even without that authority.
Which would have value, because if there's one set of carriers with a Q400 fleet and another set of carriers, they could actually get benefit by working together.
Correct.
Yes. Okay.
All right, I believe we have it properly now. Recommendation 16 would read as written, except we would propose striking the words, including the Federal Aviation Administration. And then recommendation 17 would read, seek specific statutory and/or regulatory authority to protect data that operators are required to share as part of their flight operational quality assurance programs, and require carriers to share data with the FAA. And then require carriers to share the de-identified aggregate data generated with the FAA.
Wouldn't it be easier just to say seek specific statutory and/or regulatory authority to protect data that operators share with the FAA as part of their flight operational quality assurance programs?
If we did that, then I think we would suggest leaving, including the FAA in recommendation 16. No? All right.
No, I think we still want to take it out because that's the part that gets us into trouble. I think the required part we want to get out is 17 and just say the ones that the data that they share with FAA. And then we're not moving this. We're not. Right.
But it's the same idea, though.
I really thought we weren't going to need a break while we were adopting these things, but if this goes on any longer, I promise to give everyone a break.
I believe we are. I'm hearing staff behind me request that we read it clearly to make sure that we all know what we're talking about. So the original 16, we are going to strike on line 8, including the Federal Aviation Administration. Everything else remains the same. On 17, it's going to read as follows, or we suggest it reads as follows: seek specific statutory and/or regulatory authority to protect data that operators share with the FAA as part of any flight operational quality assurance program.
Vice Chairman, are you comfortable with the revisions?
That's affirmative.
Okay. Would we like to call the question on the revised 1617?
Yes.
All in favor of the revisions as proposed by Mr. Halbert, signal with a hand and aye.
Aye.
All The ayes have it. The amendments have been adopted. Vice Chairman. Member Sumwalt has some pending amendments at the desk, and staff, are you ready with your revisions?
Yes, we are. We've combined the two. The recommendation would now read, require that airspeed indicator display systems on all aircraft certified under 14 Code of Federal Regulations, Part 25, and equipped with electronic flight instrumentation systems depict a yellow/amber cautionary band above the low speed Q, or the digits on the airspeed indicator change from white to amber/yellow as the airspeed approaches the low speed Q, to be modified in compliance with FAA Advisory Circular 25-11A.
How does it start out? It eliminates the review?
This is require that. Instead of doing the review, we're going right to require, and to be modified.
It's kind of funny because that's where we started out yesterday.
Yeah, it is.
Okay.
Okay, so we don't have two separate amendments. We have a single amendment that combines both. Member Sumwalt, are you comfortable with that?
Okay, so let me make sure. We will scratch the words in the draft. The draft get rid of the words review the, and it will now start require that.
Yeah, require that airspeed indicator display systems.
Okay. What else has changed in that original part?
We got rid of the and instead of, it's just or instead of just and or.
The last one.
Okay, so it just says either have the yellow/amber cautionary band, or
the digits.
Okay, I'm happy with that. Now the rest of that, I mean,
down at the bottom it goes from low speed Q, be in compliance with FAA Advisory Circular 25-11A.
Okay, Madam Chairman, I'd like to ask that Mr. Howder reread the entire thing. In it, the thing in entirety, and then I'll be satisfied.
Can I just ask a procedural question? Are you do they have to comply with the advisory circulars? Wouldn't it be consistent with an AC since it's an advisory? There's no compliance requirements, right? They don't have to do what's in the AC. Is that correct?
I believe they do. I'm not sure.
It's my understanding with certification, if you use the AC, you have to use all of the AC. You don't have to use it, but you have to be very careful in documenting your alternate means of compliance. But if we just want to say consistent with, that would be okay with me.
It's okay. I think it's the advisory part of the advisory circular that's throwing me. Is it because the Q400 was certified before the advisory circular was put out that they are not complying with it?
Well, the AC was not issued until June of 2 years ago, so that would be yes.
And nothing existed before that.
Well, plus even if it predated the airplane, they still wouldn't have to do it. It's just because it's just an AC.
I think that's my point.
Well, again,
do they have to do it?
No, that's what this would do. Is require them to do it the way the AC suggests. That's what this recommendation would do now.
Okay. I'm good. Call the question on the drafter. You want Mr. Howder to read it one more time?
Please.
Okay.
Or change it slightly. Require that airspeed indicator display systems in all aircraft certified under 14 Code of Federal Regulations, Part 25, and equipped with electronic flight instrumentation systems depict a yellow/amber cautionary band above the low speed Q, or the digits on the airspeed indicator change from white to amber/yellow as the speed approaches the low speed Q, consistent with FAA Advisory Circular 25-11A.
Madam Chairman, I'm satisfied with that verbiage, and if I have, I don't know if I need a second to that amendment.
Second.
But I'd call for the question.
All in favor signal with a hand and aye.
Aye.
The ayes have it. The motion is adopted. Any additional changes from my colleagues on the recommendations? We have one more modification that we need on the oral. I wonder if staff would like to read the revisions to the recommendation. I believe there's a new recommendation, and we are superseding or closing some other recommendations. Ms. Ward, do you want to read those on behalf? Oh, I can do it.
I don't have it.
Okay.
We are speaking about the existing recommendations that will be reclassified.
Yes, I'll go ahead and I move that we adopt the following recommendation. The NTSB recommends that for all airplanes engaged in commercial operations under 14 CFR Parts 121, 135, 91K, the FAA require the installation of low-speed alert systems that provide pilots with redundant oral and visual warnings of an impending hazardous low-speed condition. And then we're going to, because of the FAA's inactivity with regard to recommendations A03, 53, and 54, we will then classify those recommendations closed, unacceptable action, superseded. Do I have a second?
I second both of those recommendations. I second the motion.
Any discussion?
I didn't understand the first part of it. Were you reading from an existing recommendation? Or?
Yes, this is the draft that staff provided to us on low-speed alert systems. We adopted a conclusion earlier, and we have a recommendation to support that conclusion, requiring the installation of low-speed alert systems that provide pilots with redundant oral and visual warnings of an impending hazardous low-speed condition. Staff, do you support this language that you proposed?
Yes, we do.
Any discussion? Call the question. All in favor of the proposed amendment, signal with the hand and aye.
Aye.
Aye. The ayes have it. The amendment has been adopted, and the former recommendations have been closed and superseded. Any additional changes to the recommendations?
No, nothing from staff. When you are ready, I think Mr. Marcus is prepared to read the previously issued recommendations that we would reclassify in this report to be
Thank
sure
you very much. I'm not sure there's going to be anybody left by the time we get to that point, but if they are, we want to make sure they know what they are. Thank you. Dr. Meyer or Mr. Marcus, would you like to read them?
Do you want me to read A03, 53, and 54, the low-speed alert that we just closed?
Sure, go ahead, and I think we have some proposed reclassifications, and so let's go ahead and read that entire section.
Safety recommendation A03, 53 was closed, unacceptable, superseded. Safety recommendation A03, 53 is convene a panel of aircraft design, aviation operations, and aviation human factors specialists, including representatives from the National Aeronautics and Space Administration, to determine whether a requirement for the installation of low airspeed alert systems in airplanes engaged in commercial operations under 14 Code of Federal Regulations, Parts 121 and 135, would be feasible, and submit a report of the panel's findings. Safety recommendation A0354 was if the panel requested in safety recommendation A0353 determines that a requirement for the installation of low airspeed alert systems in airplanes engaged in commercial operations under 14 Code of Federal Regulations, Parts 121 and 135 is feasible, establish requirements for low airspeed alert systems based on the findings of this panel. Safety recommendation A0713 will be classified open, unacceptable response. Safety recommendation A0713 is require that all pilot training programs be modified to contain modules that teach and emphasize monitoring skills and workload management, and include opportunities to practice and demonstrate proficiency in these areas. Safety recommendation A0708 is classified to be closed, unacceptable, superseded. Safety recommendation A0708 is work with pilot associations to develop a specific program of education for air carrier pilots that addresses professional standards and their role in ensuring safety of flight. The program should include associated guidance, information, and references to recent accidents involving pilots acting unprofessionally or not following standard operating procedures. Next, we have safety recommendation A0514, which is proposed to be reclassified open unacceptable. My mistake. Safety recommendation A05-1 is proposed to be classified open unacceptable response. Safety recommendation A05-1 is require all Part 121 and 135 air carriers to obtain any notices of disapproval for flight checks, for certificates and ratings for all pilot applicants, and evaluate this information before making a hiring decision. And then safety recommendation A0704 is proposed to be reclassified closed unacceptable action superseded. Safety recommendation A0704 is convene a multidisciplinary panel of operational training and human factors specialists to study and submit a report on methods to improve flight crew familiarity with and response to stick pusher systems, and if warranted, establish training requirements for stick pusher equipped airplanes based on the findings of this panel.
Is there a motion to adopt the recommendations as revised?
I will.
I'm sorry, is there a motion? We can adopt all of the recommendations, correct?
Yeah. Yes, and can I have one procedural matter?
Yes.
That the board has just superseded A03, 53, and 54 as closed unacceptable action. So the new recommendation for the new airspeed alerter system, low airspeed alerter system, the board can choose to carry that over in an unacceptable status if you wish to.
I wish to. How do the other board members feel? We've asked them to do it for over 6 years. They haven't done it. We're asking them to keep looking at it. I don't think we should give them a free pass and say you get to start over just because you didn't respond to us in the last 6 years.
Yes, I agree with that, but wouldn't it actually be in some form or fashion we're going to close out A03, 53, and 54, and it would be something superseded, is that correct?
That was we voted on that when I offered my amendment to adopt the new recommendation on the orals,
okay.
and we superseded the others and closed them.
So it's already been
closed unacceptable.
Thank you.
Do I need a second to have the new classification, or does that just go?
The suggestion is that you go ahead and vote on it.
Okay. Can I get a second for the motion to retain the unacceptable classification?
Second.
All in favor signal with a hand and aye. Aye. Mr. Halbert, at this point we can adopt all of the recommendations as revised, correct?
As revised.
Okay. Any other further discussion on recs? Is there a motion to adopt all the recs as revised?
So moved. Second.
All in favor signal with a hand and aye. 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 The ayes have it. All of the recommendations have been adopted. We will now vote on adopting the report in whole unless anybody would like to have further discussion. Is there a motion to adopt the report as revised?
So moved.
All in favor? Aye.
Aye.
Aye. The ayes have it. The report has been adopted. Are there any members interested in filing concurring or dissenting statements? I'll reserve my right on a concurring.
I'll reserve my right to file a concurring.
You want to join us?
Yes. Me too.
We're all in. Mr. Halbert, so noted?
So noted. Thank you.
Well, I have to make the comment, Mr. Howder. Clearly, you and I don't strike fear into the hearts of our team. We both lost today, So I think the lesson from that is we are captains who have very assertive first officers, and they don't hesitate to challenge us when they disagree with us. And I think that that's a good news story for the Safety Board, that our investigators, our board members, all of us are independent, and we call it like we see it, and we do our jobs. And so I don't know if you want to comment to your staff.
No, I agree completely, but I believe we gained a lot more than we lost today by quite a margin, and I'm very pleased with all the work that folks put into it. It took an incredible effort to produce this report. And
You pull that microphone closer to you so people can hear it.
That's it. Once again, point out that we gained a lot more than we lost today. I lost one issue, but we gained a lot more. Staff put in an incredible effort on this. I'm pleased with them all. It was an amazing thing to put together the way we did. Very proud.
I don't think there are any losers. I think the traveling public will be the beneficiary of this meeting. And as we all said at the beginning of the meeting, we are deeply sorry of the events that happened on February the 12th. And so we will take this tragedy, and we will triumph from it. Thank you, and God bless you.
And I would like to add kudos to the staff who brought us to this result with an amazing result in an amazing period of time. Thank you.
I believe this brings us to the end of our deliberations on the accident report. Our investigation, I think, has the potential to refocus the FAA and the industry's attention on many issues that the Safety Board has raised over the last several years. Issues like flight crew monitoring, pilot performance, sterile cockpit, fatigue, training, record keeping, use of personal electronic devices, and safety alerts. These are critical issues that require the attention and the action of the FAA and the industry. The tragedy in this report is that what we uncovered in this investigation we already knew. Many of the issues in this report are not new to the Safety Board. We've seen similar issues in other investigations, like the Air Sunshine accident where we had multiple test failures. This report raises serious questions about the effectiveness and oversight of pilot training. It's disturbing to hear of the numerous times that the captain failed only to be passed along in his career. In many respects, I feel that this is like a student that was getting passed from grade to grade and at the time of graduation never truly mastered the subject matter. And there are other accidents in which the board has cited pilot professionalism, sterile cockpit violations, and training. In 2004 in Jefferson City, 2 pilots with no passengers on board flew a flight to flight level 410. They mishandled the stall recovery, lost both engines, and crashed. The cause was unprofessionalism and a lack of airmanship skills, which resulted in an in-flight emergency from which the pilots could not recover. In 2006, an American Eagle plane experienced a similar stall, this time over California, after the crew let the aircraft, the speed decay, and in this case, fortunately, the crew was able to recover. Again, pilot professionalism and training were the issues there. We've cited pilot fatigue in numerous accidents. For years, many of these issues have been highlighted on our most wanted list and in our safety recommendations. The issues that we have seen in this accident are not limited to Colgan or the regional airline industry, but they are occurring in all segments of the aviation industry. And that's why many of our recommendations are addressed to all air carriers, major carriers, and their regional partners. In the wake of this tragedy and prompted by issues raised in our public hearing and hearings in the Congress, the FAA responded with its safety call to action, a plan that asked the aviation industry, from major air carriers, their regional partners, industry groups, and labor, to improve safety standards. While this call to action is an important start, we need fewer listening sessions and more continuous and persistent action if we're serious about crossing the finish line on these issues. If we want pilots to be better at monitoring, we have to revise the procedures and the training to promote this. If we want to address how much rest pilots get, we have to address hours of service and fatigue and commuting. If we want pilots to be at the top of their game, we need to adequately train them. If we want to raise the bar on safety, we can't simply require industry to meet the minimums or the floor. And the fact of the matter is, if the FAA and the industry don't take corrective action, perhaps the Congress will. Both the House and the Senate are considering bills that impose tough safety standards. Many of the family members here today have been advocating for such measures. In fact, this Thursday, the House Transportation and Infrastructure Committee will hold yet another hearing, this one to examine the FAA's call to action. And I know the family members are going to be there to hold their feet to the fire. Today's aviation industry is safe. The skies and the airplanes in which we ride are safe. But just because the airplanes are safe and the industry is complying with FAA regulations does not mean that we're doing enough. The absolute minimum cannot be our finish line. That's why the Safety Board's work on these issues does not end with this report. Through this investigation and report, our investigators sifted through a lot of information, and you got to hear about some of it today. We issued over 20 recommendations in our report to prevent a similar accident from occurring. In the coming months, the Safety Board staff will continue to dig deeper into other issues like code sharing and pilot and controller excellence. These issues are bigger than this accident, with far-reaching implications for the aviation industry. If there's one thing that we take away from this accident, it's that history repeats itself. We must take swift and effective action on these recommendations. If the aviation community does not take them to heart, then we're destined to revisit them again. It should not take another 50 lives to gather the sense of urgency and the will to do it. This meeting is now adjourned.